Probably. And once again, finally, we're here. I'm not sure if you can hear me, so let me know in the chat if you can hear me. And I'm going to welcome you at this React.js case study festival from Geekle. No sound. I see no sound. Yeah, now sound is okay. Yeah. People, hello everyone. I'm so happy you are with us. So many people connected today to see and hear and communicate and share their knowledge. Thank you very much. I'm Ed. I'm from Geekle, and this is our second event about React. Well, few words actually while our technical team doing their preparation. Few words about these events and the idea of Geekle, what we're doing almost for a year. This May we will celebrating our first anniversary, first year. All this year we was working to deliver top content from the very famous people, from people who we find in different companies. Some companies are really with the huge branding, some unknown brand company, but what we was looking for is really great engineering ideas. We was looking for people who knows something about React and other technologies, not just something, but something to share, to push you and like help you grow. So right now we're in Kiev, Ukraine, and I would like to know where I am from. Could you please type in the chat where you now and how are you and how is weather there and all this stuff. Yeah, we have these features scan to share your location. That's idea of our community managers to once you scan it and point your location, we will share the map where our attendees are situated. So what's new in this event? First of all is as usually we have, wait a minute, Philippines, Istanbul, Hungary, Belgium, India, Romania, hi from Finland, snow has finally melted. Yeah, Australia. No, you not missed anything. He said he's late. Yeah, Latvia, from all over the world. I see from different countries. How that's it. Greece. Hello from Greece. Nepal. Hello from Nepal to everybody. Yeah, thanks, people. So as always, we have two tracks. First track is for juniors or for beginners. If you are something like less than 1 year in JavaScript using React, this track is for you. Just join it, and it's for free because our mission is to find really top speakers and deliver to developers in any country, even any villages, because top speakers when it was time when we had offline meetings was available only on huge conferences. It's quite expensive, and you have to work on large company and they will pay for it and all this stuff. And today at the COVID time, our mission is to deliver really best speakers to anyone who wants to know something about these technologies. And can you imagine almost 9,000 registrations on this specific event we got from all over the world. 9,000, and 98% of all these people are free users. So these people will join us or watch later this content. It's for free. And I also appreciate to people who paid and company who paid for paid track, because this is the way you support us. We don't have much sponsors. We have some, but it doesn't cover even half of our expenses. Thank you very much. Your dollars, your payments, or any other currency are supporting us, and we appreciate for what you're doing and helping us. So the last stuff I want to share is about workshops. When last year, when we was doing this event, we promised workshops. We didn't manage that year to make any workshops, and I want to apologize about that. But this year you can join our workshops. You can find it on our web page, or speakers who are doing these workshops, they can share with you, so you can hear them and join these workshops. What else? Probably no more chatting. Probably let's move to the point why we are all here. I want to introduce Mr. Javier, and he will moderate in this event, and also Nir. They will moderate in it for like few hours probably. Hello, Javier.
Yeah, hi, Ed. Thanks a lot for the warm welcome, and really, it's a great thing that you're doing this, and you have given me a chance to moderate this event. I'm looking forward to this, and I assure all the people in the audience this is going to be great. I'm very excited. I have gone through the abstract of all the talks, all the sessions. I have had a word with a couple of speakers as well, so I'm very excited.
Yeah. Great. It's an honor for us to have you here with us. And where are you now?
So I am basically located from Pune, India. I see a couple of folks from India as well. So it's nice.
Lots of Indian developers joined us. Yes.
Yeah.
Well, thank you for contributing here. Thanks for being with us. Okay, I guess floor is yours. And but we our technicians say they need few minutes. Really? Oh yeah. So few minutes, and we will get back to this stream. And also, unfortunately, technically, I cannot greet in person another our moderator. But I'm so happy you are with us here. Thank you very much. And we take few minutes to get back. Thank you.
So hi everyone again, and this is Bhavya Mehta here. Like I just gave a small introduction. I'm from Pune, India, and the weather here it's pretty dull right now. It's raining, and I don't know why. Suddenly it started raining today. But yeah, apart from that, I have been working as a front-end engineer from around 3-4 years now, and I love technology. I love React. I have been working and learning about it. This seminar, these talks, these conferences just help all of us as junior developers to really grow and get better at this. So I've got some snacks. I've got some water for me over here because it's going to be 2.5 hours of talks and free talks, and then will not have a break. So I would suggest you all do the same. And then our first session is about how do we boost our performance for all our apps, which I feel is of utmost importance right now because nobody likes slow or apps which just don't load up. So yeah, that's what we'll be having in the first session. I'm hoping that all of y'all are safe, all of y'all are doing good, and at the same time, the environment and everything wherever you're located is really nice. Get a comfortable, cozy place for yourselves. And I would also urge you all to, if you'll have questions, if you'll have something to discuss, please feel free to put it into the comments. You can also ask all your questions in the Q&A time. But apart from that, you can also do that. Like you could just post a question and keep all your questions and doubts ready, so we can ask the speakers whenever they have time between the talks as well. That's something. Again, about the QR code, it would be somewhere here up. I'll just add it again. This is just a small thing that we are doing. It is going to be really amazing. We are going to make a world map wherein every pin would represent our attendees from different locations, different corners of the world. So it's really great to have that visualization, and it's going to be amazing. So please do that. I request you all to do that. And yeah, so all good. We are ready to start. So I'll just introduce our speaker one. Let me just get him on stage. I'll just have to remove this. So yeah, hi Aman, great to have you here. Just a small introduction first before you say hi to everyone. So our first speaker, like I told you for the day, is Aman Sharma. He will be presenting a talk today on making web more native. So if you all have already heard about PWAs, if you all already have heard about how powerful they are, how a lot of companies are moving to it. So that's what we are going to, that's what Aman is going to talk about, and we are going to learn from him. To tell you more about Aman, he's a co-founder. He's also a CTO, and he works at a company called twinbit.com. He's also the community lead at mobileweb.dev. He generally loves to speak and write about AMPs, about PWAs, about web, cloud, MLAI, WordPress, and the list goes on and on. His goal is to create an awesome product experience for both the web and the mobile. And if this is not enough, we'll just hear more from Aman himself. So over to you, Aman. Looking forward to the talk, and all the best. I'm just a text away if you need anything. Thank you. Aman, sorry, we can't really hear you. Aman, can you hear me? Aman, sorry to stop you. We can't really hear you. Others can hear him. Not yet. Yeah, probably the audience also can't hear you. So could you just check?
How about now?
Yeah, perfect. Yeah, over to you, Aman. Yeah.
Really a bummer. I thought you guys could lip read for the whole talk, but I don't think that would be very much possible. Hello, everyone, again. And that's where I started with the kind of hi, hello, wherever you are joining from. This is a really tough time for India, and I want all of you to pray for not just my family, but everybody's family. It's a tough time, and what humanity has taught us that this time has taught us that humanity has to make its unity vision more clearer than competing and succeeding over one another. So I wanted to put forward this message that be patient, be kind, be humane to everybody around, and help as much as possible. With that, I am here to help you with a very amazing concept that I'm going to talk about. And I'm very honored to have the first talk and the first stage for React.js case study. The title of my talk is Making Web More Native. And I would request Bhavya to, if he can share my screen presentation on the page. And well, let me give you a little bit of introduction while we do it, what we actually going to talk about. So I got to know about this conference like past 3 months ago, and the team Geekle has been very supportive about new ideas, new experiments that we speakers always want to do, and that's what we enjoy in the tech community. But what I actually wanted to explore was a new kind of method, a new kind of way where I can tell developers that something new, something which hasn't been too much practiced, and it's really new in terms of technology also. And one distinction that I really found, that the way web and native apps are converging towards each other. Web apps are trying to become as much as native as possible, and native apps are trying to become as much as interactive as web, as open as web. So I think there is a point, an epitome where these both things converge, and that's what exactly we are going to talk about today. We'll be preferring more on the web side, and it's not going to be React all the way, but we'll be adding components from different web APIs, Chrome APIs, PW APIs. We'll talk about React.js code base also a little bit, but the main theme will be how you can make your web apps more look like native apps. So that put forward, let me actually start with a little introduction about me. My name is Aman Sharma, and as Bhavya introduced me, I am co-founder and chief technology officer at Koehmstedt. Koehmstedt is a Singapore-based research company. We are trying to create a new community, a new open source platform for research, where anybody can discover any research insights and experts can portray their thought leadership at a single place. We are trying to create a platform where we can connect experts from different domains and people like us who are very interested in finding new insights for their startups, for their college projects, for their business, for making decisions. So check out twimber.com for that. Apart from there, I'm also an open source community evangelist. I work with different open source organizations like AMP, Chrome Labs, Indian Web Community, and Mobile Web Dev is a community that I myself founded, and I'm also a lead at there. And apart from there, I'm an entrepreneur. I love mentoring students, and also I love advising startups. I'm onboarded as a startup advisor to various startups. If you want to connect and talk more about the stuff that I do, make sure you connect with me on Twitter, Instagram, or LinkedIn using the handle Aman. And you can see the nerdy stuff I'm into, so I won't actually bore you or kind of flatter myself more on these things, but you can see how much nerdy I am. I'm really sorry I'm not having any other talents than this, and this is like my bread and butter now. So with this, let's see what we are going to cover in this today's presentation. So basically the whole talk is divided into four main sections. The why part, why actually we are talking about what we are going to talk, and why the strategies that I'm going to discuss are important. Then we are going to talk about the process involved in making sure what I'm talking about, how you can actually execute it. We are going to see an approach. But well, before that, let me wear my nerdy glasses so that I can see clearly and also look cool. So the third one is approach. So how you can actually start diving into it and how developers can adopt these methodologies. And finally, a follow-up of how some of the conclusions, some of the things that I have missed in the other sections. And I'm really a little bit of nervous right now because this is a new kind of format. So pardon me if I'm not 100% with the flow. So I want to start with the dilemma that always people have. Like you want to launch your web app or mobile app, and you are always confused with it. And the dilemma is basically about your digital positioning. Should you go using web sites, or should you go with native apps? Because website provide you more coverage and more reach, but on the other hand, native apps have more features, more performance, and it's more intuitive. On the downside, the plus points of both of these things act as negative points as well. Web is light to bake and it's also agile, but at the same time, native apps take huge times of development cycle, huge updates needs to be built, and people need to manually install these updates. And also the installation hurdle that people have. Sometimes you are not signed in with Google Play Store, or you are using an operating system that doesn't support that native app. So the implementation of this business logic always becomes stuck. Well, if that was the case, this conversation was already ripped apart and we wouldn't be talking about this today. But why we are actually here is to see a new strategy where we can combine both of these strategies, combine the goodness of web apps and native apps, and also some of the functionalities from the cross-platform environment, whether it's be desktop applications or Chrome OS applications, of how we can combine the goodness of all these things and merge them into one single thing that is called PWA. When I got to know first about PWA, I was so mind blown that, how cool it is that you can have the capabilities of native apps while having the reach of web apps. And that's what progressive web apps actually stands for. So you're progressing a normal website into a native apps. That's why the name progressive web apps comes into picture. To start with, the whole life cycle of transformation of your normal websites to a native apps is divided into 4 main parts. And the first step, of course, begin with making sure that your website already is performing in terms of aesthetically, as a, what do you say, in terms of mobile responsiveness or single page experience, like SPA frameworks, like if you can use React state management or React routing or different SPA frameworks that you want to use. And also these web pages are already performant. They are providing as near experience as a native app inside the browser. There are not huge load delays, and the content is client side rendered instead of server side rendered. So with that cycle covered up, we'll not be going through that part because you guys are already very professional at creating websites. We'll be jumping into the second section, that is how to create a basic PWA. And the main things that are involved in creation of basic PWA is the manifest file and the service worker file. So let's dive directly into it. And the whole process of creating a simple PWA is actually divided into just 4 steps. The first step is enable HTTPS, which I think almost everybody is used today. So actually issuing yourself a wildcard or a free SSL certificate is also totally fine. It's just to make sure that some of the APIs that PWA will use over the time, it requires a secure encrypted access. So make sure that your website is HTTPS first. The second section is to create and set up a manifest file. So what do you need to do? You need to create a JSON file like this one, in which you will write the name of your app and different icons that you want to use, the start URL of your app, what background color, other theme scoping, and all this. So this is a standard layout of what things you should include in creating a standard PWA. And then you will add a link between this file and your actual index.html file. So whatever the index.html launching file you have for your application, just add this line so that the browser knows what file it needs to read to recognize that your application is actually a PWA. The third most important step is to configure and set up a service worker. You can simply start with the service worker, but wait, let's first understand what actually a service worker does. So basically a service worker is nothing but a bunch of JavaScript code. And what it is actually doing is that it's trying to intercept every network request and trying to define if it should fetch it from an actual server or should it return the results from cache. And this is very much helpful when you are trying to run your application offline. So one of the main aspect of a native app is when it makes a network call, it caches all the content offline on the device. And this is done using the native APIs. But on PWA, we will use service worker to do the same functionalities. More about service worker in the upcoming slides. And the last step is testing your PWA. For testing your PWA, there is no better tool than using Chrome and the built-in Lighthouse functionality. It tells you about different things that you can improve to make your PWA even better. To tear down into a more, granular manner, these are the different sections that we just discussed. The first one was the manifest, which defines the prompt, display mode, different things that are more aesthetics about your progressive web app. The second section is the front end, which is the actual client-side code which users interact with. Then we talked about service worker, which is basically the caching logic and how you are going to deliver the content to the users. And then finally, the API, how your app or the PWA interacts with various operating system or hardware capabilities. And also, if you want to add some extra functionalities like access to gyro sensor or accelerometer, you can use the hardware sensor API as well. Then you have cache, which actually stores the content for offline, and background sync, which periodically checks the content from your main server to feed it directly to the users. So to define it into a more dominant way, like how you can actually execute in a real world scenario, we'll go to the step 3, which is adding more functionalities. All of what we discussed in our previous slide, we'll try to conquer this one by one, and I'll be introducing you some more new techniques and new APIs that you can use to incorporate these functionalities into your own PWA. So after the second part is done, you have created your normal functioning PWA with a simple service worker which just serves and caches few of the files. You are going ahead with the third step, that is adding more functionality. elements. And for this, the whole approach is divided into these parts. We'll be talking about the placement, how you can place your PWA, how you can make your PWA immersive, how you can control the different activity side of your app, and how you can access different APIs, and finally, how you can make your PWA offline. So these are the different approach, and we'll be going into one by one to discover more about them. The first one, placement. Placement is how people discover your PWA. Whenever somebody visits your URL, which is probably through maybe social media share or Google search, how you can prompt the user to actually navigate and discover the content in your PWA and even install your PWA. So this is our first section. PWA installation works using prompts. You will see these prompts like plus install button on desktop browsers, or on mobile, you will see this bottom navigation ribbon that occurs on the home screen. What basically happens is that whenever a browser intercepts a manifest file, it automatically triggers this event, and it takes like 3 to 4 seconds. It just doesn't does instantly, but you can customize this thing as well. From Chrome 90 onwards, they have added a new 2 meta description tags that are called description and screenshot, where you can give a cool effect instead of just adding a simple ribbon. And you can add the screenshots, as you can see over here, and also a bunch of descriptions, so that a person can make a very good decision before actually making the installation happen. So this can improve and increase the installation rate by a huge number. In case you are wondering that what you can do with iOS, because prompts are only supported by default by Chrome browsers and Firefox browsers. So also at the same time, the JavaScript function triggers a before install prompt. And you can add your custom functionalities by capturing this prompt event. You can add different ways to install it, like adding it to the left navigation bar, adding it as a prompt in the main section, or adding it as a top ribbon. And you can also customize the functionality of how you want the person to behave when he discovers this prompt. For example, on iOS, you would like to use for the person to actually click on this button and then click on add to home screen to actually activate the PWA. It's a little bit of hassle, but you can tie some kind of rewards when a person does this to make sure that the users installs your PWA. To see a simple code, how you can create your own custom install. So firstly, what we have to do is that we have to listen to the before install prompt event. Then we have to save this event and then trigger our own flow. Once the PWA is installable, then trigger back to our analytics service wherever we want to listen to what if this activity actually happened. In the code base, you can see we have actually added an event listener that is before install prompt, and then we create our own trigger flow, which is adding a prevent default, which is if the person has already installed the PWA, it shouldn't trigger him again. And if it hasn't installed, then do a show install promotions. It is totally customizable, and you can follow up, and I will be sharing new resources also of how you can make it more interesting. Another point to discover over here is using is one important function that is called get install related apps. Sometimes a person has already installed a native app in his phone, and in that case, you don't want the person to again get a promotion. So in that case, you would like the person to directly navigate to the app. You can do this by using the get install related apps API function. In your PWA itself, you have to define the scope called as related apps, which is, and then define the web app or the URL that you are trying to point. So what this is basically going to do is, as soon as a person's come on a website, you will automatically be redirected to the app that you want to redirect to. Also, you can centralize some notifications, and instead of sending different notifications on the let's say the native app on the PWA, you can centralize the whole experience and don't make yourself look like stupid. So also not add more bothering prompt. So make sure that you use this function as well. The second part is immersion. Immersion is defined as the experience when the person forgets about what is real and what is virtual. But wait, actually in our case, it's what's web and what is native. So we'll try to use these practices in which how much we can make the person feel so much immersed that he doesn't spot any difference between what is a web app and what is a native app. To start with, you have to use the display mode. Display mode in manifest file is defined as the way you want to represent your app. There are 4 different ways to display your content in the PWA section. One is the full screen mode, where you don't display any navigation button. In standalone, you do display navigation button. In minimal UI, you display the navigation button and the address bar with a couple of forward and backward buttons. And in browser, you are trying to provide the same experience as the browser. By default, the browser is the default display mode, and you have seen like if somebody adds a manual app, it's open just in browser, so it's nothing different than a bookmark. And you can customize it using this display standalone property. For some browsers, these display modes are not supported. And to have a fallback method, you can use the display override property, in which it will respect the display first, but if it doesn't occur, then it will respect the fallback. In this case, that is the minimal UI. Another important thing is how people actually discover when they go into the app browser and discover your app. For many years, PWA has been culprit of differentiation between what is a native app and web app because of the iconography. So you can see if you upload an icon, it will be always surrounded with this white box. Well, not anymore. You can use the maskable.app editor, in which you can import your own icon and then generate a PWA compatible adaptive icon, which will be performing good whenever the maskable icon set is on. So that when the users use his own custom icons, whether it is round, teardrop, square, whatever he wants to use, your PWA icon exactly looks fabulous and exactly like how you want to use it. You can also use the property called as purpose maskable, which allows the browsers to actually notice an operating system will be able to mask the PNG icon whenever the person using a different theme system. Native apps have a very good feature that you can use the app shortcuts. For example, I use Paytm a lot, and I don't want to go through Paytm and click on the QR code and then enter into the QR code screen. So for that, Paytm created a very easy shortcut in which I can launch the QR code directly. Well, in PWA also, you can use the same functionality, which is known as app shortcut. You can define some top level navigations like home, timeline, recent, and also a direct function like search. If you want to perform certain actions like a data entry task, if you are creating a to-do app for sake, you can directly do it using these app shortcuts. And guess what? App shortcuts are also compatible with voice assistant like Siri and OK Google. So if you define OK Google and your app shortcut name, your PWA can trigger the same action as well. To implement app shortcuts, it's very, very easy. In your app.manifest file, you have to just add these shortcut icons. And you have to define what is the name of your shortcut, what would be the short name which appears in the menu dropdown, what description, what this shortcut will be doing, and the URL that you want to prompt as soon as somebody clicks on that action button. You can also add custom icons like how you want to differentiate different app shortcuts. So make sure you try this one out also, because this is the best feature so far that I have experienced that differentiate between a PWA and a native app. Also, app shortcut works on desktop, iOS, and different operating systems as well. Another important property for a native app is the badging. The count button that you usually see over WhatsApp or email helps you recognize that how many notifications or what activity you have received after you have exited the app. In PWA also, you can use the same functionality. This can be done using the navigator.set app badge counter in this case. So for example, we have created a const which is called unread count, and you can add any number. You can actually create a service worker which fetches the content from the server. And then you can use the navigator.set app badge and add a try catch statement and then do something with your code over here. When you want to, if the person has addressed the notification, you would like to clear up these badge numbers, and you can do that using the navigation.clear app badge function. And badging works perfectly well with periodic background sync and web push API, which we'll be discussing in the next section. You would also like to display user certain kind of notification when the app is running in the background. You don't want users to always come into your website and then discover a content. And you can do this using the service worker web push notification function. For this, we'll use the service worker registration.show notification API, and it has basically two different strings that pass through this function, which is title and options. And in title, you have to define the metas like this, in which you define your body type, what you are going to display in the text, what icons you want to display, even if you want to add certain vibrations, so you can convert your notification into a vibratable, touch feedback. And even if you want to add a ringtone, you can do that too. You have to add a tag, which helps the operating system decide what kind of notification this is. And then finally, what actions you want to define, like yes, no, and these actions can be transformed into a outputable activity inside your PWA. Well, these are amazing options. And before researching for this presentation, I never knew before that these things are even possible in PWA. Another important thing is the activity. When a person uses your PWA, how much functionally he thinks the whole application is. Native apps are amazing at it, because once you are in the native app, the UI is flawless. Even if you're offline, the UI will move like butter. Can you do the same thing with the PWA? Yes, you can. In every browser, there is something called as app shell and content module. In single page application, this is inherited by default. So basically the components or the UI layer that you are defining is the application shell. Basically the UI, the home screen, the different navigation bars, the side navigation bar, and things like that. And these are something that repeats itself again and again. And the other part is content. For example, if you have music app, then the music inside will be the actual content. SPA frameworks are amazing at it, because when you generate a SPA code, it just creates a standalone client-side code, which is nothing but a minified version of all the code that you were running before. And for PWA, this is like a dream come true. You can cache all these different functionalities, and user can come back to again and again in this application shell without even needing to connect to the internet again. You can also use the properties such as a very small functionalities that I have displayed over here, that is called user select none. One thing that native app never does is that if you try to select a text, it will never get highlighted or selected. And you can do this in the PWA as well, so that if a person accidentally click on a text, he doesn't select cells. And you can use the CSS property user select none to perform this functionality. Also, you can use font family system UI, which automatically detects the UI font, whatever the UI is going to use, and your PWA can use the same font. So this kind of makes the app indistinguishable from the operating system environment and making it look more native. There is a trend these days, and we are thinking in our company also to add a dark mode. But how you should actually add a dark mode depends upon the user itself. If he is preferring to use the dark mode in his whole operating system, then you should totally respect that decision as well. And if he wants to use the light mode, well, that's okay with him too. Sometimes dark mode and light mode shift dynamically depending upon the time of the day. So you can achieve this using the property called as window.matchMedia, and then prefer color scheme property. So prefer color scheme property returns you the value light or dark depending upon what theme the operating system is actually using. And then you can apply your own media queries to actually apply the same function. Finally, we are on almost the last part of our presentation, that is API. API help your PWA or your web app to connect with native services, different APIs that the operating system has to offer, and even the hardware, sensors, and different properties. So let's see what are the different APIs available and how you can use them. The first and the most important is the Web Share API. Web Share API helps your app to share content on other apps. So for example, if your app is a music player, you can share that music or the link of the music on WhatsApp or different apps. For this, you can use the navigator.share property and then add things like title, text, and URL, which are basically the content that you want to share. You can also add a try catch to see if this is successfully fired or you want to fire it again. If you want to share files, well, that is possible as well. For example, if your app is PW like Instagram, so as soon as you publish a story, you want person to be able to share that story on different platform as well. You can use the same navigator.share API, and instead of adding the file location, the URL that we added in the last example, instead of that, you have to use the files array property. So after you do this, the API will be able to share the files into whatever destination you want to point. On the other hand, if you want your PWA to receive data from the other apps, for example, somebody wants to share a photograph and he should be able to share that photograph inside your PWA, you can do that as well using the Web Share Target API. And this is defined using a manifest property known as share target. So in your manifest file, define a share target, add an action that what you would like the person to, what function you would like to trigger when the person hits this target, and then what method this function would be, get or post, depending upon your requirement, and what different parameters you want to get from the destination. You can also make it configurable to use post commands, for example. So for the destination can be sending a post request from a multi-part form data, and you can process that as well. The next and amazing features that I always love is the media session API. Media session API helps you to display a player on the top of your navigation bar or even in the lock screen. You can do that by using the navigator.media session property. And then you have a bunch of different properties available under this API. You can customize what the metadata.title looks like, what the artist name is. You can also define the cursor position, what is the progress of the current playback media. And also you can add a, artwork of the uh, uh, playback media. It can be video as well. So you can add the PNG or the thumbnail of that image, and this automatically gets adaptable according to the operating system. Then you can also add bunch of different actions that you want to point to, and then add an event handler for these actions as well. And you would like at some point to actually access the native file of the operating system, whether it is the desktop app or the mobile app. For example, if you're trying to create, let's say, a social media app, you would like the person to be able to pick up a file from his native app. You can do that using the window.show open file picker API. And then when you get the return property, the native path, which is the local file path for that file, you can take that file property and then you can process it in the way you want. File system access API is wonderful if you want to create dynamic functionalities. One of the important things that always native apps are good at is working offline. Even a person is in a plane or in an environment where there is no internet, the app still functions. Well, you can use the same property in your PWA as well, so that the user feels just fine, even if there is no internet. So in this portion, we'll discuss about these functionalities, and how you can make your PWA even more, offline capable. So remember the app shell cache property that we were discussing before. This is the exact portion where I explain you technically how you can implement that portion. So in your service worker itself, you have to define the files to cache in object in which you add different bunch of files and their path. You can directly add the static path in this case or the SRC path in this case if you are exporting build on client SPA from React. So then you can add a service worker, which is our install service worker, and ask the browser to actually cache all these files that we have just written. A good practice here is to also include an offline.html page, which will tell the browser what to do if the person is not online and you don't have a cached content. Instead of displaying this favorite dinosaur that we usually see in the Chrome browser, we can actually create a cool game, or even let the person see some beautiful code and give him a JavaScript functionality that reconnect after the internet is back on. This can be achieved by using this constant that is called constant.offline URL and then defining your offline file. Also, if you want to make your other content make available offline for the browser or the PWA, you can use the content indexing API. Just like in Spotify or YouTube, you can create offline version of videos so that you can watch them when you are not connected. This API functionality helps you achieving exactly that. So as an overview, what you are trying to do is basically use this index property in the registration portion of your navigator.service worker, and then add all the indexing content that you want to index. Once you have indexed the content in your UI layer, you can use the registration.index.getAll property to return back all the content that you have ever cached. So this is amazing if you want to create an offline capable PWA and doesn't want the person to manually, check the internet again. So make sure you check the content indexing API as well. If you don't want to do the clockwork yourself by creating a service worker that is this much messy, you can simply use the workbox, which has inbuilt APIs for caching up any extension format. For example, in this example, you can see we have made a workbox worker, which is whenever it sees a .mp4 file, it caches it, so that the person doesn't need to go to the internet again and again if he's playing playback his favorite romantic song, let's say. So you can do that using the workbox inbuilt. This is actually a polyfill. So even if some browser doesn't has a functionality, you can add the service worker functionality in them as well. So make sure you check out workbox in case you don't want to go through your own JavaScript writing versions of creating media available offline. Finally, the native apps, one of the property that PWA never were able to achieve was the periodic background sync. Sometimes you are not attending the app for even weeks and months, but the app is still constantly sending you notifications or even performing the functions. You don't need to open the app again and again to do that. This is called the background activity of an app. Native developer would be always already knowing that this is so easy to achieve because of the background app activity cycle of native app. Well, now you can achieve the same functionality in PWA as well. Using the periodic background sync API, you can trigger some task for a regular interval for a specific time and ask it to do some set of a task. For example, getting new content or refreshing the notification feed. This is actually divided into two main things, that is registering the periodic sync and then responding to it. So registration can be done easily, again using your navigator.service worker API and then telling it that your API is ready. Then you can define and register your periodic sync using this minimum interval time property. And then automatically whenever this time interval happens, it can trigger the function that you define. For this example, we have defined the function content sync, which should trigger at exactly, I think this is 1 hour every day. So this is the minimum interval that we have defined. So then you can add an event listener for periodic sync and then trigger whatever desired application code you want to. Finally, we are done with like amazing APIs that we discovered. But the fourth and the most important point is, even if you want your PWA to be listed in Play Store, well, you can do that as well. There is a Chrome project known as TWA, Trusted Web Activity, which is basically a parent activity to PWA. You are defining a trusted encryption type to your PWA package so that it can be published into Play Store. You can use the bubble wrap CLI, which is just three CLI commands for you to generate your own Android app from any PWA. Again, remember, I'm not talking about wrapping your website into an app layer, which is actually the web view. This is actually conversion of your web code into a operating system runnable code. And you can achieve that using these three commands. First of all, you give the manifest file, which has all the API access that you want to do, and then finally build it. And you have the .apk file that you can then upload to the Play Store. Also, if you are super lazy like me, you can go to PWA Builder, in which you just need to enter the manifest file of your website and it automatically converts your already ready PWA into a native app. So make sure that you check out that as well. Finally, the sad part is not all operating systems are made equal. Everybody is different. And the most two important operating system that we have, Chrome and iOS, the web browsers we have, Chrome and Safari in this case, are not having the same equivalent preferences for PWA. So this is a small example of what are the things that you can do on Chrome PWAs, but you can't do on a Safari PWA. So check what your use case are, and if those use cases fulfill any of these API functionalities that you want to use, I think PWA is a go-to thing that you should do. Finally, if you want to check out more content, you can always go to web.dev and check out their PWA section, where they have bunch of different web practices and different code examples so that you can start becoming a PWA pro developer. If you really enjoyed the presentation, you know where to connect me and thank me. And also, I would be looking forward towards your feedback. It was wonderful talking over here. Thanks for your interest. See you next time.
Thanks a lot, Aman. That was a wonderful session indeed. And without a doubt, the audience had a
Bhavya,
great.
I think I can't hear you.
Uh, I think so. It takes a little while to connect. Am I audible now?
Uh, uh,
Am I audible now? Uh, can anyone hear me now? I'm not sure.
Maybe I think problem is on my end. I don't know. Other people are able to hear them. Okay, I think it's just from my end. Then.
Yeah, Aman, can you hear me now? Hello, hello. Okay, finally. So we have our next speaker, uh, which is Roei Berkovich. His topic for today is same code, faster application. Like we already discussed, the apps need to be fast, need to be very smooth these days, and Roy is always like going to help us do exactly that. Quick info about him: he has been working in the technology domain for past 5 years. He's working as a software engineer, and he's focused mainly on React and JavaScript. He works with a company called Apps Flyer, and he joined them a year ago. He's always looking for ways to create high quality code and deep dive into the technologies and frameworks. He also writes a tech blog at the rate reactisrael.co.il. And he's also the founder of JS Snippets Facebook page, which has a whooping 15K followers. So yeah, Rui, over to you, and great to have you here.
Hi everyone. Let me share my screen. Can you see my screen?
Everything is working. Yeah, you can start.
Okay. So hi everyone and welcome. I'm Roei Berkovich, and today I'm going to talk about how we can make our app much faster without almost changing our code base. I'm a senior software engineer at AppsFlyer. For those of you who don't know AppsFlyer is a mobile app tracking and attribution analytics platform for app developers and marketers. We help our clients to measure the return on investment of the marketing money they spend. So basically, we use data and a lot of data to save our clients money. I also write a tech blog called React Israel. There I write about almost everything related to React, React Native, and JavaScript. And I'm also the founder of JS Snippets. It's a Facebook page with 15,000 followers. If you like JavaScript snippets and squeezes, this is the place for you. You can go and check it out. So React is great. I believe that most of us work with React because we are in a React conference, of course. When creating a new project, everything is super fast. We have excellent performance. We have quick updates, both for state and props. And we also have React Memo, use callback, pure component, and a lot more cool stuff that help us to develop a great app. Our bundle size is pretty small. We have some libraries, some modules, and maybe 3 or 4 outs. But as we continue to develop, our application gets bigger and bigger because of new features, new components, new libraries we add, new modules, utils that we had. So the more the code we write and the more libraries and modules we use, our app bundle size will get bigger and bigger. This is something we can't avoid. Everything goes to the main bundle. We can't do anything about it yet, right? Now let's see some cool stuff. So let's begin with how can we know that our bundle is too big if we don't know that we have a problem? So we can find out the easiest way for both development and prod is to check the network tab in our browser. Here we can see the bundle size of our app. The second way is to build our project with a yarn on npm, then go to the dist folder and search for the JavaScript folder. That's where we can see our bundle file and see its size. And another way we will know if there's a problem is if we see this warning in the CLI when we build our app. This warning will only appear if our bundle size is too large. Only if you use create React app, of course. This they're warning. So before we continue, I want you all to remember this sentence. Always think of your users. We are probably working in a high-tech companies, startups, and big corporation. We probably have a brand new Mac and super fast Wi-Fi in our offices. Everything works like magic. We have a great app that's worked perfectly, and we are super proud of our amazing app. And yeah, we are using React. We have a single page application. We are awesome. But some of our users are stuck with poor internet. For them, our application is not as fast as we think. So remember this, we develop our apps for our users, not for ourselves. Even if it works well at our end, our users may have trouble. Okay, our bundle is too big. Where do we start? So the first thing we need to do is to analyze our bundle. Just for that, we have two leading libraries that do almost the same thing. They analyze our bundle. We have Webpack Bundle Analyzer and Source Map Explorer. Today, I'm going to talk about Webpack Bundle Analyzer, mainly because I like this library the most, but you can work with any library you want. It doesn't matter. So what does this library do? It visualizes size of Webpack output files with an interactive zoomable tree map. Now, let's see an example. Here we can see what packages our bundle consists of, and we can analyze it. At first glance, we can see here that Lodash, Mobex, and Bluebird take a lot of our bundle size just from the size of their boxes, okay? You can see when we hover the boxes, we can see the path, we can see the stat, we can see the gzip, we can click a component and see all our children. Because we developed this app, we know that Lodash just recently added to our project and that we used it only in one place in our app. And that place isn't even used very much by the users. So why is it taking so much from our bundle size? We definitely don't need it to load on the first page. Okay, let's summarize what we can achieve with that tool. We can realize what really inside our bundle. We can find out what modules make up most of its size. And we can even find modules that gather by mistake. We want to test a library, we install it, we try it, and then we decide not to move forward with that and to replace it. But we forgot to delete it, so it's still in our bundle. Okay, we identified the problem, and we have analyzed our bundle. And as always in programming, every problem has a number of solutions, okay? But today I'm going to talk about one of the solutions. It's named code splitting. Code splitting is a feature supported by bundlers like Rollup and Webpack. They can create multiple bundles that can be dynamically loaded at runtime, okay? Code splitting our app can help us lazy load just the things that are currently needed by the users. And this can dramatically improve the performance of our app, while we haven't reduced the overall amount of code in our app. Remember the title of my talk? It's the same code, but we get a much faster application. We avoid loading code that the user may never need and reduce the amount of code needed during the initial load. this is how code splitting works. Instead of loading our bundle in one piece at the beginning, we split our bundle into multiple bundles and load them on demand in runtime. How can we do it? So the best way to introduce code splitting into our app is through the dynamic import syntax. The dynamic import syntax is just a JavaScript, is part of the ECMAScript, and when Webpack come across this syntax, it automatically splits our bundle to chunks. Dynamic import is basically returning a promise, and the resolution of promise is expected to have the module, and then we can use it. We can see how we used to import. We import add format and then use add, and we can import met with dynamic import, and it's return a promise. But if we will do it, we also need a catch, and our code will not look that good. Okay, so it's hard to work with the native JavaScript dynamic import inside our React app. Just to clarify, code splitting and dynamic import are not limited to React. We can use them in any application. It's only a matter of implementation. Now, let's see the React way and how we can do it. In version 16.6, React introduced lazy and suspense. And this is the place where all the magic happens, okay? React lazy. React lazy is a function that lets us render a dynamic import syntax as a regular import. This will automatically load the bundle containing the component when this component is first rendered. After the first render, our bundle files are cached. So if we use the same components again in a different page, we will get the bundle from the cache without having to download it again. This is the lazy function syntax. React lazy function provides us a built-in way to separate components in an application into separate chunks of JavaScript, of course, with very, very little legwork. We just change the way we used to import the component. You can see the first line, we just import my component. And in the second line, we use React lazy and pass the path. Now, this is the simplest example of React component, I think. We don't see anything special here. It's just a dump component that is rendering another component. And this is how we usually write our imports today. Now let's see React lazy in action. Here we can see the exact same component. The user's components are identical. The only thing that has changed is the way we import the component. We can see it in line number 2. In the previous slide, we used a regular import like we always do, and now we are using React lazy. So what does this code do? It will split my component and all its children into separate bundle file. And we will download this bundle only when we want to render my component. Okay, now we have 2 bundles, the main bundles and my component bundle. We must understand that when we had one bundle, we just loaded it and all our imports were synchronous. But with React lazy, we get our new split bundles on demand and download them. So what will happen while you are waiting for the lazy component to load? Just for that, we have React Suspense. React Suspense allows us to show a fallback UI because it's asynchronous. We can show a fallback UI like a loader or a spinner while you're waiting for the lazy component to load. All we need to do is just to wrap our lazy component with React Suspense. Let's see it. This is the React Suspense syntax. React Suspense has a prop called fallback. The fallback prop accepts any React element that you want to render while waiting for the component to load. Just a second. Suspense accepts at least one component that is lazy, but we can add any valid JSX in addition to the lazy component, and we will see the fallback UI until it's finished loading. Okay, we can group some components and we will show the loader until it's finished loading. Now let's go back to the previous example, and it's the same code. Now we just import Suspense from React and wrap our lazy component, and now we have a fallback UI until the component will finish loading. We can even wrap multiple lazy components with a single Suspense component. Now, it's important for you to understand that we will see the fallback UI until all lazy components finish loading. I think you can think of it like something like promise all, okay? Okay, begin. Error boundaries. Okay, our error boundary is related to code splitting. Well, lazy loading is an asynchronous. So if the module fails to load, for example, due to network failure, then it will trigger an error, right? Remember, lazy components are asynchronous. We can handle this error with error boundaries and show some recovery UI or an error message. If you haven't come across error boundaries until now, it's okay. I recommend that you read about it. And don't worry, I have added a link about error boundaries at the end. This is a full example of how our code should look. And these are the steps. Change the import to lazy. Import Suspense and wrap our lazy component with Suspense for loading statement, of course. And then wrap it again with error boundaries for catching errors at runtime. Now let's see a real life example. Okay, just 1 second. Before that, what should we split? Okay, we can split components, so it's great, but can we split more things? Sure. We can begin at the route level. Routes are the simplest way to identify points of your application that can be split. We can also identify any large components on a page on your site that only render on certain user interactions, like clicking a button and open a pop-up or a dialog, or something that the user don't see because we have a flag. And we also need to consider splitting anything else that is off screen and not critical to the user, because we don't want the user to see a lot of loaders everywhere. Even if your app will be faster, the user will think that it's slower because you see a lot of spinners all the time. Now, let's see an example. And the first place we need to think of when we want to split our code is our routes. The bigger our app, the more the chance that we have some routes that the user almost never visit. For example, let's take GitHub. When was the last time you edit your profile picture, changing your address or the place you work? Probably not very often, right? So this is a great route for code splitting. The user don't need to load it at the initial page. And in this example, we will see two routes. The main route that is very slim, the home page. Now let's go into the home page. We just have an image, a paragraph, and a link. Okay, very, very slim component. And we have the heavy component. And here you can see that I have a map data and high charts and React PDF. Okay, so it's a pretty heavy component. Now we can see our main bundle size before code splitting is 1.8 megabyte. Okay, we can navigate to the heavy component route and see that we don't download anything. You see, all our application code has already been loaded, even if we don't need this component. We load everything. Now let's see how to split our code into chunks. As I said before, all the difference is how we import our component, and React will take care of the rest. Here you can see the regular import. I change it to React Lazy and import the same path, and I wrap it with suspense. Now let's refresh. Okay, are you ready? 429 kilobyte from 1.8 megabyte. Okay, this is truly amazing. Our main bundle is now 429 kilobyte because we split the heavy component, just it. We didn't touch our code base. We just save our users 76% from the original bundle size just by splitting the one route. Okay, we must know our application and how we build it and what is important to the user. You with me? It's 4 times faster than the first time we tried to load the main page and without changing the code base. This is a huge difference to the users. Now let's see the new bundles file. Only when we navigate to the heavy component route, we download the new bundle file. Okay, you see? We refresh the page and now we can see the new bundles. It's 1.3 megabyte and 29.1 kilobyte. And some of you have noticed that the chunk names was 0, 1, and 2. This is not readable. It's not readable. What will happen if we have 10 lazy modules, 20 components? It will be very, very hard to debug. So we can change the chunk name with a special Webpack comment called Webpack chunk name. And we write the name that we want to see in the network tab. Now let's see an example. Here you can see how I added into the lazy component. And okay, just a second. And we will see that name in the network tab, heavy component. Let me refresh the page. And now you can see heavy component and the vendors of a heavy component. And if this module fails, we will know which lazy components failed in the network tab, and we won't need to guess. Okay, we saw how to split our app bundle when we had a problem, but we don't have to wait until our bundle gets huge. We can check our libraries and modules before we install them and make smart decisions. Let's see some tools that can help us with that. So the first one is an extension by Wix called import cost. It's for VS Code. This extension will display the size of imported packages inline in the editor. The extension actually utilizes Webpack in order to detect the imported size. Here we can see a classic tree shake use case and understand how it makes our bundle bigger or smaller. It's 2K or 70K. It's a lot of difference, okay? Just by how we import our modules and our libraries. The second one is called Bundlephobia. It's a website, bundlephobia.com. In this website, we can find the cost of adding an NPM package to our bundle. It can really help us when we want to add a new package to our project. If its cost seems terribly high, it might be worth considering another package or writing the code ourselves. Okay, we can even choose the library gzip or the minimum, or how the bundle is minified, and also to see the version. Here we specify a version, and we can see another version of the same library. Okay, as I said in the beginning, always think of your users when you write code. We don't want to see a lot of loaders everywhere, and we definitely won't want a slow app. So be careful and don't start lazy all your components and all your routes, okay? Be wise, guys. I hope you learned something new, and please go and check your projects and see what you can split to separate chunks. You can reach out to me on LinkedIn and send me a message. I will be glad to hear about a project that you split. And here are those useful links that I promised you earlier and that helped me in preparing this presentation. Thank you very much. It was a pleasant.
Thanks a lot, Roei. That was a great session indeed. And I personally have used like splitting code a couple of times, and it does impact a lot. So in my company, we have made a standard that we don't do, like, we do absolute imports for Lodash, and we don't directly import the whole package, because it impacts a lot on the whole, the code base and the usability and the bundle size, obviously. So because we have a little bit of time, do you mind taking a couple of questions? There are a couple of questions from the audience. We can just take it.
No, let's do it.
All right. So there was this one question which says that suspense is still an experimental feature, and React talks say that it should be avoided to use in the production. So should we use it or we should not?
Yes, we can definitely use it in production. What is experimental is not this suspense. It's a suspense for a fetch and some experiments that React are doing those days, but it's not about this suspense. So it's definitely you can definitely use it in your application for production.
Okay, that's great. That's good news for everyone here. Another question is, how does bundling and lazy loading compare to loadable components?
What do you mean loadable components?
It is a question by Adam. Maybe he can add more things about it. Maybe that might be a library which would be there. Adam, if you are still on there, you could, add more about your question. What do you exactly mean? Any other question? Let me quickly see. Everybody else who has a question, they can, feel free to add it in the comment section. There was one more. So there was one more question saying that the presentation or the example that you gave, it had a 76% decrease in the bundle size. But it is a good question. It says that would it be the same in the production, or it might differ, or how do we, predict that?
Yes, of course. It was a one route, and I want to show you the difference so you can understand that it's very useful. But you can definitely, I think, something like 40% for sure. You can decrease the size of your bundle size.
All right. So there is another question by Rahul. He says that how can we implement a deferred loading? He says that if the user is sitting idle, he's not performing actions. If he wants to load a component at that time, how can one do that?
What you want to do to show a loader?
No, so he basically saying that a user is not performing any actions, and at that time maybe you want to load a component on the page. So how should you go about that?
We can also do something like prefetch for the components. We don't have to load them on demand. Okay, we can make a decision that when we scroll after I don't know 100 pixel, we want to load our next section or our next page because we've analyzed our user interactions and we know that they will probably go to some route. And we can decide that even after some, I don't know, after 10 seconds, we will start loading in the background our second route, for example.
All right, that's nice. Another
I
question.
see they ask about SSR.
Yeah.
So this syntax, it's not supported for SSR. Okay.
Roei, can you just tell the audience a bit about SSR first? Maybe not everyone is aware. That would be great.
SSR is server-side rendering. Okay, so if you send your HTML ready from the server to the client, you can't use this syntax, but you can check in the documentation and see what is the alternative. Maybe I can send you a link.
We have another question, Roei, from someone on the senior side. He says that what are the things that you should consider when using dynamic imports? Apart from that, it makes the code look ugly. Is there anything else when you make a choice whether you should dynamically import something?
I think that with dynamic import, it really looks ugly, but with React Lazy, it's super nice, and you just change your import. So why is it ugly?
Yeah,
we don't need with dynamic import, we need a try and catch and catch the errors. But with suspense and error boundaries, it's super easy.
Okay, that's great.
I'm not agree that it makes our code ugly.
Okay. Okay. I would say one last question. We'll do the others in the Q&A round. So one last question is this also beneficial for React native apps, or is it only in React, the web apps?
I'm not sure. Okay. I don't think it's also for React Native, but I'm not sure.
All right. That was a lot of good information, Roy, and thanks a lot for the session.
Thank you very much.
Yeah, thanks a lot. We'll have him again in the Q&A. So keep all your doubts ready. We can have a lot more questions then. So
Okay, no.
thanks a lot again, Roy. Yeah, thank you.
Bye, everyone. Thank you.
So everyone, I would give you all a minute maybe to, just drink some water or grab something to eat, because yeah, it was two great sessions. And we have already the next one lined up, but I'll start that in a minute. All right, so I hope everyone's all ready for the next talk. So yeah, the next speaker, the speaker three that we have, and the last one from this block is Prathamesh Sonpatki. He has something very special for us in his bag. His topic for today is rescuing a spaghetti React project. We all in our lives have written code which was a mess and not at all extensible. Us junior developers know all about it. To maintain that code was an absolute nightmare. Prathamesh here is to help us rescue it. So Prathamesh is a product lead at Last9 and a veteran speaker and a blogger as well. He has been into the technology domain for around 7-8 years or maybe more. He blogs about Ruby on Rails on prathamesh.tech. He's also involved in open source community and contributes to Ruby on Rails. And what more you ask? So in the past life, he co-wrote a book on React. So that's overwhelming, and that's a lot of good, like suggesting a great speaker is on his way for us. We have the session from him, so let me start.
Hello. Hi. My name is Prathamesh Sonpatki. I work at Last9 building a world-class operational intelligence platform for SREs. The Last9 platform helps people find root cause of failures, increase efficiency, and prevent failures with ease. Today, I'm going to talk about how we improved reliability of our front-end code base and made it more manageable. This talk does not have any specific internals about React. Like you will not get like go and change this piece of code in your app. I'll not be talking about such internals, but I'll be talking about some practical tips that work for us in a fast-paced startup environment. The ideas are not revolutionary. In fact, you will find that these ideas are very simple in theory if we talk about it, but while applying them in practical use cases, they do the magic very well and make the code base reliable and manageable. So let's start. Every project starts with a blank slate. As we are building something out of thin air, we don't have any background. We just have few hypotheses to build upon. And we also started similarly. We started with a simple create React app on day zero. Initially, for every startup, the first few months are always about building and learning from customers, building and learning from our hypothesis, and getting things together. So we are always in the build mode where we are building, shipping features, and we are in the ideation phase where we test our hypothesis with real world. We ship our features and then get some feedback. Based on that, we change few things, we fix few things. So for first few months, we are always in this build mode where we are always shipping something. But what happens is that if you don't pay attention to the code base, slowly it sort of begins to rot. And what happens is that if we don't pay the closer attention to some of the features that we are shipping, then adding new features or fixing bugs becomes difficult over the time. Nobody basically remembers why that line 338 exists in my index.js file, or why that particular graph.tsx file has become so big that it has now more than 1,000 lines. Nobody knows that. Fixing one bug might result into creating some other bugs. We always get some random surprises on the fly. Team gets frustrated. Nobody wants to basically touch that particular piece of code. It adds mental overhead and blah blah blah. Basically, nobody wants to touch that code at all. And this is where the reality sinks in. Like after a few months, the good phase has gone, and now we are in a phase where we have to ship features, but also at the same time we have to make sure that the code base is in a state where adding new features or fixing bugs is easier and is possible. So rewriting everything, not always an option, and it was definitely not an option for that was available to us, as our customers were already using the app and we didn't have bandwidth to start from scratch again. So we had to work with the existing code base and use practices and tools and set up processes that helped us in making this code a bit manageable than what we had earlier. So what do we do, right? Of course, our first step of fixing any mess is accepting, yes, there is a mess, right? Because only after doing that, we can sort of start looking into it objectively and start fixing it. So let's talk about what do we mean by bad code? And here I'm not talking about like theoretical concepts, but what it meant in terms of our application. So bad code for us was it was very hard to extend that code. Enhancing any existing feature, like let's say we have a sidebar and we want to create another sidebar where there were some different entities. So extending that feature meant we broke something else in the existing sidebar. To avoid this breakage, you sort of start adding code which results in duplication. So for example, if you have one function, because we are not able to extend it, you sort of use some of its functionality and duplicate it at some other place. But this resulted into code duplication. And then it results into bugs because when you try to change some of the logic in both of these functions, you forget to do it at one place, but do it at few other places. So then it results into random bugs, results into lack of consistency and structure, which makes it harder to understand over time why this particular function is present in this file, and then why a similar function is also present in some other file, but they're sort of doing same thing but not doing same thing, one line difference and so on. So the code base overall becomes very hard to understand. So basically it lacked the consistency and structure, And that's where it started resulting into unrelated pieces getting broken after deploying to production, things not getting caught early during code reviews because there were multiple places where the similar logic was present, and so on, resulted into a lot of cascading failures. So that sort of got us into the picture that no, we have to uh, like take a step back and basically start thinking about how to fix that. So it was basically going back to the drawing board again and fix it. But by fixing, what do I mean by fixing, right? So yes, we have accepted that we have code which is not in a good shape, and we have identified a few areas that are causing us problems, like consistency, structure, duplication, and so on. But fixing it from this to the good code part, what do we mean by that? Like, what exactly do we mean by good code? So good code, from a reliability and management point of view, there are three things that we look for in a good code base. First is obviously you should have confidence in that code. Then you should have safety, right? Like the reliability comes from having a safety net that you have in your processes that prevents you from doing the same mistakes again and again. And the most important part that sometimes we miss out is having a shared mental model where other team members or people not from the programmer teams also understand how this particular code base works, or what are the limitations, what are the specific things that this particular code base does. So these are the three things that we will be focusing on in this talk, and discuss how we improved on these 3 points. So let's talk about confidence first. Confidence is all about being certain about a piece of code doing one thing and doing it well. Obviously, it also means that not doing anything else, because a lot of times what happens is that when we start writing code, we try to extend a piece of code for other features, and then it sort of breaks down the existing functionality, as well as it doesn't work with the new functionality. So doing one thing and doing it well is very important. And in terms of code base, it boils down to writing smaller functions. So here we have a sample function which basically, given a timestamp, it validates it. I have, just for the sake of simplicity, I have added only one condition, but in reality, there are some other clauses that are there which check whether this particular timestamp is valid or not. So this is how we start. This is the starting point for our function. But slowly what happens is that if the timestamp is valid, we want to dispatch some action in our store, because based on that, we'll take some action, we'll show something to user or something like that. And then slowly we realize that no, but we cannot dispatch it directly. We have to only dispatch if this particular user is admin. So now we have added a conditional block here, right? So this is another mental headache that happens in this function. And somebody doing a code review or code check, if I check the name of the function as validate timestamp, I don't understand what exactly other things that is it doing. So here we are doing a side effect, right? In while checking the validation of the timestamp, we are also dispatching the action under certain conditions. So instead of this, if you just split it into two parts, by writing pure functions, right? So we try to have a pure function which basically takes an input, produces an output. That's it. It doesn't have any side effect. And that way it becomes very easier to understand the code base, as well as very easy to reuse the code base, because we can reuse the same pure function at other places as well. But the most important thing that it gives us is that they're pure JavaScript functions. There is no concept of having some framework related code, or having some library related code in these pure functions. They basically take an input and give the output back. So we can basically pull out these functions, put it into helper classes or helper methods, and then basically try to use them and reuse them. They don't have anything about using anything about React, Redux, or any particular library. And that allows us to also test them, because we can simply write unit tests for the given input, expect the output, and that helps us increasing having the confidence in our code. Because writing testable code is as important as writing code, right? We cannot write code which we cannot really test. And writing the pure function sort of help us in the first step, where we are able to write the unit tests in a very seamless manner for our pure functions. So when we started this exercise, we realized that a lot of our React components were using these kind of functions, but they were also relying on the global state of the component, or they were also doing sort of some side effects to the other parts of the application. And pulling those functions out and putting those into separate files helped us in sort of removing that ambiguity that our functions, even if they're using a state attribute, we always made sure that we pass that attribute as an input, because only then we are able to pull those functions out and test them separately, independent of the React component itself. So that allowed us to sort of increase the unit test coverage in our application. When that reality check happened, we had very less test coverage. But after applying this practice, our test coverage got increased to around 25 to 30%, and that helped us while fixing the bugs, because every bug fix was coupled with a test, regression test, and a pure function as much as possible. 100% test coverage is obviously a myth. I would not say that we should strive for it actively, but adding these kind of pure functions and coupling it with a unit test allowed us to have more confidence in our code. Obviously, unit tests are not the 100% solution, because a lot of times what happens is that having a unit test doesn't mean that you're tested the flow end to end. So in our case, we also use Cypress for writing end-to-end tests. And those tests helped us basically document and test complicated user workflows, like what happens after the user clicks on a particular entry in the UI, or what happens after user deletes something or clicks something. So those kind of workflows we were able to test using Cypress. Initially, we were a bit skeptical about Cypress, because the integration tests, they tend to be slow, and sometimes they also tend to be flaky. But over last 6 months, what we realized that those Cypress tests actually helped us and saved us, because when we were refactoring a lot of code, these tests actually helped us in catching bugs. So in a hindsight, the decision of relying on end-to-end tests turned out to be pretty well, though at the time when we started it, we were a bit skeptical about them. So we have integrated Cypress tests in our CI, GitHub Action CI, and we run them frequently. So that also helped us in increasing the confidence in our code. A test is always a important aspect of having confidence, but another important aspect of increasing confidence in our code is using the API that the framework gives us in an efficient manner. So in case of our application, it was about using the hooks API confidently, because we ran into few issues when we started the app. We ran into some usability issues, we ran into some overuse of hooks, and we wanted to address those while converting this code from a bad shape to good shape. So regarding hooks, they were introduced in React 16.8, and that allows us using state and React features like other React features without writing the component classes. So before this, there was a component class API in React, but hooks sort of allowed using the same functionality in a functional manner. So there are use effect and use state. These are the hooks that are very popular and widely used. But we also realized that we needed 2 more hooks for performance reasons, and as well as making sure that the state updates are transferred to our children component seamlessly. The first hook that I will talk about is when we don't want to use the use effect hook. So sometimes what happens is that when we are populating the state from the URL, then we don't want to run certain use effects on their first load when the component gets mounted for the first time. But we only want to invoke them when user takes some action after the page is loaded. So in those cases, we don't want to use the use effect on first mount. And this is a modified version of use effect, which basically checks whether the component is getting mounted for the first time. And if it does, then it skips the callback. and instead of that, it will just do nothing. So we will not run the use effect hook on the first load. But when you run it on any other user interaction after the page is loaded, we want to run it on any subsequent changes. So this hook sort of helped us in streamlining our state management, because we were able to make sure that certain hooks in certain interactions don't run on first load. Another important hook that we used was use callback. Before talking about it, let's see how basically equality works in JavaScript. So when we are comparing the primitive objects, like let's say Boolean or numbers or character strings, then we can see that the same object returns true if we compare them. But if we compare hash literals or arrays or functions, we basically get false, because every occurrence of that particular object creates a new object, because JavaScript doesn't follow the referential equality. So what happens is that in case of effects where we are using objects as arrays and maps in our components, then during re-renders, even if their content doesn't change, because the object gets created again, the components get re-rendered unnecessarily. So for example, if I have a array object for selected items, and I pass that selected items in a function to my list component, then during re-render, even if my list items are not going to get changed, but because that object gets recreated again, my component gets re-rendered unnecessarily. And in these cases, just wrapping that particular function within a use callback hook helps, because then use callback takes care of doing the internal comparison on the selected items, and only if the contents change, only then our component will get re-rendered. So this is an example of using use callback for a function. It's a good hook when we have these kind of objects which doesn't match the referential equality. So it helps us in avoiding unnecessary re-rendering. There is one more hook called as use memo, which is a sibling of use callback. So where use callback is important for wrapping functions, use memo is important for or useful for wrapping values. So whenever we have some values which are in the shape of arrays or maps, then we can use memo to make sure that it doesn't frequently change. It helps us in improving performance, as well as making sure that unnecessary re-renders doesn't happen. So that's how we use this hook for maintaining the sanity in the code base. There is one more thing that I want to talk about, which help us a lot, and it is that exhaustive depths ESLint rule. This rule comes from the React API itself. And most importantly, even if it causes a lot of warnings in our code base, you should never disable it. Even Dan Abramov from React team says that you should not ignore these warnings, because what these warnings tell us is that you are missing something in your use effect on which you depend on. So we should not we should not ignore these warnings. For example, if I have a use effect which is depending on view's length, but inside this function, I can also see that I'm accessing graph type, and graph type is also another state attribute in my component. And here I'm missing that. So in this array, I only have views.length. So basically what I'm saying is my use effect depends only on one of the attribute, but I'm using another attribute also inside the use effect. So this ESLint rule basically gives us a warning in such cases and tells us that no, you have to add the graph type also inside the use effect, so that we are protected from the side effects or random surprises that happen due to state being stale, or the graph type not having the correct value. If it changes at some other part of the application, we should not use the stale value inside this use effect. So this ESLint rule is extremely important, and ignoring it is not recommended. As such, ignoring any warning is bad, according to me. And I'll talk about how we treat the warnings also in next part of my talk. So with these things, having pure functions, having a command on hooks API, and using some custom hooks, we were pretty confident about the interactions in our code base, and slowly our code base was getting into shape. But we also wanted to make sure that while these steps of having this confidence definitely helped us, we also wanted to be diligent about not running into the broken window syndrome again. So we wanted a kind of a safety toolkit similar to the medical box that we have at home, which can keep us on our course and when basically we are tempted to deviate from it. So we wanted to have such safety toolkit with us. And the most important ingredient of that safety toolkit was TypeScript. TypeScript was a lifesaver for us. Basically, if you have never heard of TypeScript, it is a superset of JavaScript, which allows adding optional typing to our JavaScript code. It is a superset, so our existing code continues to work, and the typing is optional, so you can have certain part of the application with types and the rest of the application as it is. So you can basically gradually start adding types to your code. But overall, it improves the reliability of code base by a huge margin. And to tell you a sample example, here is how you can basically define a type. So here I'm defining a timestamp object and defining its type as number. But then I can also extend it and convert it into a maybe timestamp. So while my data is getting loaded, initially the timestamp may be null or undefined. So I am using the existing timestamp and composing a new type out of it. I can also define user interfaces like for time range, I can use the timestamp type that I created earlier for the from and to values. And even I can create enums. So I like this enums because I can basically map it to my API contract. And then I don't have to worry about having deviated from that API contract. So following the API contract strictly becomes quite possible using these kind of custom types that we can make out of the existing types. And then we can use them in functions with the colon syntax. We can also write types for the return value of a function. This is extremely important in case of refactoring, because when we are refactoring a function, while we have different callers calling that function, uh, the code doesn't compile until you fix all occurrences or until you change all occurrences of that function. So having these return types and the types for the arguments helps us a lot. Important and funny thing here is that before running into this situation, we were already using TypeScript, but most of the times we were using the any type, which basically means that this type can mean anything. And it was not helping us because the use of TypeScript was only notional use. We were not using it diligently. But after this realization that we need to fix the code base, we started using it extremely diligently, and then it helped us in um, improving the health of the code base. We can also extend the type interfaces that we have created. So for example, here I have created an interface for query object, but then if I want to use it with limit in certain API calls, I can just extend it and use it. So it is similar to writing code. You're not writing any other thing. You're just writing code as types, and it will just apply those types at compile time. It helped us in code reusability. Code refactoring became a lot easier because code doesn't compile until basically all occurrences of that validate function time are changed, or all calls of that validate timestamp are changed. If I'm adding a new argument, the code doesn't compile. So that helped us in catching bugs at the development type itself. There were no random surprises out of the blue at runtime. The undefined, not found errors sort of reduced. And in fact, net result, if I talk about the outcome after doing this exercise for a few months, was that our sentry errors reduced by over 80%. And that was a huge win, because earlier we used to have a lot of errors where the API contract was not followed properly, or the certain times you are passing wrong values to the functions. All of those things just went away. Code readability and predictability also improved. The only gripe that I have about is that the overall compilation time sort of increased a lot, because TypeScript was taking some time to go over the code base and compile it. But other than that, it was a huge win in terms of in terms of just in improving the reliability and making sure that the code base doesn't deteriorate again. So converting the JavaScript code into TypeScript code is possible on a gradual basis, and a lot of editors also support the integrations out of the box. So I'll highly recommend checking out TypeScript if you're not using it already. The other two friends that we had were ESLint and Prettier. And as I mentioned earlier, their warnings should not be ignored at all. So similar to the exhaustive depths rule that we discussed earlier, there are various other rules which make our lives as a developer easier and give us warning before we deploy a build. Sometimes we tend to treat those warnings as, what is this warning? I don't want to see this warning. Let's ignore that. But what we did was we added this max warning 0 in our ESLint command. And basically what this means was that our build, CI build used to throw errors if there was even one warning that is thrown by ESLint. And that helped us in mitigating a lot of warnings that we were ignoring earlier. Because the build fails, you have to fix it, and then only then the build will pass. So it helps us proactively fix the warnings upfront and keep the code quality in check. So in certain cases, the decision of ignoring warnings was taken on purpose after seeing the use cases and after making sure that, okay, we can ignore these warnings inline. But otherwise, having this max warning 0 in the build sort of protected us from ignoring warnings which get ignored due to manual oversight. Because a lot of times in development, when we are shipping at a fast pace, we tend to ignore these things, but we should not. And that also helped us a lot in maintaining the code quality. So having talked about the code a lot and improving the confidence, safety in the code base, I also want to talk about the other part where working in teams is not just about the code, right? We have designers, we have our higher management in our team, which will not have necessarily the time to check the code base all the time. Only the developer knows the internal details about a particular code base. So restoring the confidence and having a safety toolkit helps us as developers. Having a shared vocabulary helps everyone else in the team also. And that's where the mental model comes into the picture. So mental model is termed as having a knowledge structure held by each member of the team that enables them to form accurate explanations and expectations from a particular piece of code is my added definition, but this is how a mental model works. And having a common ground on what we are building and how it is getting built is of utmost importance, because we have a distributed team where a platform team and product team works in different sprints, in different terminologies, and having an explanation about how the API that is developed by a backend developer is going to get used by the front-end application is extremely important. The backend developer not necessarily will check the code that the front-end team is shipping every day to understand how they're using it. So if we provide them with some documentation diagram, they will be able to understand these things easily, and they will have a mental model about how their feature is going to get used by other teams. So we rely on things like sequence diagram. These are almost first-class citizens for every new feature that we are working on. We write flow charts. We try to prepare these diagrams and share them upfront so that these documents, these basically document our coding process, and we not necessarily have to check code all the time to understand how a feature is working. We also rely a lot on comments. A lot of times we sort of discourage writing comments in programming because our mantra is that comments get outdated very quickly. But what we have realized is that writing comments for business related decisions in the code is important, and because we don't remember that decision after a month, like why this particular if condition was added. It was added because there was something missing in the backend API, and we had to accommodate that change in front end for time being. And those kind of decisions get lost in Slack or in emails or in any other tool that we use. But having certain comments in the code base actually helps us in having that background on that feature, like why this was done in this way. So yes, don't write comments for everything, but especially for business decisions that are important and that you will tend to forget, having comments helps extremely. So now after doing these three things, having restoring the confidence, having a safety toolkit to basically save us from the temptations of doing things in a different way in future, and having a shared vocabulary that we can share with our team members, in a better way. We have sort of converted or moved away from our bad code, and we can say that the code is in a decent shape now. This Following these three practices to the T helped us improved our code base. We sort of rescued it from the from the bad shape and made it more reliable. Adding new features or changes doesn't feel like a burden, and we sort of look at it from a positive angle, that yes, we are able to ship things at a better pace, and even if the bugs happen, we are able to fix those and in a consistent and reliable manner. They don't affect the whole world unnecessarily. So then we become happy again, right? Having followed these practices for over last 5 to 6 months, I can say that they help us in a fast-paced environment where we were able to ship things very quickly. And even if these things are not like the framework specific things, these are general programming guidelines. And our team was also not very like experience in React, right? But just following these general programming guidelines of pure functions, maintaining the code in a way that it is testable, and making sure that we are using the API correctly. These things help us in improving the code base. If sort of things resonates with you, then do let me know in comments and questions. And you can also reach out to me on Twitter or via email. I'll definitely try to answer some of your questions. Thank you. Thank you.
So another great session and another great talk by Prathamesh. We have a couple of minutes of break now, and within another 3-4 minutes, we'll start with the Q&A. We'll have all three, Aman, Prathamesh, and Roei with us, and y'all are free to ask all your questions, all your doubts, all the discussions. Again, to remind you, y'all can put them in the chat, and we'll start it soon. See you. Yeah, so before we start our Q&A, we have a quick announcement for all our attendees. So our speakers prepared for you a pool of private interactive workshops where you can get much more information on the topics and dive deeply to React.js. There are 3 workshops that are already available. One is component-driven design systems. There is another one which is resilient component libraries with React, and we have another one which is React app hosting in Azure. I will put the link on chat so you can find more info about them and maybe just see if you'll like them and if you'll want to attend them. So so yeah, I welcome all the speakers again. All the 3 talks were really great and we had a great time without a doubt. I see a lot of comments saying great content, that was really helpful, they enjoyed it. We'll start with the Q&A now. First, Prathamesh, I would like to ask a couple of questions to you because there were questions already there put up. So one of the questions from Lucas was, do you think that using a clean architecture is a good first step to help us break our code into smaller and more focused components?
So clean architecture is very subjective term, right? Defining a clean architecture is not a very easy thing. It depends on application to application. But having a bias towards smaller components or smaller functions helps in terms of maintainability of the code, because every piece of code has a limited responsibility. So that helps in terms of like in terms of longevity of the project. It helps because of having a smaller mental overhead about what this piece of code is doing. So I would say only that having a, like, maybe I'll not answer the question in a true sense, but I'll say that give bias to the smaller functions and smaller components. That will help you in the long term in terms of maintaining the code base.
All right.
Clean architecture is subjective. So something that is clean for me may not be clean for anybody else.
Yeah. So there was another interesting question which says, you in your talk you mentioned about flowcharts. So
yeah,
there was a question about how do you create those flowcharts and where do you store them? Like how is it in a shared space wherein everybody can look it up?
Yeah, so we use Whimsical, and we use a common Whimsical account at our company, and all of us just maintain the microservice specific flowcharts there. So even our front end team, back end team, we write flowcharts or sequence diagrams for the new features and just maintain it there.
Okay. So I had a quick question from my end, which was, like recently during when I was working on one of my projects with my team. So we were using TypeScript 3, and then we decided to, just migrate our app to the newer packages, and we migrated to TypeScript 4, and everything started breaking. So in those scenarios, how would you suggest to, migrate our app, or how do we go about it?
Right, and that is painful. That happened with us also. So we also migrated similarly a few months ago, and everything started failing. But I think that everything started failing is the most important thing, because you don't miss anything. It is failing is actually a good thing. That it helps you in terms of not missing something that you would have missed otherwise. And also there are ways to disable certain rules. So for example, when we were migrating, I don't remember the exact rule, but there was one rule which was causing around 60 to 70% of the failures, and we just decided that we are going to avoid this for now, disable it, and come back to it later. But I think so. Looking at it from a positive point of view, that missing, like having those errors is a good thing. Changes the perspective of how we look at it. Obviously, in terms of if you have a big project, it becomes a bit problematic situation to fix everything immediately. But we can always do it in stages. So yeah.
Thank you. So there is another question which I'd like all our speakers, share some thoughts on. So there was this question by Sachindra. He says that for any application, how much code coverage or test coverage do you target, and how much does a team actually, like able to achieve it?
Right. So we have a thumb rule that every regression has to be coupled with a test. And anytime a new feature that you are developing, we should have a Cypress or end-to-end test for that. That is our thumb rule. Because we didn't start with a exhaustive test suite to start with. This strategy worked out for us while developing code as well as increasing the test coverage. And yeah, I mean, we don't target for like we don't follow TDD to the T. That first write test and then write code. We don't do that. But this has been working out for us. So no, like no 100% test coverage, but just making sure that most of the scenarios are covered by end-to-end tests and every bug fix coupled with a unit test.
Maybe Roei or Aman, you all could share some thoughts how we all do it at your companies.
Well, for me, I'm never like
Yeah.
totally. Yeah, Roei. You want to go first?
Okay, yeah, I will go first. We are writing unit test for every new features and also end-to-end test. About coverage, I think that it's something like at least 70% coverage for tests.
And for you, Aman, like for your company, how does it work?
Yeah, so I was about to say I don't have a unique viewpoint on this. I'm like not totally deeply involved in those matters. At some point, like couple of years ago, I was involved, but then I think the situation that I tend to do is that they like we do mostly about the stage testing whenever the release is happening, like using the agile methodology. So whenever, like as Roei said, it's not about like quantifying it to the the percentage coverage as well. So there is a minimum bar requirement for each of the functionality, and it is not like one size fits all kind of situation. Like you might want to have different tests on in terms of performance or accessibility. A lot of companies don't even consider accessibility, so but those units needs to be covered as well. So I tend to do that, and then when you see on the glances, like when you do go over the statistics, like how the releases has been happening, so those kind of business metrics helps in positioning your apps well and see in the actual ground how the tests are being covered. So I think that's the complete go through to that. So let's not put a number. This might be different on different use cases.
All right, all right. Uh, so another question that I had was, a lot of people ask about how you build your technical skills, how you, grow as a developer. But I also wanted to ask, like, how does one, plan their free time well, so maybe plan the weekends well to perform better on that Monday and not be, completely drained out or not looking forward to the next week, something like that. So how you'll, like each one of y'all do, or if y'all have any policies around that in your companies?
Yeah, so I am like personal fan of, I don't know if you have heard that song, work hard, play hard. So that's the thing that you want your guys to be in the same boat into, and you have to lead yourself as an example. So sometime I'm sharing my playlist or drunken pics. So because I want to encourage them to go crazy on weekends, because you need that distraction to be more focused on the Monday sprint that is coming. So even sometimes like when some miserable or horrible shit happens, then you have to work on Sunday nights or anything, and at that time the leader is also there to show them. But again, you have to get that flow right, that you are not just treating them as a deliverable package deliverer guy, but actually a human being. And if his dreams and aspirations are not being built at the end of the day, well, the motivation will suffice for 1 or 2 or 3 months, but not more than that. And then you will see that he is not giving 100% dedication in terms of even writing individual code. I really like the way Prathamesh covered the talk, and I think one of the point in writing like kind of working around with the spaghetti code is making sure that individual aspects are clear. They are themselves not spaghetti in their own life. Like, why I'm doing this shit, right? Because it might be a very important deliverable day for you, and he would just have that nirvana moment. Man, this company sucks. So you don't want that thing to happen with your engineers, and then final outcome won't be right. So you can run tests, you can run coverage, but at the end of the day, it's about how your employees feel. And for me, the rule of thumb, again copying Prathamesh in this, is if their dreams are automatically aligned towards the company ambition, then you don't need to motivate them at all. So I try to figure this out in the interviews or when we are having the selection, that does his dreams and aspirations align with our company's objective, and if it's the case, then we are in the shit together and we are in the good shit together as well. So that's the phenomenon. I would be interested in knowing others' opinion as well in this case.
Maybe Roei, you can go next. Roei, you are on mute. Sorry. Roei, you are on mute. We can't hear you. You are on mute, like you have kept your mic on mute. Maybe Prathamesh, you can go till then.
Yeah, so it is an individual choice how we want to spend our weekend and get recharged for the next week. Some people do some activity. Some people just shut their laptop, go out, enjoy with friends. Some people keep writing code, side projects and other stuff, or watch movies, Netflix, Prime, and all that. So I would say it's individual. It's important to take breaks though. That is extremely important, because otherwise it's very easy to get burned out, especially when um, we are working remotely these days. When there is no human element involved, it's very easy to get into that pit where we sort of are working without doing anything. So important to take breaks and important to know one's limits. Um, One thing that I like based on my experience is that everyone in the team is different, and some people like to work, which doesn't mean that everyone has to work all the time. In a team, at a lot of times what happens is that because somebody else is working, there is a pressure on us to also keep working. But I have realized that we should just openly say that no, this is the limit that I'll be working on, and people do appreciate it as well as understand it. And if your team members are not understanding it, maybe that is a not good place to continue working. Because in my experience, in whatever good companies that I have worked with, and like people understand that this person is not going to work on these days. You already announce it. It actually helps them plan the delivery in a better way. Because let's say if I announce that I'm not going to be available on this Friday, because I have some work, I'll be unavailable. It helps my team to plan the release on Thursday, or if it goes beyond that, we can release it on Monday. We can reduce some scope. We can change some of the goals that we are chasing, and so on. But being open about it, I think, helps, and not taking undue pressure of what others are doing, I would say.
Yeah, Roei, you can go next now. Yeah.
Yes, you can hear me now.
Yeah, we can.
Okay. So I think that we don't need to pressure the employee to work in research, and everyone is different, and everyone take care of some parts of the codes and what they want to do. So definitely they don't need to work on weekends, only if they want. If they want to learn about something new or something that is interesting. So it's blessed. Of course, knowledge is power, and sharing knowledge is great. But you can't force anyone to learn something new. But it's definitely a good thing. We are also having a community inside Appsflyer for sharing knowledge. and people are presenting their achievements and new stuff they made. But you definitely want to hire people with passion. You don't want to force them to learn things and technology.
So that brings me to my next question. There is a question regarding what advice each of one you would like give for someone who's just starting in React, like someone who's a beginner, someone who's a junior. What advice would you give?
Documentation. Read the documentation. Follow some React core team members. Watch conferences. And definitely write your own code. If you just see videos on YouTube, you can't write something real. You have to practice. You have to try it out. You can watch videos and then try to do it yourselves. But you must get your hands dirty with code. But definitely Medium, Dev to React conferences, YouTubers, Twitter. You see a lot new cool stuff on Twitter. I think that's it. That's it for me.
Anything you all would like to add, Aman or Prathamesh? Anyone?
Yeah, so I think I'm a huge fan. So certainly a lot of people come with that background, that from college environment or from the school environment. In fact, some people, or the culture around the location is such that you are like automatically forced into becoming a good programmer, and like just good connections help you build that. But for some peoples like me, I am actually descended from part of northern part of India known as Kashmir, and I got my first touch to computers in like my high school or later that time. But I had a passion that I had to fidget around with machines and all that. What helped me a lot along the way to this position till now was a simple concept that somebody told me just after my high school, that fake it till you make it. So I tried to be in that portion that whenever somebody gave me a challenge, Aman, can you do this? Or something I myself thought, can I do this? Even though I didn't knew, instead of going through, let me prepare for that, I'll be doing, okay, I'll take the challenge and on the way I'll prepare for that. What this actually does is that you won't be going through 1 2 3 steps or YouTube videos or trying to get a certification. To me, the overhyped certification or completion of course sucks, because you will be end of the day will be earning a paper, but on the ground, do you know how certain things work? I have seen people having a lot of certification, but even if I do, can you merge this pull request using just git CLI? They can't do it. So you can only do this if you are deeply involved into something, that you didn't did it for the first place to earn a certification. See, why we build frameworks, why we build a technology, to make somebody's life easier, and you are here to do a project to make somebody's life easier. So the tools and technologies you should be choosing, you should be going through that dilemma, that should I be going with React, should I be going with Angular, what are the pros and cons of that? So when you will realize that when you start building your own projects, you go through the mentality of how the developer would have been thinking at the same point. And once you do this, then you yourself build the individual ingredient, and whatever is missing, you have open resources like Stack Overflow, as Roei also said, different blogs. I am a huge fan of Daily Dev. If you are not using that, please install that extension. It gives you news from all of that. So just be subscribed to new bloggers, listen to their podcast so that you are aware of the new stuff. But at the same time, keep contributing to open source. Any open source project will always emphasize the best coding practices, because they are not just creating apps to impress a certain business metrics or a company. So they will always tend to have the best of the best programmers and the best of the best quality practices. So to begin with, I also started with contributing to open source, even though in beginning I sucked. Like I was only doing documentation, but then serious one day by day, and when we talk with other programmers, they help us guide through that. And you have to feel that the imposter syndrome is with everyone, like am I doing this job right, or I'm the person who can contribute to open source? But you have to use this thing, fake it till you make it, because the brighter side is too good than the darker side. If you don't succeed, you learn a lesson, but you will continue doing it. But see the brighter side, you will be coming yourself out as a person who has completed an amazing project and is being used by people. So don't do it for certification when you're learning a skill. Do it for being a professional in that thing.
That's a lot of good information. And I'll probably move on to the next question. There is another very interesting question. It says, what are the new development tools or frameworks that all of y'all are using to improve your developer experience and also increase your day-to-day productivity? So Prathamesh, could you start for this one?
Yeah, so TypeScript for me, highly recommended. And it will not just improve your developer productivity, but it will also improve the health of the code.
Roei, would you like to share something?
You can definitely use TypeScript. It's very good practice for JavaScript developer. I saw that they are also asked about AUI. So you have anti-design and material UI and Tailwind. So there are great libraries. Yeah, you can check them out. What else? If you start with React, I recommended you to start with Create React App. It's great bootstrap, and you don't need to mess up with Webpack and things that you don't need right now. You can just start coding in React.
So I think because the first part is also about development tools, and I'm a huge fan of people trying to make their code better, code practices better at a surface level. So I'm a huge fan of code analysis tools like Code Climate and Deep Source. So and this practically helped us team us a lot because it has this gamification function. And yesterday only we were doing a betting that whoever has the, let's say, lowest code impact will eat chili or something. So we do these things all the time, so kind of add a fun element to their own progress. And what you are getting in the company is actually a very performant code. So we directly involve programmers and engineers to bug fixes whatever new issues we are getting in Sentry, or whenever somebody is doing a PR, what bug risks we are getting in Deep Source, and also doing this regular, what do you say, weekly meeting about how we are doing as a team in Code Climate. So these all three tools are free of cost for beginning. So definitely check it out, involve in your company, and even for your individual projects, it will help you standardize your company's code to a very higher company standard.
Thanks a lot for all those inputs. Another quick question I have for you, Aman, specifically, because your talk was related to PWA. I wanted to ask, do you see the native apps, the Android apps, the iOS apps getting redundant and completely thrown out of the market in near future? Or do you feel that there is a place for them to coexist?
Well, this is a classic debate: robot versus machine, AI versus humans, and all that. So I won't go into the battle, but actually I see a convergence. See, what the thing about innovation is, when you innovate enough, you tend to converge multiple industries so that you don't repeat. And if you see in practical way, the fundamental way for a user is to discover the content and accomplish his task. It doesn't matter if he's doing it in web browser or using native apps. So the question is redundant itself, like whether you should install an app to perform certain functions. So I think over time, as the innovation happens, as even you can see the battle between Epic and Apple has showed that depending upon a Play Store policy is something that users shouldn't be going through that barrier, or even the app producers. Internet is free, like anybody can publish anything and anybody can reach out to anyone. So that is why I don't see one getting over another, but I see it to be getting more convergent. And with so it is creating force on companies also, like as in my talk I discussed about that Apple doesn't support all the PWA features as Android, and I think this is the last bottleneck why people are not going PWA only for most of their apps. See, most of the app only needs API function, getting content regularly, adding notification, search functionality. Most of the apps won't be using sensors and heavy hardware accelerated things. So PWA is making sense to them. But this Apple scenario creates a difficulty for the user because they are Play Store or App Store is a way to discover or compete against markets, and web doesn't has a market, which is a good thing and a bad thing at the same time. But I think as more and more application developers innovate enough in the space, and companies also realize that this battle is going to be a bad thing for them. For example, Apple in this case, the app scenario is going to go into the divergent section also. One important thing that I observed, and I don't know a lot of people know this or not, when the first iPhone version was released, the apps were made in HTML5, and then they go into the Swift path, and then they are recommending their own users to use things like WebAssembly to render their app and directly run their web app code in form of native apps. It's just the barrier entry, I think, for the people to install PWAs on the iOS. But I think as soon as that is fixed and people are working on that thing with next W3C update or conference, I think that will be over as well. After this is done, I don't think there will be any differentiation between a web app and a native app.
That's a lot of good information, Aman. Thanks a lot. I had a specific question for you as well, Roei. It was about, like there are a lot of us junior developers or intermediate developers, and we also would like to, learn how we can start blogging or how we can start, speaking at events or become a speaker. So could you share some light on your journey and, how did you go about it?
Yeah, sure. So you just need to think of a subject that you want to learn. Okay, if you're a junior and you want to know how React router is working, for example, or what is the state management, or I don't know, context, hooks, just pick a topic and start to learn it. Write at least 5, 6 I don't know, Medium blogs, see some video, and then start to write from the beginning to the end. And every time you write, you must be aware that the things you know, the readers doesn't, not all of them know what you know. Okay, so you have to explain everything, even the simplest thing. Because it's very important to be clear, and you want that your postblog be productive, that people go and want to mutate your side project maybe. If you can put an examples, you can make with code sandbox, or I don't know, with CodePen, and put some examples that people can play with your code and see what you done. About talking in conferences, just believe in yourself. Everyone can. If you like it, you can do it. Okay? Just again, pick a topic and practice and practice and practice, and be the best that you can. It takes some courage, but it's okay. No one will laugh at you, and the community is very strong and very adaptive, even to junior developers. And just do it. And I think that if you will Slack me or anyone here, we will be happy to assist.
That's great. Yeah, probably I would be the one slacking you next, but yeah. So
Go for it.
Another question, Prathamesh and Aman, y'all could answer because y'all are talking about open source. So there's this question regarding any suggestion for an open source project to start with. Like, how does a junior developer or developer who has a 1-year experience, 2-year experience start with, an open source project? Where do you find them? How do you start?
Aman, do you want to go?
Yeah, I think you are the more senior in this case. You have done more work than me, so I'd love to hear you first.
Yeah, so I would say the project that we are working on, whatever tools we are working on, if we pick up just one of the library from our project, I think that is also a good place to start with. For example, if I'm using Redux, I'll start with checking how Redux works. Uh, Eventually what I will find is that there are four other libraries that are similar to Redux, or I will find that Redux is also similar to another programming language called as Elm. So I'll probably dabble into that and see what sticks with me. Because a lot of times what happens is that we unnecessarily try to do everything. But if we have few libraries or few projects that we are already using, just noting down some of the problems that we face in our day-to-day workflow also helps us in figuring out how the internals works. For example, if I add that max warning is equal to 0 flag, I will see how ESLint internally implements parsing of the flags. Or I will see how to do that via ESLint RC file or so on. So just noting down some of the problems that we face in our day-to-day development life, we can start picking up few things from those libraries and start learning about the internals. And then slowly we can start fixing few things and contributing.
Yeah, so I have more generic advice on this. So basically, I think open source contribution really matters if you are really catching up to the heat of the moment. So if the open source project is too mature, then you have to do hard contributions. So for beginners, it won't be that relevant. And if open source project is too young, then there needs to be so much architectural work needs to be done on the app, then you still can't be relevant. So there is this middle chasm that users needs to find. One of the great ways is like if you regularly code on GitHub, there is a section in GitHub known as GitHub Explore. So you can go on GitHub Explore and it automatically recommends what are the open source project you can be part of. So that is one direct way to identify from your end. The other way is, for example, if you're talking about the current state, and in terms of React specifically, I see AMP to be a very good project because they themselves use internal React components, not React. But still, it's very good to clear out basics and still be part of open source. Creating Gatsby component could be good one also because they are also in this current phase of creating many component. Recently, GitHub released a new platform called as Nhost, which is more like creating microservices. So you can be creating code samples on that. Then Code Sandbox, you can create public code activities for people to start working on them. So this is like individual projects that you can start. And then I think the best practice is keep on coding, and then go and regularly check GitHub Explore section, and they will find something very unique to you. Try to find the top 10 GitHub performers also, and which projects they are part of. So that could be very good learning point for you also. So go with these kind of trends, what is actually in that chasm, and will ensure you the maximum learning effect and absorbing.
I think that you also need to go for the big project, because then you can get some small fixes and issues and not start from a small project and you need to do the architecture maybe. So definitely, if this is your project, go for the big ones, because then probably, or maybe you will have someone that will guide you. You can see a good code, you can see good comments, and you can fix something very small, and then you will get confidence with your code.
Yeah, thanks a lot, everyone. Aman, a few of our people from the audience are asking for the links or the things that you mentioned. So if you could just put that in the chat. And with that, our Q&A comes to an end. So I would like to thank all of the speakers again, and I would also like to thank the audience. We have a small giveaway for all of y'all. We really value because the speakers and the team has really worked hard for this event, and y'all are commenting, y'all are here to attend. It means a lot to us. So all you got to do is post on Twitter and tag our official Geekle account @Geekle official and write what you like the most about the event and which topic did you like the most, which speaker, and some lines about it. And there would be 5 winners who will get 2 free tickets for any of the next Geekle events. So I'll be mentioning the same in the chat. And thanks a lot, everyone.
Thanks a
So,
lot, Bhavya.
Thanks a lot.
Thank you.
yeah. Thank you, everyone.
Thank you
So,
very much.
Stay
yeah,
healthy.
thanks a lot. So to the audience, we'll have a 15-minute break now, and see you soon. Thank you. So yeah, welcome back everyone. We'll be starting in a couple of minutes. So I hope everyone had something to eat and just had a small short break because we have our next session. And our next session is about React libraries. I already saw a couple of people asking about libraries and which are the best ones or which are the ones the industry is using, how to prefer one over another. We'll have all those answers in this session. We have another three speakers lined up, and the first of them is Ketan Agnihotri. He will be presenting a talk on the new buzzword in town, micro-frontends, and how to implement it. Ketan has over 8.5 years of experience in tech and is currently working with Microsoft. And he's working as an Azure consultant. He has worked on tons and tons of frameworks and languages, and React is obviously one of them. So over to you, Ketan.
Thanks. I think hope you can hear me. So I will share my screen and we will get started with the stuff. Okay. So welcome to this session. So just say yeah, everything is all good and you can see my screen. If yes, just type yes, no, yes, no. Okay, great, cool. So basically, micro front end is kind of a new buzzword in the market. We will understand when to use, why to use, what are the things and frameworks available in the market, and why it is important. Because if you see these days, we have many front end libraries like AngularJS, React.js, and Vue.js. We don't know which one to learn and present. Okay, so that's where the problem comes in mind, or which one to pick as a framework to choose while developing front-end applications. So this is kind of a microservices approach to scale your modern UI. So as Bhavin already introduced myself, so I will move forward. The agenda for this session looks like this. We will check introduction to micro frontends, how it is different from monolithic front-end application, when to choose micro frontend. So it's not like choosing micro frontend all the time. It's as and when it is needed. We need to make choices wisely. It's not about it's something new and trending in the market and let's go ahead and use it. It's not like that. So that things we will understand when to choose things to take care while building applications in micro frontend. uh, some of the advantages and disadvantages also we will check an example showcase for this. Okay, so basically this is what the monolithic application looks like. So normally we have a database, a micro a service, a backend service, and a front end application attached to it. uh, and uh, during the transition and the era in last 4 to 5 years, we have splitted our monolithic services to some of these services. We split them, but we definitely not did the splitting of the front end application. So that's a bottleneck. So when you want to release particular feature from front end applications, it's all the time like you have to build entire code base, deploy the artifacts and all this stuff. So it's not that suitable most of the time. Okay, so it's basically as I told you, it uses the same code base for all the teams, and we need to manage its CSS, its JS, the versioning of the packages we are using inside it. So all that comes with the extra overhead. So that's the problem with monolithic. So as we splitted the backend services, there was an architecture style was introduced by ThoughtWorks in 2016. So they came up with this approach where they also started to have a mono repos, a kind of a repo which will have its database related stuff, its backend service, as well as front end application. So it's a kind of a micro application. So you can build and release your applications using pipelines uh, for each micro means each micro application. Okay, so basically when you want to choose micro front end architectural style, you need to understand the boundaries. So you need to segregate the front end application in a such a way that they are not connected to each other, so they are quite loosely coupled with each other basically. And because of that, scaling of the application becomes very easy, and you can innovate your application without impacting other piece of front end application. Okay, so you can innovate as per your need. You can choose basically the technology of your choice. Let's say front end application one you want to develop in React, the second one in Angular, and the third one in Vue.js. So you can pick the best of all the worlds and can implement it. So let's understand what is micro frontend. So as I told you, it basically microservices for frontend. We break down the monolithic frontend and backend services into microservices. So we split these applications by business domain or maybe by technology. We many small manageable uh, pieces basically, which can basically are not connected to each other, so they are decoupled. And composition of the feature owned by the different independent teams. So if one of the team is good at Angular, one of the team is a good at React, so they can see and pick the business logic and they can build it. Okay, so also one thing, independent deployment and releases is possible. Because of that, you can write build pipeline and release pipeline for this. It's kind And also one important thing is, let's say you have an old code base which is actually up and running and your customers are using it, and it's maybe, let's say it's written in 2010 where jQuery was quite trending in the market. So you have everything is written in jQuery. Now on top of it, let's say you want to have a single page application using React. So you can uh, club these two old and new technologies together and can make it run, and you will use the routes, different routes for the old application, different routes for the latest application. Like that you can merge both of them at one places. So if we really think about it, how we can pick the micro front end, which how we can segregate. So mostly people try to do consider the subdomains means business. In terms of business, you will split your applications in a such a way that each domain you will segregate from each other, and you will have a separate team for that. And after merging all those application subdomains, you will be able to deliver application which is actually focusing the businesses. Okay, so like that, basically micro frontends are the technical presentation of business subdomains managed by same team. Okay, so things to look into micro frontends, basically composing multiple frontends. If you have more than 2 to 3 frontend, then only we can call it as micro frontend application. Otherwise we will not make things complex, we will have only monolithic frontend. So data sharing between the apps you also need to keep in mind. And also the UX consistency. Let's say you are having let's say 5 to 6 routes for your 6 micro frontends. Okay, so while navigating from one route to another route, there should be UX consistency. User should not feel like he is using 6 different applications. Okay, so accordingly you need to set the standards for you need to set the standards for your application CSS and everything. Okay, so like this, if you see the build and test pipeline, so let's say front end one is built in Vue.js, front end 2 is in Angular, front end 3 is in React, front end 4 is in React again. So it's not like you have to choose only uh, uh, all 3 of different. So you can have all 3 of them in React, all 4 of them are in React, or all of them in Angular, and as per your need you can pick best of the world. So and build and test pipelines will run on each one of them. After deployment, after the build, you will start the deployment process. You will pick the deployable things for each, for front end 1, front end 2, front end, and 4 apps will be composed into one package and will be deployed on a server. Okay, so they will be deployed independently also. It's not necessary to club them into one and deploy. Okay, so basically when we talk about micro front end, independent cross teams development is possible because of this. So good dependency management result into smaller deployable bundle. Okay, so independent teams with independent deployments, and there are no version conflicts with the functionalities we are delivering. Okay, so with the monolithic all the team members are working on one of the project, and it's having only one package as a deployable and non atomic deployment. Even if you want to make a smaller change, you have to deploy entire code base. Okay, so that's what the problem is. As I told you, related to the styling, avoid sharing the code across the team. So when you are building macro frontends, try not to have an abstraction. So most of the time what we do the abstraction, we keep the common css, common component at one place. So it is possible to some extent, but try to avoid horizontal teams like this. If you see the team one, team a, team b, and team c, all of them are using micro frontend and they are sharing the styling part. So it's not recommended when you are building micro frontends. Okay, so there are multiple approaches and libraries are available in the market when it comes to micro frontend. So one of the popular one is a single SPA meta framework, Frint.js. You can also have your own iframes, and make you can deploy your single page applications live at different URLs, and you can use the window object and can make the communication possible between them. Cross application communication via routing is also possible sometimes. So after doing all this stuff, build and release, so there is important is the testing part of it. So as we have splitted our application in terms of business subdomains, so it's also important there should be an integration test between one application to another. Consumer driven contracts are also validated, and the API journey testing is also one of the key. The functional test and security test, like you need to sanitize your inputs, you need to do a lot of security checks on top of, because we are using different frameworks and different libraries in each one of them. So it's necessary to also consider the security aspect of your application. Okay, so I have built one sample application using single SPA framework. So where what I have done, I have basically used 3 to 4 application. So one application I have built in Angular, one application in React.js, and one application is kind of a router, so navigation basically between the apps. Okay, so I try to build that. So in single SPA, you need to have a one main container, let's say your entire page, which is up and available, always accessible to all the applications. Okay, so main container is responsible to load the micro front ends. So which also can be called as bootstrapping. So bootstrapping is basically kind of a singleton kind of a stuff where we load all the necessary libraries and scripting for the complete application. There will be a tiny layer which will invoke this small app 2, app 3, app 4. Okay, so there are quite these are the some of the events or methods provided by single SPA. So where you need to register your application first, where you can also pass the custom props, where let's say some authentication token you want to pass, and you will store it on a local storage or cookies, and all your application 2, 3, 4 will use this authentication to validate the authentication and authorization part of the user. After doing that, single spa.start is also one of the method which you can use to start and to register your Angular application and React application. These are the uh, uh, basically stuff you can import from single SPA framework. Like that, you need to pass the dependencies to it, and these are some of the important life cycle events or method you can call in single SPA. Bootstrap, the initial stage, and the kind of a singleton stuff, mount and unmounting of the application. So all this declaration you have to do. Okay, so I have already built that application and it's up and running on some one port. So I will share that. So what I'm going to do, I'm going to refresh and will show you how the Angular and the React application are getting loaded in a single screen. So if you see, when I'm refreshing, there is a spinner. Basically spinner is actually a container. If I hide this left stuff, this widget which is built in Angular, so let me just do display none. And if you see, there is already an application, a loader, which I have added on my main container, which is all the time running and is getting overlapped because of this Angular application. How we can see this is Angular? So if you see, there are the ng content, ng when we already know, when it comes to ng means that is Angular. So all the stuff I have built is in Angular on the left side section. So, and this is a sample API. Let's take consider the network XHR request, making a refresh. A sample API I am using, which is available on internet, this post API. I got this result from that sample API, and I'm actually doing the mapping of it. So if you see, these are the post, title, body. So all those rendering I have done, and this is built in Angular. Okay, and the right side section is in React. If you see here, a sample simple React application, it's not so fancy with the hooks and functional component, but it's a kind of a very old React application I was having, so I just clubbed it. A profile component I have built, where I'm just showing my image, my name, and about me section. So it's so two different application. So application from two different worlds are running in one container. So as I have already shown you the container, and this is app 1 and app 2, like that. So this is my source code. So I'm planning to publish it on a GitHub very soon, but it's not in very much in a better state. Still I need to work on it. Once it is done, I will publish it. So that was about you can also see the this code, how it's basically I did the registration of the application. If you see, the first I have did the registration of navigation part, then the profile and the app details, and then I'm starting the single SPS start. Okay, so those stuff basically I have done. So now we are coming to the point. Now a lot of questions comes in mind. Really, I should always use micro frontends or not? When to use? So when you feel like there are distributed teams and having different skill set, and they can work independently, and they can release their features independently, at that time you should use the micro frontends. When you want to collaborate with different frameworks, that time you can choose the micro frontend. Also, micro frontend doesn't mean using every framework in the world. You can also use, as I told you, all of the micro frontend application can be built in React.js. It's fine, absolutely fine. So easy to build micro frontend. It comes with a lot of extra infrastructure and planning, right? So it needs a planning. You need to distinguish your subdomains. You need to find that separation line. Using that, you can build the front end applications accordingly. So advantages of using it is empowering teams to choose framework of their own choice, combine many small apps, and they are quite easy to develop and test. uh, Improving the new things becomes easier and better for maintenance. As I told you, we can club our old jQuery application with the new front end React application all together at one place. So that is an extra advantage. If we come to the disadvantage part of it, so if application is really small and it's very difficult to have that separation line in between the subdomains, at that time I will advise you not to choose this uh, micro front end stuff. You can go ahead with our monolithic front end. So it comes with operational complexity. Don't use this for the simple app. Payload size, if you see, as we are running npm build, and there is a JavaScript bundle which might be having a duplication of common dependencies. Browser may end up downloading a lot of frameworks and duplicate code. Let's say we are using Axios, is one of the HTTP client we make call to API. So if it is getting used at in Angular as well as in React, that time we will end up loading a lot of duplicate frameworks. Okay, when there are environmental differences and some complexities attached to it, and the node package versioning is different across the applications, that time also this can happen. Each team may take their own technology and coding choices. That is also a disadvantage and can be seen as advantage some of the cases. So it's absolutely depend on uh, up to you how you see it. Yeah, I think that's all from my side for this particular session. So thanks. We do have a question and answer session after 1 hour. So yeah, I think over to you, Bhavin.
Hi.
Bhavya, sorry.
Okay, no issues, no issues. Thanks a lot, Ketan. That was a brilliant session indeed, and we got to know a bit about micro front ends. A lot of us did, like we have not really used it yet. So, if you have a little bit more time, maybe I would just ask our audience to ask any questions if they have, or they want to, discuss something.
Yeah, sure.
We could just wait and see in the chat.
Yeah, Jose. So there are multiple frameworks. So there are frameworks like, as I told you, single SPA. You can also have your own frameworks. You can build using iframes and Windows objects. So that event bus, basically, you can do the communication between them. Okay, so you can use that. So there are framework like uh, Frint.js as well. So these are some of the well-known frameworks which can be considered.
There is another question from Benjamin. He says, "What's the best way to, share a design system across all the micro frontends?"
Yeah, so if you talk if you ask me that question, like let's say I have a 3 portals or 5 portals, all of them are built with the same business domain. So that time what I will do, the common components like let's say text box, buttons and icons and lot of stuff which we use, we will use all across them. So those lies like those are kind of a common usable components. We can pick these components, can develop on our own and can deploy them on node, basically our own node package manager, and can install the same in all of the portals. But it's always recommended not to have abstraction while building the micro front ends. So but this component which will be used all across the applications can be considered for abstraction.
All right. Thanks a lot. There is another question from Mariam on our Pine Labs application. She says that how does it look like? How would this look like for a smaller, less complex project or a company? Would you recommend using it?
Definitely, if you have if the project is complex, as I told you, if you can separate that concepts by business domain, or either by technology or by something, there should be a complete separation, clear line you should able to see while planning. If you can see that, even the complex applications can be built using micro frontends, because it gives an uh, extra flexibility. Let's say in future you don't want to use Angular because it's old, or maybe you don't want to use React.js, it's having some problem, something new came in the market. You can get started with the new stuff on the same code base, and you can write your CI/CD pipeline for that, and it will get deployed and can be clubbed together. So all those React, Angular and the new upcoming frameworks can work together.
Yeah, that's a lot of good information. I had a question because you have
Mhm.
worked with multiple companies from Microsoft to Deloitte for Persistent, and then there are a lot of smaller companies. Could you
Right.
maybe, for because we are junior developers, you could, tell us the difference between how it's working for a giant versus working for a startup, and which one do you prefer?
So basically, when it comes to the startup and the top MNCs, the only thing I can see is the facilities part. We actually, when we work for Microsoft or Deloitte, we only work with a group of people, let's say 10, 15, 20, max 50 people. So it doesn't matter what the count size of the company is. If you have a good like even if you're working with a startup, that is also fine, if as long as you are learning. If you struggle early in your career, definitely you will get victory as early as possible. If you make some you are in comfort zone for your initial 3 4 years, definitely it will be painful for you later when you have more experience, because industry will demand something new and something challenging from you, or some challenge can you take up or not, that kind of approach it will take. So I will say it's not about the company. So always try, if you are learning something, go ahead for and join the startup also, if it is top MNC, that is also fine.
Thank you for that answer. Another one from one of our attendees. He is asking about, where can he find code samples or example structure for
Mhm.
this, micro front end. So could you just guide us to that?
Yeah, so on single SPA framework official website, they have shared some of the sample working applications as well. You can go ahead and clone their Git application, Git repo on your machine and can run it. Also, you will find numerous videos on YouTube, but it's quite new in the market still. I even can't see much material on it. So there is a concept called as shell, which I told you as a container. So most of the people, what they do, they develop their own shell, which will have their own custom logic of authentication, authorization mechanism, security related stuff. And on top of it, they will use this iframe or maybe event bus communication between the Windows objects, and will make it possible. So you can find it on GitHub for definitely.
All right. Thanks a lot. There is another question from Taranjeet. He's saying, I'm using an iframe to load another page inside his page using an URL. Can
Mhm.
single page SPAs like SPAs or there's some library friend.js load an app from a web URL so that he can remove the iframe?
I'm not sure about this. Maybe I need to check. I will not comment anything on this because I'm not sure about this.
All right, no issues. We'll have you for the Q&A as well, and the audience can ask all the other questions then.
Uh,
Thanks a lot
Yep.
for your time and thanks a lot for the talk.
Thank you. Bye bye.
Yeah, yeah. Bye. So with that, we are done with our fourth talk for the day, and it has been going great. So quickly again, I have the announcement wherein you can scan this QR code. It will basically help us put all the people from wherever they are attending on a map and create a visualization, and then you all can uh, we are probably going to share it with you all as well, so it's going to look really beautiful. So please scan this QR code and just do the needful. So I'll give another small 5-minute break and then we'll quickly start. Yeah, so hi everyone. Hope you all had a small break and we are back for the next talk. So, like we had another great talk from someone from Microsoft, Ketan. Next up is Nikhil Kumaran. His topic for today is React plus TypeScript plus Tailwind CSS. So Tailwind CSS, from my knowledge and from what I'm working on, is probably the fastest growing styling framework right now. And whatever experience I have had with it, it's brilliant. But I know, like, the learning curve is there, but it's brilliant. Something to tell you about Nikhil. He's a front-end engineer and he works with a company called Cloudera. He loves JavaScript and he has been working in React for a while now. He loves to speak, he loves to write, and he has been speaking at a lot of events. He's been writing blogs. So there's a lot of good content on your way. And rest, I would allow Nikhil to, maybe just introduce himself and take it from there.
Hey, thank you, Bhavya. Thanks for the introduction.
Yeah.
Can you hear me good?
Yeah, we can hear you. We can hear you well, Nikhil. Maybe you could just start with a small introduction, because I did not tell much, and then you can take it from there.
Okay. Sure.
Yeah.
So I'm Nikhil Kumaran. I'm joining from Chennai, India. So I'm a web developer at Cloudera. I've been using React for more than 2 years now, and I absolutely love it. So I'm happy and excited to speak at Global React Conference. So big thanks to Geekle for having me. So my talk is about UI component library. So in the next half hour, I'll be walking you through the processes that involve in building a UI component library. So let me share my screen and let's get started. All right, cool. Okay, so I don't have slides, so I'll be going through the code. All the links to the resources that I'll be talking about in this are available in this Notion page. So this is the tiny URL for this Notion page, tinyurl.com/react.js. So go to this and you will reach this page. So in this session, I'll cover the project setup for UI component library, developing components with React and TypeScript, styling with Tailwind CSS, documenting the components using Storybook, integrating our component library with the design tools like Figma, testing our components, hosting the Storybook UI to host, say, Vercel or Netlify, and publishing the library to NPM, and finally automate the publish process using GitHub Actions. So there is a lot of to cover. So let's get started. And so the first thing to before you do start with the component library is to have a design system to follow. So I have selected this Atlassian design system. So they have this all the components in Figma templates. All the assets are available here. So we'll be following this and creating the component library. Okay, let's start with the project setup. So there are two options available for project setup. So if you have used React, you have heard about Create React App for bootstrapping your React application. So similar to that, we have a tool called Create React Library. This is not officially maintaining by Facebook, but this is an awesome tool that you can use to easily bootstrap your library project. Or if you prefer doing it on your own, setting up your own roll-up configs and TypeScript and bringing in React and all the stuff, you can always do that. This is a really good article to follow and do all those steps. So I have done the latter one. So I'll just quickly go through it and get started with it. So the thing we need for initially is the rollup. So rollup is for transpiling and bundling your components basically. So we bring in that, and it also has a rollup config, and we bring in all the require dependencies for transpiling and bundling our component. So I'll get more into this in the build process later. Get more into that. And the next thing we need is, of course, React and React DOM. I'm adding React and React DOM as a peer dependency instead of dev dependency, because these two dependencies are required to run our component. So when we use our component in another application, when they install it, we require them to install React and React DOM as well to run our application. So it's been added in the peer dependency. So the next thing is TypeScript. So as you might have known, TypeScript is really awesome for, especially for component libraries. So because of all this static type checking and identifying potential bugs in the build time rather than in the runtime, and general code completion and intelligence and refactoring is also really good in TypeScript. Use TypeScript. So for all those awesome features, we are using TypeScript here. And also it has its own TypeScript config. This is a basic config template that's available everywhere, so you can use this. And another thing is we need to develop component is styling. So there are a bunch of options available, but I personally use Tailwind CSS for my personal projects because it's really easy to configure as well based on the style guides available. And also, by style guides, I mean the design, the specifications for the design. So, for example, here for the Atlassian design system, we have these sets of configurations available. For example, color, spacing, typography, and all those stuff. So you can configure those in Tailwind. So there's a Tailwind config, and you can configure all the colors and all the spacing that are available here. So based on your config that you give here, Tailwind exposes multiple, utility class names based on the configs that you give here. So with that, you can, rapidly start developing components. You don't have to write your own styles anymore. So you don't have to leave your JS or TSX file, and move to a CSS file and create your styles and then import it here, and all those things are avoided here. You can just use the class names directly in your JSX file or TSX file. So that's really awesome. I love that about Tailwind config, Tailwind CSS in general. So, and one more thing as well also. So if there is any change, so since we have this central config, if there are any change later, if the design system evolves and there is any change to the style guide, let's say, for example, the primary color changes, you can just add the primary color sets here, and it will reflect in all the components that we developed, as well as the apps that the apps that are using a component library. So if you have a bunch of applications in your company, and all of them are using this component library, and if you are about to change a style or make a spacing specification or anything like that, you can just change it one place and it reflects in other places. So that's a really powerful tool that we can that's really useful. And yeah, we are ready to start developing components, but before that, I would for maintainability of our library or in any project in general, we have to do sanity. We have to sanitize our code basically. So for that, we use linting and code formatting. So for that, let's bring in ESLint and the required dependencies and prettier as well. So this you have to do every time you commit your code, right? So that it gets the linting and formatting gets completed, and you have your sanitized code to commit. So I sometimes tend to forget that and just commit my code. So for that reason, I like to automate this process whenever I do a commit. So for that, we can add a Git hook, and on every commit, this will run our linting and formatting. So for that, let's use Husky. So Husky creates Git hooks. So there are a bunch of Git hooks, pre-commit, pre-push, and all those things. So we are interested in pre-commit, and you can add the commands here. But we only want to run our formatting and linting on the changed files. So we don't want to run it on every other file in our project, right? So whatever the changes that we did, we are about to commit on those files alone, we have to run our linting and formatting. So for that, we use lint staged. So lint stage will run on the specified extensions, but also on only on the staged files. So on those files, we run prettier, ESLint, and once everything succeeds, so if one of them fails, then the entire commit process is stopped, and it will again ask you to fix the files or fix the linting errors and then do a commit. So and then eventually, if everything succeeded, we add that to the GitHub and commit it. So this is really powerful, and you can use it to so especially if you forget to do sanitizing your code before you commit. So all right, that's about with the project setup, and let's start developing components. So let's start the simple button component. So since we're using TypeScript, we bring in define our prop types. So we can use interface or types interchangeably, but be consistent with any one specification. People tend to use multiple things, but I would say be consistent with anything. If you choose interface or if you choose types, and be consistent with it. I'm defining a few props here. So for based on the type, so it's based on the design system basically. So whatever the types you have here, this is primary, and this is subtle, and this is warning. So based on that, I'm defining my types here, and this is I'm defining it as an optional. So when it is if the user doesn't give any prop value here, then it will default to the primary. I mean the default to the button, the normal button, which is not primary, but it's normal button. So basically the normal type is normal. So yeah, that I have given the normal type here. So based on this props and based on these types, I'm having my Tailwind configs, Tailwind styles here, class names basically. So this is what I'm talking about. So if you use class names, that one thing it doesn't do is, if you highlight something, it doesn't show the actual style that is being applied. So but if you use a normal component without class names, let's say here, if you hover over it, or if you don't hover over it, if you see the color beside it, it says Tailwind. So there is an extension for it, Tailwind extension. So if you use that, it will show what's being applied here. So if I hover over this is translate text, and if I hover over this, it is question object. So it's really easy to add it here and visualize here. So that's one thing about Tailwind. So, and that's the disadvantage here for using class names. If you combine those class names, it's not showing up the pop-up for styles that is being applied. So it's one of the disadvantages here. So once you add the class names and add the class names here, and we have a button component. So we have the component, we added styles, but the one thing we haven't done is visualize the component. So for visualizing the component, that's where Storybook comes in. So Storybook is for documenting our components basically. It's for our development environment, and as well as for the end users to see what the component, what are the components that are available in our design system. So okay, I'm told to share the Notion page. So this is the Notion page. This is the URL where I can share it in the comments. I think I don't have permission to comment, I guess. Bhavya, did you get that link?
Yeah, I'll just share it across. Thanks a lot for it. Thank you.
where was I? Yeah, Storybook, right? So we need a way to visualize the components. So that's where Storybook comes in. So yeah, let's take a look at Storybook itself first, and then I'll explain about the stories. So what are the components? So you should define. Okay, let me start with the uh, installation process here. So Storybook has this bunch of add-ons. So the first thing that's main Storybook is the Storybook React. Now, although other things are add-ons, okay. So Storybook has these configs here in .storybook folder. So in the main file, you define what comprises a story. So here I mentioned the suffix should be .stories, and it should be one of these extensions, right? So if you create that file, and if the Storybook sees it, then this becomes the story. So if, for example, let's open this button stories here, and I'll talk about the add-on in a bit. There are a bunch of add-ons that we'll be talking about in a bit, and this is for customizing your Webpack config. So Storybook internally uses Webpack. So if you want to change something, so for example, here I added support for SVG. So, and I'm using SVGR Webpack to add that support that SVG component in a component format. So I'm adding this, changing this config. So if you don't have it, you can just leave it. And I'll come to the add-ons in a bit. Sorry, 1 second. Yeah. So as I mentioned here, this we should define the what comprises a story here, and if this file name matches, this will be considered as a story. So if you see here, the atom/button is this represents this hierarchy. So it should be so if I change it here, change it to components here, and if you see this button story will come under this component hierarchy. So this is basically to define the hierarchy. So for example, if you follow atomic design example, so that comprises of atoms, molecules, organism, and templates and stuff, right? So you can define, so what if your component comes under, for example, button comes under atoms, and for example a couple of items, let's say an input box and a button can comprise as a molecule or something. So that you can club those together in this format based on the hierarchy. And what the component that you should be rendered is provided here. I'm importing the button component here, and this is part of the add-on. I'll come to that in a bit. And this is also part of the add-on. And this is the basic syntax for writing your story. So you define a template and you bind the template. This name is coming is based on this. Did I save it? No. So this name is based on what you give here. It will come here with the space added. And this is for providing initial value. So for example, if you see here, only the label is required, others are optional with because of the question mark here. So so I'm giving an initial value for the label prop, and this is also part of an add-on. I'll come back in a bit. So if you see, okay, let me go to the add-on itself now. So there are a bunch of add-ons for Storybook that you can use. So first thing, let's look at control add-on. So this translates to what you have in your props. So for example, label is a text, so it's a text field. And type, if you see, it's enum, right? We have a bunch of options only. There's no other options that we can add. So that is added here as a select box. And obviously it's undefined because it's optional, so it's undefined. And if you change it to primary, then based on that the color changes. So that is represented here. And disable, if you see, it's boolean, so it is represented in the form of a switch. And if you notice here, the body background color is string, but it's represented in the form of color selector, color switcher, right? So that's because here I have added an archetype and the prop name, and I set the control to color. So this means, so in the context of TypeScript, it's still a string, but so this color and a bunch of others are part of Storybook itself. So this comprises the a type for Storybook, you can say. So the same way we have types for TypeScript, we have some types for stories as well. So that's one of the things is color. So if you do that, then this normal string field will become a color switcher. So that's also part of an add-on. And the second add-on that we can talk about is accessibility. So I've added here as well A11Y. So this one, as the name suggests, it checks for accessibility in a component. So with this, you can be sure that your component is accessible by different people in the world. So for example, how this works is it has some bunch of tests that it runs. So let's say if I change this color, I add this color. So instead of black, I added this text color gray 400, and it's barely visible, right? So then it violates one of the constraints that it has. So element must be sufficient color contrast, must have sufficient color contrast. So the background and the foreground, text color and the background color should have a sufficient contrast ratio. So this violates that. So we have it in a So this violates that. So we have it under violation. So you fix that.
Sorry to interrupt you, Nikhil. There is a bit of a background noise from your end. Maybe you could just check once.
Oh, okay. I'm sorry. Is it clear now? Or
your voice is clear, but there is a bit of a background noise. If you could just check it quickly, then it's fine, or you can continue.
Not sure where it's coming from. I don't know, like maybe I can come closer.
No, you are pretty clear, so that's not an issue. Yeah.
Okay, cool. Maybe I'll try to talk a little bit loud, so maybe that noise fades out. So yeah, so now if you remove that font color, then the accessibility tests are passed. So yeah, good to ship. So that's about the accessibility add-on. And let's go to the design add-on, or let's first see the docs add-on. Okay, design add-on is really cool, so I'll show that in the end. And so this is a default add-on by Story. So Story Source is the name for that add-on. So basically, it will. This is like more interactive part, and this is more like a documentation part. You can also interact with it. Okay. So it also shows the code for how to use it as well. So here it doesn't show that. So this is a default value. If you select normal, and it will be added here as well. So you can just copy, and so if you are app that using our designs, using our library, you can just see here and see what you need, and so see what the type you need. So and you can copy this and put it in your app. So it's easy to integrate your components with the application. Okay, now let's go to the fun, awesome part, which is the design add-on. So, I mentioned we are using Atlassian Design System, and they have their assets in Figma, right? So we can actually add this integration with Storybook. So, so what I did was I added. So this is the add-on. So Storybook add-on designs. So once you have that, it exposes a a function, and you can use it in a declarator. So once you do that, and if you add the parameters property, and have the type as Figma and the URL for it. So this URL comes from here. You can right click on the asset and copy the link to the page and can paste it here. So once you do that, it will integrate tightly with our application. So this will drastically increase designer and developer collaboration, right? So also this is not static. Okay, so if you change anything here, let's say if I change the color to green here, it automatically updates here as well. So everything is visible, right? Automatic updates here as well. So it's not static, it's dynamic, and it's really useful for designer and developer collaboration. So okay, that's about the storybook. And okay, let's do so we visualize the component, and let's start with testing our component, right? So for testing a component, I'm using Jest and React testing library, which is pretty much the industry standard for testing components. So yeah, the philosophy of React testing library is that the more your test resembles the way users interact with your components, the more confidence it will give you. So basically, your test should resemble the test that you write should resemble the user who is interacting with your component, right? So that way you can have more confidence on shipping your components. So that's exactly what we'll be going to do. So let's have test for the select component. So let me first show you the select component in the storybook, and then we'll talk about the design, talk about the test. So it's basic select component. It has a placeholder, and if you click on it, it will show the options available, and you can select any options here. And it's also searchable. So if you search for P, if you search for A, and the required results are filtered out, and you can select any of the options available. So we'll be testing this fairly. So let's start with it. So React testing library provides these couple of functions. So one is a render function, similar to React DOM, but it has little more functions to it. So it exposes different functions to it. So we'll use that to render a component here. So I'm importing a select component, and we are rendering a component, and we are giving it as option. So if you take a look at select component here, just quickly go through select components. So we have this menu item props here, which has value and label. So that's why we are giving value and label here, and the placeholder, which is string, and value, which is a string. So by default, if you don't give any value, the placeholder will show up. And yeah, so basically it has two components. One is the select component itself and the menu items component. So select component is just the what you see when you then click on the select component, and this menu items component is a different component that is, we have it in the same file. So let's start the test. So just provides these lifecycle methods before each, after each, and after all, before all stuff. So we'll be using before each to render a component. So basically, after every test file, React testing library will automatically clean up the code. It will remove the DOM, and it will remove a component as well. So we'll be using, we'll be rendering it every time for each test case here. So the first thing we'll be testing is the placeholder and the drop-down options hidden, because that's what the user sees first, right? So you'll see if the placeholder is available in text. So the screen object will have various query functions, right? Get by text, get by label, get by role, and all those stuff. So we'll be using get by text to get the placeholder, and we are expecting that it to be in the document. So we are checking that, and we are also checking initially in the initial state, the menu items will be hidden. So in our case, placeholder will happen, will show up, and the the menu items will be hidden. So that's what we'll be checking. So I'm checking the class name for it to have hidden. So if you see here, if it is not open, the state is so okay, the select has the state, this open state, and I'm getting it as prop here, and I'm based on if it's open or not, we are hiding it. So so why I'm checking for class names here, right? So internally just uses JS DOM for rendering your components. So CSS files are not loaded in just JS DOM. So basically, your styles will not get applied in the JS DOM. So what we are essentially checking here with this is it's kind of unit testing, so we are checking the functionality of it, right, rather than the visualizing the UI part of it, right? So for that, so I'm using a little bit of hack here. So I'm checking if the class name hidden is available, and hidden is a part of Tailwind CSS, right? So I'm pretty sure Tailwind CSS has the required styles applied, and I'm checking only for the class name. So, but if you have an inline style like this, see, if you instead of using classes, if you define it as an inline style, then you can use this kind of syntax instead of using a class name check like it's an hack, but you can use this cleaner syntax, right? So you can basically it checks for query by label. So the one more thing I like to add is difference between the get by text and query by label text. Get by label text and query by text, because query by label text even works, which means it will not fail if it doesn't find the element. So, but get by text will fail if there is no element that's matching. So even the query by text will not fail even the elements are not available. So for disappearance, or for if the query if something we are checking for negative parts, we will be using query by label text. And also there's one more link that I mentioned here for testing. Okay, I think I'll add later, but it has a few special cases where a React testing library, special functions where we need to use this kind of query by text or find by text and all those things. So I'll be linking it here in a while. So for disappearance, we will be using query by text. Basically, the negation, for negation, we will be using query by label text. And I'm checking if it is not visible. So negating that visible function. So so once we check that, the first case is done. And the second, what the user does is the user clicks on the component, right? So click on the select component, and we should list all the drop-down options available. So clicking on the component will should list all the components available, all the options available. So the user event. So we use for mocking the events, we are using the user event function that is testing library, and we click on it. The query for the event is here. So screen dot get label by text, and this is a text component here, select component here. So we will be clicking on this element. And once we do that, we will be this entire menu list will be rendered, and we are all I'm getting all the options available. So for this, I'm using find all by role. So instead of get all by role. So what the difference is that find all by role is async. So it will wait for a couple of seconds. So by default, just has a timeout of 2 seconds. So it will wait for 2 seconds until it finds an option role, basically. Get by all all the get strings are sync, and all finds are async, and all query selectors are for checking for disappearance or negation, right? So I'm waiting for it to appear and getting all the roles of the options. So basically, each element is each option is has a role option, and I'm getting all the options, and I'm checking with the options that are available here. So I'm mapping the rendered options and getting a text content out of it, basically all the text here, and then I'm checking if it is equal to the options and the label of those options, not the values, because the label has the actual rendered content here. Okay, now the user sees the drop-down options as well. Now the user selects the option, right? So the same thing, clicking on the, so since we are after each test, our component will will be cleaned up, right? So then we have to do the same thing again. So we have to click the select component and wait for the click the select component, and then click for the available option. So I'm clicking the Melbourne option, and after that, what happens? The Melbourne. So I'm getting the selected value label here. So you see the select component here. I will have. So this is the label for the entire select component, right? And this is the label for the selected value itself. So I'm checking if that label has this text content. The element has this Melbourne text content, right? And also, if you see, the menu items disappears once you select it. So I'm checking again that, and also the placeholder also should not be present. So I'm checking that as well. So here, if you see, I'm using the query by text and not, because we are not using styles. I mean CSS to class names. Basically, CSS class name to disappear it. We are using just just a boolean to not even render the component itself. We are not using CSS, so that's why it's we can use we can use placeholder. I mean, we can use the query by text and negation to test the invisibility, right? And once you select it, the another thing that is pending is a search, right? So we'll do for searching the options and selecting it. So again, we click on the select and we search for select and we search for stuff, search for options, and here I think we are selecting the same thing, Melbourne again. Okay, there are okay. The type is using user event type. So there are multiple events, right? Click event, scroll type, and all those things are available in the user event, and we are using the type event here. And the same thing, we are getting the roles and checking for. We are filtering out the options to be rendered. So here we'll be rendering only the selected options. We won't be searched options, basically filtered ones. We won't be render everything, all the options available. So I'm just filtering it out and then mapping it to the asset expert here, and then clicking on the Melbourne and checking for the selected value and checking for the menu items to be hidden and the placeholders will be hidden. So we covered all the aspects of what the user will interact with the component, and this is how the React testing library's philosophy is, and we followed that and we are done on testing. So this is one way to test our components. So there are multiple other ways as well. So we haven't touched the UI testing, right? So we just tested the functionality of the component. So for UI testing, there is the storybook itself provides something called as chromatic. I haven't used it. I'm excited to explore more on this. So basically what it does is it does a visual regression of all the components that are available in the storybook. So basically it's like taking a snapshot. So you can see the image itself here, GIF itself here. It takes a snapshot and it compares the snapshot with the previous version of the components, right? And then it will compare, and if there is any difference, there is any unintended difference, and it will show it. And if it is intended, we can go ahead, and it's like if there is a change in the primary color itself, then it will find it, and we can say if it's an known change, then we can replace the old version with a new version. But if it's unintended, we can check it and we can fix it to the previous version. So I haven't used chromatic, but I have used something called Puppeteer, which is a browser automation tool for testing, for end-to-end testing basically. So in that I have used a very minimal version of UI regression testing. So basically taking a screenshot of the entire page and then comparing with the previously taken screenshot, right? And compare it with using a pixel match library. So it's a very basic pixel matching library. So I've used that, but it's not that much effective. So one disadvantage I see is that if multiple developers work on in a project and they have different OSs, right? Different OS. So for example, the scroll bar, right? That will be different for multiple OS. So for Windows, we'll have a scroll bar, and for Mac, we have a different kind of scroll bar. So that so in the visual regression, that also it's been found out, and it is shown as a bug, right? So there are some limitations to it, but I think when you integrate with the storybook, it doesn't take the entire screenshot of the page, but it will take the particular component alone. So I think it's really useful, but I have to explore more on that, and I would suggest you to explore more on this as well. So yeah, now since we done with the tests, let's host our UI storybook UI to some hosting using some hosting tools, right? So I hosted this library, the storybook UI. So first before hosting, we need to build our storybook, right? So it is different from building our component itself. So building a component, I come to that later. But for building a storybook UI, the storybook exposes the simple build storybook command. So similar to how it exposes the starting the storybook, right? For starting a storybook, we can just do start storybook and the port number to where it has to open the storybook UI here. Same way for building, you can just use build storybook, and once you run that command, you will be shown, you'll be this file, this folder will be created, storybook static. This contains all the bundles, not for your component but for the storybook UI itself, for this application, right? So this you can host it. So I'm using Vercel to host it. You can use Netlify or any other hosting platform. So basically this will you have, so once you have your repo in GitHub, right? Give me 1 second. So once you have your repo in GitHub, you can link it with the Vercel. So basically, if you want to create a new one, you just have to create a new project, and you can link your repo here. So that's what I did, and I hosted it in Vercel. So one more good thing about Vercel and other platforms as well is that here it will provide you with this kind of bots, right? So this is similar to GitHub Actions that we will talk about later. But so what it does is, before whenever you have do a commit and you raise a PR, right? It will pre-build your application with that commit that you made, and it will show the it will deploy it in some URL, preferably with your commit hash. You can configure that as well, and you can preview the how the UI looks via this preview commands, preview URLs basically. So once you are satisfied with that, you can merge your code to master. So this is something that Vercel does, and also Netlify also does that. So it's really useful feature. Okay, once you are done with the hosting your storybook UI, let's start by building our library itself, right? So for that, the first thing that you have to do is you have to export all your components. So I have a button component here, I have an input component here, and I have a select component here. So what I will do is I will export all these components here in this index file, index.ts file. So, and also I'll add my styles here. So why we are doing this is, in the rollup config, we have given the input for the rollup to point to this index file. So whatever are available in this index file, right, those will be bundled and transpiled and then bundled together. So bundling process is pretty much like a black box. You can have these, so this is like a template. I just showed you this URL, right? Just use this similar template from this article, basically. So it has this. So we are using peer dependency, so we need to use this dependency, and we are using Node.js. So we are resolving with Node, and we are also doing CommonJS resolve, right? So so why we are doing this is because if you use TypeScript, and if you're not using CommonJS, then if another application that is not TypeScript using your library, then there'll be an incompatibility. So you have to transpile it to CommonJS, and then we are using TypeScript to transpile it, as well as to maintain the types for it. So and then post CSS for Tailwind CSS. So we are using Tailwind. We are configuring Tailwind using post CSS. So also while we are at it, I'm adding an auto prefixer also to have cross browser support. It will add the vendor prefix for you, and these two are related to SVGs. So we can import SVG either as an URL, like a image source URL, or else as an React component itself. So I'm adding these two as well. So essentially what we are doing here is telling the rollup to bundle and transpile whatever available in this index or TS file. So
hello, Nikhil.
Yeah.
I'm very sorry to cut you again, but you have a couple of minutes left, so please, we have our next speaker. So
okay, I'll just rush it up. So yeah, where was I? Right. So when you see here, this is the build file that is generated. So if you see the packages on here, just cleaning the build. So basically removing the build. This SSH is for removing RMR. So I'm using RMRF command, which is not supported in Windows, right? So this will add the support in the Windows as well. And I'm using an inline variable production. This basically for Tailwind CSS. So I'm using purge CSS for so this will remove all the CSS class names that are not used in your component. So if you use a couple of class names only, then those will be available in the bundle. Other class names will be removed from the bundle. So so if you see the build here, so after that, then there is rollup and -c. It will the basic build command. So once you do that, if you see here, all the your components are being transpiled into JS and then bundled together, right? And if you see the respective folder names and file names, only the types are being written, not the implementation, right? So implementation are part of this index file, JS file, and then types are part of this d.ts file, right? So once you have that build, okay, if you notice here, the build file is git ignored, right? In git ignore, I'm adding the build file also. So this is git ignore. So then how our application, for example, I'm having an example application here, and I'm linking our library here. The NK design system is the library name, and which maps to the name here in the packages. So here in the example application, I'm linking our library. So in your node modules, when you do an npm install or yarn install, here nk design system, here you will have the bundle file, right? How this is happening, because in our repository we're not having. See here, if it is git ignore and it's not available. Sorry, it's not available here in our git repository. Then how it's being entered? So for that, here in our in the application that we are using our library, we are asked to add post install. So it will be added in the readme as well. So the users using our library have to add a post install script in the package.json and then importing the CSS from the bundle available. So these two will be added. So I come to the so the disadvantage of having this is the obvious disadvantages. The user has to add it to to their packages on. But the advantage here is we don't have to commit our build files. So when you do a change to a source code and the build is auto-generated, you don't have to review it. But if you do a commit with that build, that also comes up in the the source control. And if you're having a big project or big PR, big feature, then it clutters the review process itself. So that's one big disadvantage that I feel. So that I'm not including a build in the in the source control in the GitHub repo itself. So here the build.js, what it does is, so basically it will cd into node modules. So this will be executed when an application is using our library, do an npm install. So it's post install. So once the npm install is done, then this will be triggered. So once npm install is done, we will have this nk design system in their node modules, right? So we are seeding into that and then doing an yarn build. Okay. So yarn build, as you see, it's the rollup config. It will remove the previous build and then trigger a new build. So because we are since we are doing that, that's why it's been appeared inside this node modules folder. Otherwise, it won't have to be available. So once, okay, I think I'm taking much time. So
yeah, I'm very sorry, Nikhil, but we'll have to cut you off. I think so. It's just the part wherein deploying it to Vercel. I think so our audience can maybe figure it out from a blog or something. Maybe you can add it in the chat and we can ping them. But thanks a lot. The session was really great. And we'll see you in the Q&A session, and maybe you can just help us there with all the doubts that the audience has. Yeah.
Sure, Bhavya. Thank you.
Yeah.
Thank you for having me. Bye.
Thanks a lot. Thank you, Nikhil. So yeah, we had another great session from Nikhil, and we'll be quickly moving on to the next one. So our next speaker is Zachary. Zachary Reece, his topic is something I feel which a lot of us would want to hear and learn from. I personally would want to for sure. His topic is maximizing productivity and managing complexity with Material UI. So to tell you something about Zach, he's an author of a best-selling user interface development course. The name of the course is Implement High Fidelity Designs with Material UI and React.js. He has been coding for his entire life, and he's also extremely passionate about education. His course has taught over 5,000 global students and is listed as #1 recommended paid course on Material UI documentation. That's something absolutely huge. I'm absolutely mind blown by his share introduction. Over to you, Zach. And sorry for making you wait.
No problem for the delay. Thank you very much. I'm very happy to be here. Let me go ahead and share my screen and we'll start the presentation. All right. All right. So again, hello, everyone. And I'm very excited to be here. So thank you very much to Geekle for having me. Like the moderator said, I have a best-selling course in user interface development on Udemy with a new course over the Jamstack coming soon. So I'm really excited about that. So be sure to follow me on Twitter to find out when that gets released. So let's go ahead and let's dive into how you can transform your React development with Material UI. So why Material UI in the first place? Like, why do we need this tool? Well, I think that most React developers run into a similar set of problems quickly after getting started. You've learned the main concepts of React, like components, props, and state, but there are still some questions when it comes to putting it all together in an actual project. There's so much that goes into a production application that it isn't really feasible to build everything from scratch for every project. That's why we want our React components to be reusable, so we don't have to rebuild them, which would be very tedious. So it also becomes a challenge keeping your styles and functionality consistent throughout your application and across multiple applications. So how do we manage this, make sure we're not starting from zero every time and we're maintaining some degree of consistency? Well, what would be great is to start off with a library of components for all of the common elements in web applications. Then you could customize those components to fit the look and feel of your application, giving you more time to focus on actual components and functionality. So that's kind of what Material UI provides to us, along with a lot more. So a component library also gives you mechanisms to ensure consistency by connecting components to a single shared store of styles known as a theme. So everything is sort of running off the same styles and you have all these components to build off of. So it gives you a really great place to start for your projects instead of starting from zero every time. So after you have solutions for styling your components and a set of components to build on, then you need to consistently and predictably arrange those components on the screen. So creating layouts like this can be complicated though, especially when you have really detailed designs. So it's a challenge arranging all of that content on the screen in a consistent way, in a way that's easy to manage. So we need some sort of system to help us do that. Now, once all those pieces are in place, you have to make sure that those styles and your layouts respond correctly to different screen sizes. They need to adapt the screen size, to the screen size and provide the best experience for your users, no matter what device they're on. So typically, we have to combine multiple solutions for each of these problems to get our project off the ground. But what would be great is to have all of it in one place. And that is precisely what Material UI does. Now, before we dive into Material UI, let's take a look at some other solutions to these problems and just use those to kind of highlight why I think Material UI is the best. So the first one that I'd like to explore, and the first other solution to these problems, is something it's been around for a long time. It's very popular as Bootstrap. So you may or may not have heard Bootstrap, depending on how long you've been doing web development, but it's been around for a while, I think probably before React itself. And it's not React specific, which is something that I think is important. So it wasn't designed for React, but there is a React version of it. So they kind of ported it over and rebuilt the features for React. Now, this means that it actually relies on the main implementation for features. So the main version of Bootstrap, and it isn't as responsive to developments in React. So when a new version of React comes out, it's not as likely, because it's not React specific, that they'll then build React features. So they're not as responsive to developments in the React ecosystem. Bootstrap also has a component library. So it does have a component library, but there's kind of a small number of components. It's not extremely large, and it doesn't cover everything that I think you would need for your project. These components can also be kind of difficult to customize, and it isn't always clear how to override the default styles. That's something that's really important with component libraries. If you're using a set of pre-built components, you need to be able to completely customize those. Now, they do also include a grid component that helps you arrange your content on the screen, and that also helps implement some responsive design. However, it's not a more generalized responsive design system. So you have the responsive design system for your layout, controlling the content on your screen, but outside of that, there's not really a responsive design system to help for more generalized problems. So that's Bootstrap. We'll take a look at another, which is Tailwind, which I believe we just heard a little bit about. Tailwind's a really popular CSS library. It's a great library, and it's used by a lot of people for styling web applications. But it's not a component library, though. So it's kind of a different thing. It's only a styling solution. So that is really helpful, because obviously, we do need to be able to style our components, but that's not really all. It doesn't provide all the building blocks that I would like. It doesn't have the component library and some of the extra features that I'm really looking for a tool like this. Now, because it's a general CSS library and it isn't React specific, and it doesn't have that React variant, again, that just means it won't leverage React whatsoever in terms of features or functionality. So I think that just leaves a little bit to be desired when we're obviously working in React. Okay, so lastly, although there are plenty of other similar libraries that do similar things to all the ones I've described, Semantic UI is another popular component library. Again, it's not React specific though, but it does have a React variant. So again, they took the original Semantic UI and rebuilt it for React. So I like that, but it doesn't even have its own styling solution. It still relies on the styling solution from the main library. So you don't have all the features. And again, because they're not taking React into account, they're not building it for React, you're just going to miss out on some functionality that would probably help you out otherwise. So like many other component libraries, many people say that customizing the components in this and overriding the default styles is not simple. And I think, again, that's just one of the biggest things that you have to keep in mind when choosing a component library. You have to be able to customize it to your liking. So obviously, what we'd really like out of our component library are a few things. So first, we want it to be built from the ground up for React specifically. So this is just going to get us so much more functionality and features because it's going to have React at its core. So this could give us really valuable features such as custom hooks that give us functionality that other libraries wouldn't be able to provide without a React specific version. So then when new React features are released, the library can then be updated with new APIs that enable more powerful or efficient workflows. That's something that other libraries that aren't really designed for React probably won't be able to do as well. Second, we also want more than just a component library with all the features we just described before. like a solution for styling our components, adding responsive design, and creating our layouts. So Material UI does all of this and more. So Material UI has completely changed my React development. It's completely changed the way I think about it, the way I work in applications, and has really given me a complete mental structure to use as I'm scaffolding out and building applications. It really gives me a solid guide to where I always, know the next step and have the pieces that I need to keep working. So it features a wide selection of components with powerful functionality, easy customization, and excellent explicit documentation, which is really important. It also has a great ecosystem with easy integration into popular systems like Next.js or Gatsby for even better performance, and it helps reduce boilerplate. Material UI was built explicitly for React, so it's taking advantage of React features at its core. It's not just a React port of an existing library that might have design decisions that either don't take React into, or that don't take advantage of React, or they might actively even work against it, which the port library, the React version, then has to work around. So best of all, Material UI is actively developed and maintained by a great team with an active and supportive community. So Material UI truly provides a solution for all of our problems in one cohesive and integrated system. So let's go ahead and explore how. So the component library. There are tons of Material UI components to help you get started on any interface. You then combine their components from the component library with your own custom components to create your projects. Some examples of their components are things like buttons, sliders, text fields, and here we can see many different text fields. So we have the we can set a text field as required, we can disable it, we can have validation with error styles, and we also have the two text fields on the bottom there with icons. So either a little user icon at the beginning of the text field or the show/hide password icon at the end of the text field. So their text field component has all that functionality baked into it for you. So it's a really great place to start. We also have drawers. So this is the little pop-out window from the side here. It's very helpful. We have loading indicators. So you can see at the bottom there, we have the spinner. So you can either set it to automatically just spin for as long as it's on the screen, or you can actually control the rate, you can control the progress and manually increment it. We also have badges. And so the badge is the little notification icon there. So we can add notifications to different icons or elements in our application easily. We also have a data grid component, and this is for managing tabular data and displaying data like this to our users with built-in filtering, sorting, and pagination. So a lot of functionality baked into this one component. So again, it just really speeds up your development. It's a great place to start. Now, just like regular React components, you can customize Material UI components using props. So one of the most common props that you'll find is the variant prop. Now, the variant prop allows you to select different styles of a component. So for example, here, you can use it to get a filled in, outlined, or plain text button. So you can see at the top here, we have the actual output, so the buttons across the top. And then in the code here, we are rendering different button components. So the first button has no variant, it's just the default, so we get just a plain text. And then the next button has a variant of contained. So that gives us that filled in look. Then the variant of outlined, of course, gives us the outlined look. And then we can also, use other props like the disabled prop to disable the button as seen here. So now that we've seen the buttons, we also have the typography. So a typography component is used for all of our text styles, And again, here we just pass the variant prop and then select the variant we'd like. So on the left, we see these different text styles at H1, H2, H3, and so on. And on the right, we see our typography components where we select the variant that we want, and those text styles are then applied automatically. So that is how we can use different props to customize the functionality of our Material UI components. And most importantly, the Material UI components all have excellent documentation for all of the available props for each component, along with a description of its functionality and the default value. So we can see here for the typography component, we have the name of all the props. So this is just a piece of them, but we have align, the children prop, classes prop, and then it gives us the type, so examples of it, the default value, and then a description of what that prop does. So with a library like Material UI, where you have such a vast component library with so many different pieces, it's really important to have great documentation so you can always go in and figure out exactly what's going on in your applications. So, all right. One of the most important aspects of a component library is flexibility. You don't want to be locked into the default styles, which is why Material UI has a clear and explicit system for customizing the components with your own styles. So again, like I mentioned before, when using a component library, you don't want to be locked into whatever the defaults are. You have to be able to completely customize everything. Like, it's always good, you need something to start with, but if there are parts that you don't like, you have to easily be able to change that. And so Material UI has done a great job making sure that that's the case. So there are multiple different options for styling your components and customizing them based on different scenarios that you might encounter. So we'll explore each of these throughout the talk, but we'll just briefly review them for now so that we can kind of get the idea in our heads. So the first option is a specific variation for a one-time situation when you just need one instance of a style. So just a quick one-off when you need to add a style. So then there's a dynamic variation. A dynamic variation for a one-time instance of a conditional style. So this still is just you need it one time, but the style is now conditional. So you could say if X, then be the color blue, or if Y, be the color green. So that's a conditional style. There's also reusable specific variations. So this is when you need to reuse the same styles in multiple locations. So if I have a button that I want, say I want it purple polka dots, and I want to reuse that button throughout the application, there's a reusable way for us to do that so we don't have to keep copying over those styles. Now, finally, you could also use a global theme variation, which is when you want to apply styles to every instance of a component across your entire application. So say the button in Material UI has a hover effect that you don't like, and you want to remove it for every button across your project, you can do that using the theme overrides. But we'll talk more about that in a minute. Now, Material UI components are also composable, which is a really powerful feature. This means that you can easily transfer styles and functionality from one component to another using the component prop. Okay, so the most common usage for this is turning a button or any other component into a link. This transfers the functionality of your link component for navigation into whatever component you pass it to. Any props not used by the main component will then just be passed down to the composed component. So here in this example, we have a button component and we pass the component prop equals link. So that's saying we want to take the functionality of the link component and put that into our button component. So then typically the to prop, so to/contact, that is usually just for your link components. But here, since we're composing a button and a link, we just put the to prop on our button. And since the button doesn't need the to prop, it ignores it and passes it down to the link component. And then the functionality works as expected. All right, so that's how you can compose components, and that enables a lot of really powerful functionality for combining things in different ways. So now let's explore Material UI's styling solution. So Material UI uses JSS, or CSS in JS, as the styling solution to bring the full power of JavaScript into our component styles. This means we're creating our classes right inside of our components, although you can move the styles externally if you wish. Personally, I like to have all of the styles and functionality for each component totally encapsulated in just one place, so having it all in the one component file. I think that's really clear. It's helpful having everything in one place, so you don't have to have different style files in other places and have to hunt around for where everything is. So this also enables really powerful functionality and flexibility, like generating dynamic styles based on the state of your application. So that's really powerful, and we'll explore that more in just a second. But here is our basic component, and we of course import React. We would have needed to import the button component, and then we import make styles from Material UI. We then create a constant of use styles, set it equal to make styles called, and then inside of there, we can pass it an arrow function that will receive our theme. We'll talk more about the theme in just a minute. But we then return from make styles an object. And that object has all of the classes that we want for our components. So previously, all your CSS classes that were in an external file, now you then create those CSS classes here in this style object. Then inside your component, so inside of our component my button here, you create the const classes equal to use styles. That sets up all of the styles that you created, and it generates the actual CSS. And then we can create our button component and pass it the classes.button class that we just created up above. So that is how we create our classes in our component and then tie it to the components that we want to style with those classes. All right. Now, Material UI components, they use the prop classes to allow you to overwrite any of the default component styles with your own custom classes. You can even only apply certain classes when the component is in a certain state, such as being disabled. Now, they also provide complete documentation on all the classes that each component has available for you to overwrite. That's under the component API section of the documentation. So that gives you all the overwrites that you might need for customizing your components. Then, of course, for regular JSX elements, we just use the class name prop as we've normally been doing. And then we pass the class from the JSS class that we created. So in this example, we can see here the button component has two classes being applied. To the root of the button, which is just the button tag itself, just the base button tag, we'll get the classes.logo container class, but then we pass disabled. So that class, the classes.logo disabled, will only be applied if that button has the disabled prop of true. So you can see how they give us the really powerful ability to apply certain styles, not just to the component, but also to the component in certain states. So that really enables some powerful functionality and flexibility with our styles. Now we also see the span tag here, and that, of course, as a regular JSX element, just uses the class name prop instead of classes. All right. So dynamic styles is probably the most powerful feature of using JSS like this. So we're able to dynamically generate our styles based on the application state and props. So we can easily pass whatever data we'd like into our styles and then use that data within complete functions inside of our classes to determine the component styles. Leveraging this feature, we can make our components extremely flexible and reusable for many different cases. We can see in the example here the component quantity button. Okay, and we're passing that quantity button the props white and round. We then take those props white and round and pass them to an object inside of our const classes equals use styles. So we pass the props into use styles, and then up in our style object inside of make styles, we can then destructure those props that we passed. As you can see, for the background color property, we set it to a function where we destructure out the white property and then check if white is set to true, then we use the background color white. Otherwise, we use the background color of black. Same for the border radius. We set it as an arrow function and destructure out the prop round. And if round is set to true, we'll use a border radius of 50 pixels, otherwise 0. So this is really powerful and enables such flexible components because we can completely alter the styles of our component based on props. So it's really powerful and such a simple system for us to be able to do that. Now, sometimes you'll want to reuse your components throughout your application with the same style. So for example, like a button, that we want a certain styled button that we're going to use multiple times throughout the application. Now, we of course don't want to just copy those styles over and over. So what we'd really like to do is we can create a new copy of that component, which automatically has our desired styles applied. So in this case, we create a const of styled button equal to, and we have a styled function for material UI, where we can then pass that, the component we want to style, and then call the result of that function and pass an object inside. So that's that second set of parentheses after the styled button, and then with the object inside of there, pass the styles that we want to apply. Now we can just use that styled button and all those styles will be applied automatically. So you could imagine in other parts of the application, we could then just import that styled button and we'd see those styles without having to copy over the styles every time. So we just have to import that style component and use it as usual. So a lot of really powerful functionality when it comes to styling your components in Material UI. Now, extending the power of the styling solution is the theming solution. Now, Material UI provides a default theme for the application, which we can then customize, overwrite, and extend. The default theme is a collection of styles and utilities that you can use throughout your entire application. So everywhere in your application connects to the one theme. The default theme is a collection of styles and utilities that you can use throughout your entire application. And some of these include a collection of drop shadows arranged from lightest to darkest. So you have an easy selection of shadows. They have colors for common events like success, error, warning, and information. So you can have consistent coloring. And there's also a function for calculating consistent spacing and even more. That's all inside of the default theme. Now, your primary use for the theme is consolidating commonly used styles in one centralized location instead of having them spread out randomly throughout your entire application. This way you have everything in one convenient place. You don't have to go hunting around looking for different styles. And you can access the theme from your component classes, making it an excellent repository for all your styles. So the classes that we've shown before, we can access the theme inside of those classes and just reference the one central place. And that way, all of our styles will just be referencing the theme and we won't have everything distributed throughout the project. So the theme is broken into a couple different sections. So the typography section of the theme is used for centralizing all of your text styles. So they break down the text for each of your H tags, like H1, H2, and so on, and also give some other options like body 1, body 2, subtitle 1, subtitle 2, or caption for different text styles that you may have in the application. This makes it so simple to maintain consistency throughout your application using an explicit hierarchical text system. So as you're coding, you just have to use the typography component and specify which variant you'd like to have those styles automatically applied. So you can see here, we're using the create MUI theme from Material UI to create and customize our theme. And we're passing inside of the theme object a typography section. That typography property itself holds an object. And here we have H1, H2, and all the other H tags. And we can specify the text styles that we want applied for that variant. Then in our code on the left here, you can see we just import the Material UI typography component and then use the variant prop to specify which variant from our theme we'd like to have applied to the text inside. So here we've selected a variant of H1, so our H1 styles will then be applied to the text hello world. So this is a really powerful system. So you have this very clear system of your H1, H2, H3. So it's organized. You can make sure that H1 is your largest, down to H6 being the smallest. And so as you're coding, you don't really have to think about your design. You just have to remember what it is in your theme, and you're not having to recreate these every time or make sure that you're using 4.5 RAM in every single place. Maybe one place you mess up, you only do 4. No, with this, you'll have everything just referencing the one place, making it extremely consistent and maintainable. So then there's the palette section of the theme. And this is used for centralizing all of the colors in your application. Now you have a few different options for setting colors in the palette. So first is your primary and secondary colors. And these are special colors. So here we can see on the right, the palette, and then the primary and secondary. And each of those has a main color inside of it. Now the primary and secondary colors should be the main and the accent colors for your brand. So whatever your main brand colors are, those should be the primary and secondary colors in your theme. Now, because these features, these colors, the primary and secondary colors, they have a unique feature where you set just the primary.main and then the secondary.main, and Material UI will actually automatically generate a lighter and darker version of those colors for you. So here you see I set the theme.palette.primary.main to our green color, but it also now generates a theme.palette.primary.light and a palette.primary.dark. So if I just need a lighter version of a color to highlight it somewhere, or a darker color to maybe disable it and color it out, well, then you could use those automatically generated colors to get those variants. So now we can see on the left where we're actually using our classes, creating our style object. We have the class drawer, and we're setting the background color to the theme.palette.primary.main. So you're not having to reference and copy over the same color every time. You just reference it inside of the theme. And this enables a lot of really powerful functionality. So then besides the primary and secondary colors, you have the common object. And that is used to hold all the other colors in your application. So you can see here, the common, we just have the tan and red colors. So again, that way we don't have the same color code all over the application that maybe if we want to go and make a change later, now we have to hunt each of those down. No, here we just reference it from the theme. And now if we wanted to change this red, maybe to say a darker red, we could just change that one constant of red in the theme, and then that will now be reflected everywhere in the application because they're all referencing just that one spot. So the theme has a direct impact on the components in the component library. So your primary and secondary colors that you set in the theme palette will be used as the main two colors for all the components from Material UI. So whenever you then import those components, they'll automatically have those styles applied, eliminating one step towards customization. So we can see here at the top, we have the output, the buttons, primary and secondary, and we have 2 switches. And we see in the code that we can pass a color prop. You can set the color to primary or secondary, or the switch actually just has that secondary color applied by default. So as soon as you import the component, it's going to have those colors applied that you set in the theme. So that automatically enables just one extra level of customization, kind of speeding up your workflow for you. The theme also provides a section for overrides. So this is where you can specify application-wide styles that will override the defaults for every instance of a given Material UI component. So in this example, we set the overrides for the MUI chip component, which is just a little display icon basically. And here we want every single chip in the entire application. Every time we import the chip component and use it, we're setting the background color on the root of the chip, and then we're changing these text styles for the label. So this will then be applied to every single instance of that component throughout the application. So it's a really nice way, a nice place for us to add our overrides. So now if you need to make changes to the fonts, colors, sizes, or any of these other styles, you just have to change the theme and you'll see it reflected in every instance throughout the application. This is exceptionally maintainable. If you ever want to try out new styles in the future, you can easily adjust the theme instead of hunting down each individual usage. You could even save multiple themes for different events like holidays or promotions that go on within the company, and then you could use that to easily reskin the entire application at once. So now we have our components, we know how to style them, and we can consolidate our commonly used styles in the theme. Now we need some way of arranging those components on the screen in a consistent manner. So Material UI provides a grid component for arranging our content. It's essentially an abstraction of Flexbox and provides a straightforward system for managing our layouts. This system is built on a 12-column layout like many other grid systems. So there are grid items and there are grid containers. The grid items are the actual components or content. So that's what you're actually wanting to display on the screen. And then the containers simply hold those items. Okay, then we can use different props to align those items within their respective containers, and we can assign the number of columns that an item should span to determine its size. Containers can also be items of other containers. And so by combining these item containers and changing their distribution and their direction, we can create interfaces of arbitrary complexity. So we can create basically anything we can imagine by combining this grid system in this way. So I want to take a break real quick to show off a demo of this grid system, just because Material UI documentation has a great example for how this works that I think illustrates it very well. So let's flip over to Material UI documentation.
Sorry,
Yes?
Sorry to interrupt you, Zach. You have a couple of minutes left.
Couple of minutes left?
Yeah.
Okay, sounds good. Okay, so here's a demo of the grid system in Material UI. We'll just go through this quickly then, since we're running out of time. But each of these boxes here, each of these cells is an item inside of this overall space here, which is our grid container. So these are all items inside of this container. Now, first we set a direction. So the default direction is a direction of row, which would be horizontally. So we have the cells laid out horizontally from left to right. Now, then you have the justify and align items props to change the alignment of those items within their container. So we have the justify prop, which modifies the main axis. This is a common misconception, or at least something that I struggled with at first. I thought that the justify prop always controlled either up or down, and then align items always controlled left and right, but that's not the case. So justify, it affects the main axis. So for a direction of row, the main axis is horizontal. So if we want to align these items to the left horizontally, we'd set a justify of flex start. If we want them at the right, we'd set a justify of flex end. I'll go ahead and center those back up. Now, if we want to move them up vertically, if we're in a direction of row, then we would use align items, because align items uses the cross axis, so the opposite of the main one. So if we're in a default direction of row, the cross axis would be the vertical axis. So if we want to move them up, we can use flex start, and down flex end. So basically, by combining the different alignments and setting the direction from either row or column, we can create any layouts that we can imagine. And for an example here, you can see that combining this allows us to create a complicated layout with many different elements. And combining these all in many pieces is how we create our entire application. All right, let's go back and finish this up. So responsive design, we'll move quickly through this, but responsive design is integrated in Material UI to ensure that our styles and layouts look perfect on any screen size. So Material UI essentially provides these breakpoints. So extra small, small, medium, large, and extra large that represent different pixel sizes for your screen size. So then they have media queries that we can call that are stored in the theme to check if we are currently at one of the given screen sizes. So they have the different media queries in the theme.breakpoints.down or theme.breakpoints.up. So if I wanted to check if the current screen size is at or below the medium breakpoint, we could use our theme.breakpoints.down for medium. And same for small, or if we want in between a certain range or any of these ranges, this allows us to accurately detect the screen size, and then we can use that screen size to make changes in our code. So here in the classes, we can see where we're creating our style object. Here we have a class of container, and we're setting a margin bottom of 8 rem. That is going to be applied for all screen sizes by default. But then you see that we call our theme.breakpoints.down and pass in the medium key. And so now the styles inside of there will only be applied to screen sizes that either match that they are at or below medium. Then we can do .down for small. So now we'll only set a margin top of 2 rem for small and below, and then a margin top of 1 rem for extra small. So by creating our breakpoints like this and setting up conditional styles for different breakpoints, we can completely change the look of our application and optimize it for mobile users. So the responsive design system is not just integrated with our classes, but it's also integrated with the grid system. So we can specify that items should take up a certain width at different screen sizes. So in these examples here, we can set the items to take up 100% of the screen size. So that would be 12 columns, or we could say just 6 columns, but only at small breakpoint and up. And then at the extra small, then it should take up 12. So we can see the second line of boxes here on the first screenshot. They are just 2 of them sitting side by side. But then in the smaller screenshot, when we're on a extra small screen, the extra small of 12 kicks in. And now instead of sharing the line, they're both taking up the full width across. So we can specify the number of columns for each of our items and use that to, again, adapt the layout based on screen size. So we can adjust our classes, we can adjust our layout, we can even adjust our content based on responsive design. So Material UI provides a use media query hook, which you can see here. We pass in our theme.breakpoints.down, and that will return a Boolean for whether or not we match that current screen size. So here I create a constant matches MD. So if we are at or below the medium breakpoint, And then we could define, say, our tabs for our desktop website and a drawer for our mobile links for our mobile website. And then we can check if matches medium is true, render the drawer for our mobile site. Otherwise, if we're not at a medium breakpoint, then just use the tabs because we must be on a desktop size. So we can change our classes, our grid layouts, and our content itself. So to wrap up, the influence Material UI can have on your productivity and workflow is just unbelievable. It will completely change the way that you work in React. There's going to be a lot less boilerplate, and you'll be able to prototype faster because you have all these components to start working with. And so you can just import them and really easily build out interfaces to test concepts before you have to do all the hard work of building it out to a production design. You can just throw things together with the default components and get the concepts working. So much faster prototyping and iteration. So Material UI really does provide a one-stop solution for everything that we need in our application. It provides the component library, our styling system, a theme system, layout, and responsive design to make sure that all of those look perfect on every screen size. Now, normally we would have to have a bunch of different solutions, all isolated, independent solutions that we put into our project, and then we'd have to figure out ourselves how to make them all work together. But Material UI provides everything we need in one package. And so each of the systems inside of it can all talk to each other intelligently. So we don't have to coordinate that ourselves, and it just gives us everything that we need. So lastly, one of the best benefits that I think you can use Material UI for is before you even start coding, take the design file of the project you're about to build and go through and convert the design file into your Material UI theme. So get all your text styles in your variants for your typography, all your colors into the palette section. And then when you go working and building your application, you won't even have to think about the design. You'll just be able to reference the theme. And that will really speed up your process and just streamline your entire workflow. So I really think using Material UI to its full potential will significantly streamline your development and provide you with an explicit, scalable, maintainable foundation for all your future projects. I think you should definitely try it out today. So thank you very much for listening. Thank you very much for Geekle for having me here.
Thanks a lot, Zach. That was a brilliant session without a doubt. So yeah, we have extended the session. I would quickly add Nikhil and Ketan for the Q&A session. So yeah, just give me a minute. I have a quick announcement for the attendees here. So we already have heard 2 out of the 8 sessions that we have in all. Our next flash prize is for Angular.js Global Summit 21. Angular has changed, and what's new? Angular 9 Plus is a hot subject of discussion in professional communities, and what's the migration process? So we'll have talks from people across Microsoft, Google, Samsung, and a lot of others. And so do go ahead and register for it. We have 20 tickets available right now at $79 with a promo code of React Flash, all in caps. So I'll just add a link to that, and please don't miss out your chance to register. Coming back, we have the question answer session ongoing, and we can start taking questions from the attendees. So while the attendees write down their questions, I would just like to ask Nikhil and Zach, because Zach was very ups on Material UI, and Nikhil talked something about building his own React component library. So can you just tell me like which way one should go, and what scenarios like building our own component library would really help?
So it depends, right? So, for example, you can still use Material UI instead of Tailwind in your own library itself. For example, you have so Material UI provides basic components like buttons and select components and all those stuff. So if your app or if your company has a bunch of apps and they require common components, let's say composing of those components, right? For example, composing an input box and a button and select and some other components together, and having it everything in your component library, doing it everything in all the composition from the Material UI in your component library, and then use that component library in other apps will drastically improve your reusability of the components, right? For example, Zach talked more much about theming and configuring Material UI, right? So if, for example, you have 5 apps and all those apps have the same theming and same styles, right? So instead of configuring everything in all the configuring Material UI configs in all other apps, just configure it in your component library, and then use your component library, expose all the components that you compose, use it in other apps. So that way it's really having your component library is really useful. So a bit about Tailwind and Material UI. So Material UI provides, as I mentioned in the end, it provides an integrated solution, and Tailwind is for it provides a very basic element of styling, right? So if you have your own design system, and if you have your own design styles, and everything is developed from scratch, and you have a brand in your mind, and you are going to build a component from scratch and design also is from scratch, instead of using Material UI and customizing it, for some use cases it will be better to build it from scratch itself. So I have seen some few startups, and they have they are thinking about the brand ahead itself. So take example of this one, Atlassian itself, right? So they have their own design system with their own styles. So and they have this Figma thing I showed. So they started building their own components, and then they have started exposing like similar to Material UI, but they are not configuring all other themes. So what I'm saying is, so if you are trying to start everything from scratch and you have your own theme, then go for Tailwind CSS. Or if you want an integrated solution, and if you want to only use the reusable components that Material it's exposing and composing those components, then go for Material UI.
Yeah, I definitely agree. I think that in a similar sense, you could start with Material UI as the base component library, and then sort of build your own component library on top of that with the customizations and the custom components that you need along with that. And so that way you're still not having to start completely from scratch, but you're still building up you're still accumulating the components that you reuse throughout applications to build your own component library on top of that. I think that'd be the way to use it.
Agree. Yeah, so we also have one of the product, Fluent UI, built by Microsoft developers, and it's open source. So in one of my project, I already started to work on those Fluent UI instead of using Material UI. So we might think about other design systems or ready-made controls we have. So those stuff also we can pursue, because we can pick the best of the world from Material, as well as some of the stuff from Fluent UI, and we can extend it as per our need.
Yep.
All right. Ketan, I had another question for you. I wanted to ask, maybe others can answer as well. So I wanted to ask, like in these virtual times, there are a lot of Zoom calls and a lot of people, very active on Slack. So how do companies like Microsoft are tackling, issues like Zoom fatigue or, overloading of Slack notifications? So do you all have anything, around that, or you all are doing anything around that?
Actually, we are using Microsoft Teams, so all of Microsoft products we are using. So it's much better. I love the way the Microsoft team has evolved over the period of last 2 years. So it's like we never felt like we are working from home. So when we were used to work in offices, we used to have all meetings on Teams only. So we will have all the recording files and everything at one place. You can also connect with your Jira, ADO, Azure DevOps as well. You can queue your triggers. There are chatbots also you can implement. So a lot of cool stuff are coming. Even I can take my interviews on teams as well by installing some of the plugins like Code by Vivana or some. There are multiple extensions. So I love to use Microsoft Teams. Recently, I've started to use Slack as well for some of the community related conversation. But I never felt like I'm working from home when I'm on Teams.
So anyone would like to add like how you all are doing it at your companies?
Same, right? We use Slack and Zoom, but it's not overloading in the sense. Maybe it's not overloading for me. I'm just at an entry level position. Maybe for higher level managers or stuff, though they will have overloading of meetings and questions or something like that. So yeah, so we respect our each everyone's time, and they might have their own need and stuff. So Slack is basically for asynchronous communication, right? So we put our message there and we wait for them to reply. It's not instant messaging, right? So yeah, so we respect our each other's time, and we give our space there, and we try to get through this COVID situation.
Yeah, I work at a small company. I'm the only developer, so I don't have to really worry about coordinating all this. I can basically sort of just go on autopilot. So I haven't had to deal with that very much.
Okay, that's nice. Another quick question I had, maybe everyone could share their thoughts about. So, because we are moving to a skill-based world wherein the skill matters the most. So, do you all think degrees like doing a postgrad degree would be relevant? Maybe today it is, but maybe 5 years from now, would companies or new startups would be looking for degrees, or it's just going to be all skill in future?
Yeah, I agree. It's all about skill, what you have. It's never about a degree. Even the postgraduate programs which are running in the market, I also feel like try to pursue free courses first. Try to explore free courses. Try to check for the available material on Udemy, even on YouTube, instead of going for the paid courses. If still you feel like you need that degree and you are not getting the things, so then you can reach out to the people. I think it's all about skill these days. It will be like a techno manager kind of a role in coming years. It's already there, but it will be more technical. The person who is developing will play scrum master role. He will interact with the customer, end customer also some of the time. So I feel it's skill.
I definitely agree with that. I think that things are just changing so quickly now. Like React is only like 5 years old or something like that. And so I don't think that traditional education and getting a degree, I think that they have a harder time responding as quickly to the fast developments in technology. So I think that it does have to be sort of skill based, because it just by the time you get a degree, the things that you've learned are already starting to be, there's already new stuff to learn. And so I think it's more important to prove, your knowledge and ability for those, the new developments and for the things that keep coming out, rather than just one fixed set of skills. Like I had someone who graduated recently with a computer science degree and didn't know how to build a website. So I think that, if it depends obviously what you want to do with your degree, but I think that I don't know, skill based is definitely where it's going.
Yeah, definitely skill based, but certain skills can be achieved learning through online courses, YouTube videos and articles. But for example, like data science and machine learning, those, if you take one machine learning course, you're not a data scientist or machine learning expert, right? So for those things, I think a specialization is necessary. Not to have a degree or certificate per se, but to gain those knowledge, you have to read a book and you have to write research about it and stuff. So those achieving those kinds of skill in tech, that it's not about degree but where you learn it. So for now, I think getting a degree will get you more information and more knowledge in those
Yeah,
areas.
even if you say like data science and machine learning, and also it's all a buzzword, people are really learning. I'm also part of it, But if you don't get chance to work on actual live projects, so it doesn't make sense to have a degree in machine learning and data science. I've seen people taking courses in my organization also, but they're not getting assigned to the project and they are really struggling. So the React is the only bread and butter I see, apart from my skill set like Azure, .NET, and Java, all those traditional web development ways of developing the applications. So I feel React and the front end will never die, because to talk to the actual end customer, there is a front end. So I choose to pursue this further. I got assigned, unfortunately or fortunately, to one of the React project, and it was really new 3 years ago. And recently I started to work on React Native as well. So it's all about luck and how you respond to the opportunity. So it's not about the buzzword if you are really learning it or not.
Yeah, thanks a lot. Thank you for sharing your thoughts. A couple of questions from the audience. So Marta is asking, is it important to use TypeScript in all component libraries, or we can not use it? Because probably Nikhil, you used it in your storybook application that you were showing. So is it important, or we can avoid using it?
It's not a must. You can use JavaScript to build your component library, but if you use TypeScript, there are tons of advantages, right? So there is a bit learning curve to it, but you can start slow. You can just start with the prop types and you can build on that. So the main benefit you can see is first the static type checking. You can find your own find bugs very early and fix them instead of going into the runtime and occurring in the runtime. So one is that, and another is it has really good intelligence and code completion, right? So if you are using, so I actually got one to show you, but I can't show you in the demo that I did. But the thing is, you even if you build a component library and you bundle it and transpile it, you retain the types for it, right? So and then if you use it in a JavaScript application instead of a TypeScript application, you still get those types. So if you type, for example, button type, I have added these four, statuses, right? So that one will be available in IntelliSense when you import your component and use it in an application, even if it is JavaScript application. So for those things, I think basically using TypeScript is really useful in those cases. But it's not
All right,
a
thanks. Yeah.
Yeah.
Another question, maybe I would want to ask that to Zach. So it was about the styling in Material UI, because you did a lot of component level styling. Maybe you were injecting the styles, or you were doing it in a styled components format. So there is someone who's asking whether we can separate the styles from the component, like maybe use a style sheet or something.
Yeah, totally. That's a question I actually get a lot in my Udemy course when people are learning Material UI. A lot of people have that question. Like I said in the presentation, I like to have everything in one place. When I open up the file for my component, I really like having, I know the styles are up at the top, and then the actual content is being rendered down below. I like having that all in one place. I feel like for me, it's just easy to scroll up and down and just find everything I need in one place instead of having to kind of hunt around. But you can really easily create the style object that I showed using the make styles hook from Material UI. You can use that in an external file and just then import that into your component and then create your classes using the external style object, and it'll work just like normal. So that is possible. It's just a matter of preference.
All right, thanks a lot. We probably have time for one more question. So maybe everybody could add to this. A lot of front-end engineers are here, myself being one. So there are, could you maybe tell ways or suggest things, how a front-end engineer can stand out? Basically, he'll surely run front-end well, which is React or Angular or whatever library he's working on. But apart from that, what he should learn or, he should gain knowledge about to stand out from the rest.
Well, I honestly think that the most important thing that you can learn as a front-end developer is going in depth on just JavaScript itself. I feel like a lot of people, myself included, for a long time, knew this tiny little bit of JavaScript, kind of just the surface level. Okay, I know how to make arrays and variables, and now I'm going to throw together a React project. When I think that, if you take the time to dive deep into the language and really understand kind of some of the nuances behind it, some of the tricks, some of the, really understand how the language works, it makes your React code a billion times better, because you're just going to be so much more intelligent about the way you structure your code. The structure of the code itself will simplify the functionality that you have to add later on. And I think that those sort of decisions and insights can only come from a deep understanding of the language. So I say dive deep into JavaScript and really master the language.
Yeah, right. So if you do that, then you'll also get to know about Node.js as well. It's basically JavaScript. So then you have some knowledge on backend as well, right? So diving deep into JavaScript and getting to know about it, and learning more about TypeScript as well will definitely make you a better developer.
Yeah, I agree too, and I would like to add to that is it's not only about the technology, it's all about the people who are going to use it. So you have to understand and absorb the things around you. Like, let's say you are using LinkedIn every day and how they are using UI UX there. So you can anything you can pick it. You can, just like a sponge. When you drop that sponge into an water, it becomes heavy. Just like that, you are empty, feel empty yourself every day. Try to dive into to grasp some knowledge so that you will feel heavy, and start sharing with the people, and also take help from people and also help others. So that's the mantra.
Thanks a lot, Ketan. That was really a great way to end this. So we have our time done for the question answer session as well. I would like to thank all of you all again. All of the talks were really great, and looking forward to maybe in the next upcoming events.
Thanks for
Thank
the
you.
opportunity. Bye bye, take
Thank you.
care.
Thank you, everybody.
Yeah, bye. So I would just have another announcement for all of us. It was related to the Angular workshops. There is an incredible opportunity to get the best practical knowledge and hands-on skills by registering for all our Angular workshops. The slots are limited, so don't wait and grab your ticket now. Just follow the link in the chat and check them out right now. And then we'll be having a quick 15-minute break. We have 13 minutes to be exact. And that's it. That's my time. Thanks a lot.
And hey, Nick here. And before that, we have not forgotten that we were sharing the QR code. And you should join me. Yeah, because you were announcing that. So yeah, let me just pull up the map that we got. Was just a little experiment that we did just to see where are everyone watching us from. So one moment, and here's the map. So it actually like more than 100 people scan the code and share their location, and it looks interesting. Like we really have the audience from the whole world, even the people that started watching us during the middle of their night. Yeah, so what I want to say is thank you all so much for coming, for joining, for watching our conference. And well, I can share the link if you want to this map. Well, I don't have much to comment on that. It was just it's more interesting to show from the whole scale. I don't want to get into details, and also want to give you guys folks break to get some rest before the next block. I also want to thank you, Pavia, for moderating. Yeah, we'll continue. We'll continue in 10 minutes, I guess. Thank you.
Yeah. Thank you, Nick. Thank you
Thank
for
you.
this opportunity.
Okay.
See you after the
Yeah.
break. Bye.
Yeah. See you.
Yeah.
Hello, everyone. My name is Chrissy, and I'm so excited to be here with you today for our React.js Case Study Festival. Today, I'm broadcasting from Kyiv, Ukraine. Make yourself comfortable because I'll be with you for the next 6 hours until 2 a.m. my time. So you know I'm committed. So in the next 6 or so hours, we will have 7 speakers, 2 Q&As, and some exciting announcements, and a sponsor, actually. So that's amazing. So stay tuned. And be sure to stay active in the chat so we can prepare your questions for the speakers ahead of time, if possible, of course. I'll be keeping track of that. Don't hesitate to share your opinions with one another and be open to new knowledge and ideas. So with all of that being said, let's say hello to our next speaker. So before I pull her up on screen, let me tell you a little bit about her. So our next speaker is Adora Nwodo. Adora works for Microsoft, and today she will be telling us about 7 habits of highly effective engineering teams. Nana Adora Nwodo, who fondly likes to be called Adora, which is such a beautiful name, is a software engineer based in Lagos, Nigeria. She currently works at Microsoft, where she builds cloud services and high-value experiences related to artificial intelligence and mixed reality. In 2018, she created a blog called Adora Hack, where she publishes articles on software engineering, productivity, and career growth. In June 2019, she created a YouTube channel for Adora Hack, where she posts tech content that could be useful for software developers. Adora gives talks at technology conferences worldwide. She's extremely passionate about the developer community and is trying to drive inclusion for women in technology, which is amazing. She co-organizes community events, contributes to open source, and speaks at conferences and meetups. So that was a lot. Let's get her up on screen. Hi, Adora. Oh, you're muted. There you go. Hi, welcome.
Thank
For
you.
starters, wow, like I just said, what a beautiful name.
Thank you.
Thank you for coming and joining us here today. How are you feeling?
I'm feeling well. Thank you. Thank you for having me.
Oh, it's our pleasure. And I think we have so many exciting speakers at this event lined up. And for the next, well, I mean, we've still got like half a day. And there's just so many amazing speakers, amazing topics. I can't wait to hear your speech. And if I'm not mistaken, you'll be joining us for the Q&A as well, won't you?
Yes, I will. I will be joining for the Q&A as well.
That's great. So I don't see your presentation backstage. Do you have a presentation?
Yes, I have a presentation that was pre-recorded.
Would you like me to play the recording or?
Yes, I would like the recording.
Okay, amazing. A note to our technical team, can we please get the recording? And in the meantime, so I'll say goodbye for now, and we'll get the recording up on screen in a sec. So see you in a
Okay. Okay.
React.js Case Study Festival. My name is Adora and I am more than excited to be giving this talk today. Today I'm going to be talking about habits for building effective and inclusive engineering teams. But before we get into the talk, one of the first things I would like to do is share a little bit about teamwork, and I found this very helpful video that does that well. So I'm just going to go ahead and play this video for you to watch. can see that teamwork is something that is very important. Initially, when they tried using their spoons to feed themselves, nothing could work, nothing was working. And when they decided to work together as a team and do things together and feed each other, they were able to accomplish what they were able to accomplish, because at the end of the day, they all had a common goal, but their stubbornness for not wanting to work together initially was preventing them from reaching that goal. And to be honest, when we look at the world we're in, it's crazy how different we can actually be, like ourselves and the next person. There are so many ways, there's so many spheres of diversity, there's so many things. So it's important to understand that in building these teams, we also need to create safe spaces for these people that we're going to be working with to feel excited and to bring their most authentic selves to the workplace and to whatever it is they're doing. Because at the end of the day, we're all different. What you like might not be what somebody else likes. What you enjoy might not be what somebody else enjoys. You might even be different in tradition. You might be different in, your race. You might be different in other areas that exist that could possibly make people different. So it's important to know these things so that we can work together to create these effective and inclusive safe spaces where people can come, work, and be their most authentic selves. So now I'll go ahead and define teamwork. Teamwork is the collaborative effort of a group to achieve a common goal or to complete a task in the most effective and efficient way. This concept is seen within the greater framework of a team, which is a group of interdependent individuals who work together towards a common goal. Now, when we think about it, the main thing is as team members, as people, because when we talk about building effective engineering teams, at the end of the day, these teams consist of people. So we need to start with the people first. So as people in the team, how do we go from being dependent to being interdependent team members and building an effective team? That's what I'm going to be talking about today in this talk. But before I dive into it, I would want to quickly introduce myself. Hi, my name is Adora, and I am a software engineer at Microsoft Mixed Reality. I am a tech content creator at Adora Hack, which is also the shirt I happen to be wearing right now. Adora Hack is a blog that I have created where I talk about tech, I talk about my life as a software engineer, I talk about career growth, some things I share as I learn them, some things I already know. I share all these things on Adora Hack. I'm the co-founder of Unstack, which is a developer community that was created in Lagos, Nigeria, and has scaled to other different locations. I'm also an advisory board member of VRAR Association Nigeria, which is the Nigerian chapter of the Global VRAR Association. You can also find me on Twitter at Adora Nwodo if you want to say hi, if you want to ask a question or anything at all. So now let's get into it. Let's talk about the definition of teamwork again. We've said it's a collaborative effort with a group of people to achieve a common goal in the most effective and efficient way. This has to do with people. We've talked about the concept of teamwork being drawn from the framework of a team, which is a group of interdependent individuals. So basically, what we now need to ask ourselves is, how do we go from being dependent to being interdependent? That's important, right? And this talk is based on one of the important life books I have read, and it's called The 7 Habits of Highly Effective People. And basically, you go from being dependent, like, oh, I can't do this myself, to being independent, which is, I can do this myself. And then when you become independent, your next level is becoming and staying. It's important to stay, right? The next level is thinking about becoming and staying interdependent, which is, I can do this and you can do something else. We should do this together. In a software engineering team, it's never one engineer. That's why it's a team. You need people. There might be ML engineers, there might be front-end engineers, there might be back-end engineers, there might be DevOps people, there might be mobile engineers and all of these things. And this is looking at the engineering side. At the end of the day, you as an engineer, you are building for customers. You're working with product managers, project managers, product designers. You're working with other people that make up the broader team, and everyone is working towards that common goal. So these essential habits are broken down into 3 buckets. The first bucket is going from dependent to independent. The second bucket is going from independent to interdependent. And the third bucket is staying interdependent. So now let's look at the first bucket, which is going from dependent to independent. The first thing there is you should learn to be proactive. You should learn, there's something called the circle of influence, which is the things that you can actually control. It's important to know what your circle of influence is and try to make impacts in your circle. Don't try to chase after things that you cannot control, things you don't have control of. You need to learn to make impact in your circle. You need to acknowledge your own responsibility. If there is, I'm going to give an example here. Let's say something went wrong with an app that was being built. As opposed to blaming every single person that is blamable, one thing that you can do is learn from that experience. Let's be honest, as human beings, we're always going to make mistakes. You are not less of a human being because you made a mistake. What's important is what you learn from that mistake, what you learn, what that experience teaches you, essentially. And a proactive person acknowledges that, okay, this is my life and I am responsible for this, and this is what I have learned from this experience, and going forward, these mistakes I made, I will not make again. For example, something happened, you were writing code or something. So let me give this example. You're a DevOps person and you accidentally did something where you deleted an entire environment, and because of that, customers are trying to hit that service and they can't hit it. Customers are trying to get access to the application and the entire thing is down. It's like, okay, why is this thing down? You might even be trending on Twitter that your app is down and you are trying to fix that problem. As you've been able to fix and mitigate that problem, there are some things you would have learned from that experience. There are some holes that you would have discovered that, oh, if this thing was properly closed, if this thing was properly patched, this thing would not have happened. So I'm going to go ahead and take control of this situation. Now that we have mitigated this issue, I'll go ahead and take the extra step and do this thing so that what happened today doesn't happen again. That's a proactive person. You are anticipating that there's a chance that this thing can happen again in the future, and you are taking the necessary steps to make sure that they don't happen again, because this is something that you can control and you've decided to control it and make sure it doesn't happen again. So that's things like that, you know. Other things that proactive people can do are proactive people acknowledge their own responsibility. They are not reactive. They focus on the impacts they can make in their circle. They communicate effectively to their team members, to their managers. They communicate because if they don't, there's a chance that something could go wrong. And a proactive person wants to be able to, you know, be in control of the things that they can control, right? Proactive people seek opportunities and not limitations. It's never a case of, oh, I can't do this thing, but it's more a case of, oh, how do I do this thing? How do we do this thing? At the end of the day, a question opens the mind and a statement closes the mind. It's something that the author of Rich Dad Poor Dad said, which is something that has stuck with me for a very long time because I found out that's actually true. When I ask questions, I find myself getting new information. I find myself learning new things. But when I make a statement, it's like, okay, that's it and that's the end, and there's nothing anybody can do about it, essentially. So proactive people seek opportunities, not limitations. They learn from their mistakes, they learn to be accountable, and they learn to manage their time, which is something that is very important. The second thing on the list for me is beginning with the end in mind. So when you think about beginning with the end in mind, it's more about knowing about your visions, knowing about your goals, not being short-sighted. When you're about to do something, think about it in the long run. Always think long-term. Be future thinking, be forward thinking. In the long run, how is this thing going to add value to me, my co-workers, my team, my customers? This is something you should think about as someone that is trying to become independent. You have to learn to pick up this habit of being forward thinking, not being short-sighted, knowing what the particular goal is, knowing what the particular mission is, and not just being someone that can easily go wherever the wind is going, essentially. The next thing is putting first things first. You have to learn how to plan, you know, prioritize, understand important versus urgent, because it's something that would help you a lot. Know what the important things you should be doing are for your team when you're working on a task, when you're working on a certain deliverable for a certain date. Know how to order and prioritize the tasks, because sometimes things don't go as planned. Things don't go the way we planned it in our teams or in our heads. But being able to prioritize so that even if we have to launch but we've not concluded a lot of things, we know the things that we can prioritize that have to go before the launch and things that we can deal with after the launch, because they help the app be better, but they are not things that if they were not there, the application will not be able to function. So you need to learn planning, you need to learn prioritizing. Even when you have your own individual tasks, your own individual tickets, most times it's always multiple things. But so you need to know the most important one, the urgent one, whatever, the one that needs to go first, essentially. So now talking about important versus urgent, this is the important versus urgent chart. So something that is important and urgent are things with like clear deadlines and consequences for not doing immediately. And those things are things that you do now. Something that is important but just doesn't happen to be urgent right away are things that you plan for. These things are things that have a set deadline that is kind of far away, or don't have a deadline at all, but they bring you closer to your goals. So those are things you plan for. Things that are not important but they're urgent, you delegate them to other people. You delegate them as, like, I've heard a lot of people nowadays talking about how they've gotten EAs, PAs to help them with mundane tasks, so they focus on what is important. This is exactly what they mean. So things that need to be done, but they don't necessarily require your specific skills, you can delegate these things to somebody else. Now, things that are not important and not urgent at all, why do you have them? These are distractions and they are not connected to your goals in any way, so you should eliminate them. If you are able to be proactive, if you are able to begin with the end in mind, and you are able to put first things first, at this point, hopefully you have become an independent team member. And when you become an independent team member, the next thing to think about is how you should go from being an independent team member to becoming an interdependent team member. And this is where, so the first part talked about your self-development as an individual. Now this part means learning about teamwork. And the first thing here is being able to think win-win. Know that teamwork is important for software engineers. You're going to, like I said initially, you're going to work with product designers, you're going to work with product managers. As a front-end person, you're going to be using APIs that are written by back-end engineers. As a DevOps person, you're going to be working with the entire team because their code is going through the CI/CD pipeline that you create, and all of these things. So you need to learn to work with people, and thinking win-win is something that is important. Teamwork is very important. Always take feedback. At the end of the day, you are learning something and the person is learning something back. An example of thinking win-win is two people exchanging value. Don't think about it as, oh, I'm doing this for you. For example, if you are working as a freelancer, don't think about it as, oh, I'm building this app for you. You are giving the person value in terms of the application that you build, and you're giving them your time, and in turn you're getting paid for that job. So it's a win-win thing. It needs to be treated as a win-win situation, as some kind of partnership. That's how it should be addressed. The next thing is seeking first to understand and being understood. And this is particularly interesting because I'm talking about inclusive teams. You need to learn to understand people. At least try. Because people are different. You're working with different kinds of people. You don't want to make them uncomfortable, because if you make them uncomfortable, they may not be bringing their most authentic selves to work. And at the end of the day, you don't have that effective team that you are trying to build. Don't be too quick to jump into conclusions. Be someone that is a good listener. Be someone that is empathetic. Be someone that is patient. That's how you can be a better person, a better team member, and encourage people to bring more of their authentic selves to the workplace, because they would feel more comfortable around you. Although we talk about people recruiting to hire diverse talent, when we talk about inclusion is not for the HR, the recruiting managers, the hiring managers, and other people in management alone. Inclusion is for everybody, because if you are someone that is toxic in a team, and there's a diverse hire, there are multiple diverse hires, and you have a really diverse team, as a toxic person, you are still going to make some team members not feel included. So this is something you should think about. And one way to do that is trying to understand people, listening, being empathetic, and being patient. The next thing is synergizing. And I'm going to read this out real quick. To synergize means to combine or coordinate the activity of two or more agents to produce a joint effect that is greater than their separate effects. And I'm going to talk about this with a story. So when we think about synergizing, it's trying to combine forces, joint forces together to create something amazing. Let's look at a basic application. Front-end, back-end. A front-end site is great, except if you want it to be a static site, maybe it's a portfolio website. But the truth is, you are watching this talk currently on a platform. If this talk only had the front-end things, you would definitely appreciate the UI, but let's be honest, you will not be able to use it. You wouldn't even be able to log in. The same thing with back-end. Back-end engineers are amazing. You know, they think about security, they write code to be able, like, for you to be able to do all the things that you want in your business logic. But let's be honest, if you have only the backend, as a customer, I'm not going to download Postman and be calling every single endpoint one by one. Maybe I have a manual and I have to call every single endpoint one by one. And that's how I communicate with your backend. At some point, I'll get frustrated and stop. But when you bring the effort of the front-end engineer to build the amazing UI, and you bring the effort of the back-end engineer that builds the amazing APIs, and there's a connection in the middle to make both of them work, that synergy exists, you come up with this amazing platform. You come up with YouTube, you come up with Twitter, things that look very great and are also usable. They have all the back-end features. You know, you can check out your tweets, you can check out your videos, you can like a video and it reflects in the server and it reflects on the UI. You can do things, the UI is responsive, it's great, because these two efforts have been merged together. Synergy is something that's very important in teams generally. You're not going to be working in silos, you're going to be working as a team. So you need to learn how to synergize. You need to learn the culture of joining efforts together, allowing people leverage on your work and leveraging on the work of other people. That's something that is really important when you think about teams long term. And in staying interdependent, the last thing to think about is sharpening the saw. You know, you need to constantly maintain yourself physically, maintain your health mentally, financially, in every single way possible, which means staying informed and staying healthy. And now there are other ways that you can sharpen the saw. One of them is recognizing burnout and taking breaks where necessary. The next one is resting, exercising, meditating, and eating well. Then learn more skills so that you can grow in your career, develop your brain, and keep climbing in that whole career ladder. Keep informing yourself, keep learning new things, keep growing as an individual, and strive to always be a better version of yourself. Maintenance is very important in every single sphere of our lives. In every single thing we do as human beings, we should always try to properly maintain ourselves and maintain the things that are around us. And I'm going to end this talk with an important quote, which is, coming together is the beginning, keeping together is progress, working together is success. Thank you so much for watching this, and I hope you have a nice day. I hope you learned something, and I hope you enjoy every other talk from every other speaker.
That was wonderful. Thank you so much, Adora. Now I'll pull her up on the screen again. Thank you for that, Adora. So do you have anything to add to that? Because I know we've still got a bit of time. So is there anything else you'd like to tell us about?
I don't have anything else to say beyond that. I think I poured up my whole heart in that recording when I was doing it the first time. If there are any questions, I believe that I can answer. If any questions have come in at this time, I believe that I can answer them right now. But I do not have anything to add to that.
So as far as I can see, if I'm not mistaken, I don't see comments just yet. But I'm sure I know we'll have more questions during the Q&A portion. So I think we can end this here now. And speak to you again soon. So Thank you so much. And I'll see you in a couple of hours, in an hour or two.
Okay, thank you.
Thank you. Bye. So let's move on to our next speaker, which is Daniel Afonso. So Daniel is a software engineer. His current interest is in React and JavaScript, and he advocates for better testing principles using the testing library. He has a full stack background, having worked with different languages and frameworks on various projects from IoT to fraud detection. In his free time when he's not learning new technologies or writing about them, he's probably reading comics or watching superhero movies and shows. So the title of his topic today is A Year in the React World. So let's get going. Let's get him up on screen. Hi, Daniel.
Hey there, everyone.
Hi, how are you doing today?
Really great, and you?
Good. Thank you for joining us. So, where are you based now?
I'm based in Portugal. I live in a city called Coimbra.
Aha, I've been to Portugal, never there, but I've been to obviously Lisbon and the Algarve, beautiful country. I imagine it's much warmer there than in Ukraine.
Yeah, right now it's good. It's been a couple of tough days, but yeah, right now it's good.
Very nice. I wish you could send me some sunshine. But okay, I won't take up too much more of your time. If I'm not mistaken, one second. Let me just pull up your thing and we can get going. So I'll see you shortly.
See you shortly. Called A Year in the React World. So, before anything else, my name is Daniel Afonso. I'm currently a front-end engineer at SerraCare, and I'm also an Auth0 ambassador. You can find me on Twitter, on any social network at the handle at DanielJCAfonso. So, before anything else, my main ecosystem right now and the stuff that I'm mainly working with is JavaScript, React, and for testing, obviously, the testing library, which is one of the things that we'll end up seeing during this talk at the end of it. So, before anything else, what is this talk about? This talk is about a real-life case study that went over 2 years of building and growing a React application. During this talk, I'll approach stuff like why migrate to React hooks, how to deal with state management, and testing. So, let's start with the first point, which is hooks. So, before speaking about hooks, it's important to speak about class components. Class components have been around since the start of the React, and while they served as well, they have a couple of issues. The first one is giant and confusing components. What we can see here right now is a class component with 3 lifecycle functions, a component in mount, a component in update, and a component on mount. What we can see here is that inside of these lifecycle functions, there is unrelated logic grouped together on each lifecycle function. Right now, this might be readable, but imagine that we have a scenario that we need to add a bunch more logic to the component in mount or a bunch more logic to the component on mount. This will cause that unrelated logic stays grouped inside of the same live function and affects a bit of the readability of your code. And let's not even speak about how we are going to test this. The first point is reusing logic between components. So, if we were to think about what React offered natively before hooks, to how we can reuse stateful logic between components, we would think about stuff like make-sense, but they were deemed unsafe. And then we have patterns like I order components and render props. The thing is, these patterns often lead to code restructuring and adding extra complexity. And this leads to something that the React team refers to as wrapper hell, which is what we can see in this image. And the last one here is confusing classes. This one might be a bit controversial because, yeah, I'm saying that classes can be confusing. In JavaScript, that is. So, before anything else, you have to understand how this works. You need to remember how to bind your event handlers on the constructor and all the related logic. All this usually leads to a bit of boilerplate code, and it might be a little bit verbose. And this is only for the human part. The React team has mentioned publicly often that for machines, classes don't minify properly, and this can cause issues on auto reloading and overall might introduce some erratic patterns. So it was to fix all these issues that the React team introduced React hooks. At the time, hooks had come around for 2 to 3 months, so they were still very recent, and we needed to have some justification to explain to our product team why did we want to take time in our development process to migrate to something that is very new. Well, the first selling point is that the React team has publicly mentioned that hooks are the direction where they intended on taking React, so hooks were the future of React. And here are another couple of motivations. The first one is code readability. So as you've seen previously, before hooks we had lifecycle functions. The thing with lifecycle functions is that they made us write grouped and unrelated logic on the same function. With hooks, in introduction of effects, now we can split this code and group related logic together in each effect. So yeah, this is a great aspect of hooks. The second point is code readability. So as you saw previously, before hooks there was no way to reuse stateful logic between components. Then we had patterns like mixins, render props, or by order components, but as you can see that usually led to stuff that it's called the wrapper hell. With hooks and with the abilities of creating custom hooks, this now is possible and so much easier. And the last point is ease of teaching React. We knew that at the time we would soon be hiring some junior developers, and we wanted their onboarding process and ramp up to be as easy as possible. And we wanted them to get into the React ecosystem without many issues. And with hooks we wouldn't have to worry about all the stuff related to classes, so that was definitely a win. So yeah, as you can see, hooks are pretty great and they basically bring a new mindset to using React. We soon migrated our code to starting using hooks, and personally I can say that it cut the code in half, so we had half the lines we had previously. Everything was so much readable and easy to use. And here are a couple of lessons that we learned while using hooks. The first one is pay attention to the rule of hooks, either it being things like not using hooks conditionally or forgetting some dependencies on a dependencies array. It's really important that you pay attention to this, because that way you won't make mistakes that you will find later on. A thing that really helped us paying attention to the rules of hooks was static analysis. React has an S-lint for rules of hooks, so this will make sure that these rules are fulfilled and we don't break anything. The second point is don't pre-optimize everything. So React introduced 2 new hooks to deal with memoization, being it the use memo and the use callback hook. It's often said that premature optimization is the root of all evil. And with this in mind, we decided to follow an approach of trying to avoid memoization until it deemed itself necessary. Despite this approach, there are a couple of cases where we needed to memorize things, and there are a couple of lessons that we've learned. The first one is, if you're adding an always changing dependency to your dependencies array, then you probably shouldn't be memoizing that function, because if you're memoizing every time a dependency changes, it basically will be the same thing as if you're not memoizing it. And the second lesson was everything that's inside of your memoized function is memoized as well. So don't forget that the state of your functions used inside of your memoized contents will be the one before memoization. And this one was definitely tricky because we've had some issues with closures, because it would create closures of the previous value of our state. And when we went to use it, we were left to wonder why. Why was it using a state that it's not the current one? Yeah, don't forget about this. And the last lesson learned was how to deal and how to think in life cycles. So it's not thinking about life cycles, it's about how not to think in life cycles, because with hooks there was a new paradigm that was introduced. Instead of having life cycles, we now started to have side effects. And the way we could perform these side effects was by using the use effect hook. Often in documentation or being in tutorials, use effect is presented as a combination of the component in mount, as a component in update, and as a component we want mount life cycles. And this was one of the things that causes main issues. By advertising effects as the new life cycles, there will always be a comparison between them and for everyone that uses React pre-hooks. This led for us to writing effects the way we used to write life cycles, and even creating some custom hooks with the name of life cycles, like we had a hook for use mount effect or use unmount effect and stuff like that. And the catch here is that we didn't understand until a couple of months ago was that life cycles ran synchronously after render and blocked the browser from updating the screen, as effects generated by the use effect ran asynchronously and were non-blocking. To use effects properly, we needed to forget how to use life cycles, and we had to start approaching React with a new perspective and thinking about effects instead of thinking about life cycles. And with these lessons learned, we can finally wrap the classes and React hooks topic. The next topic I would like to discuss in this case study is state. When we start a new project, there is a question that we always ask, and that question is, how will we manage state? There are a bunch of state management solutions in the market, and you can use either one. At the project I was in, we decided to start with Redux. Despite Redux being the most used state management library in the React world, it has a couple of issues in my opinion. The first one is it has too much boilerplate code. For you to start using Redux, you have to set up a bunch of things in your code. The second point is learning curve. Redux comes with a pretty big learning curve for someone who's not into state management at all. Despite this, it also has a bunch of needs for middleware, so you often find that you need to start using either Redux Tunc or Redux Sagas and so on to start applying some effects or stuff like that. And I like to say that Redux isn't necessary pre-optimization. I often do a comparison that, in my opinion, Redux in early stages of an application is like using a bazooka to try to kill a mosquito. And from this point, we decided to stop using Redux and move to React Context. And React Context is great, and we used it for over a year. There were just a couple of issues that we had with it. The first one was, why am I getting unnecessary renders? But then I'll show you it in the next slide. The second one is related logic often gets grouped into the same context, so that make your context a bit bulky with a bunch of code, and often to use context it has a bunch of boilerplate that you need to do as well. So as I mentioned, one thing that I've learned from context and I delved into was, why am I getting some unnecessary renders? And I'll show you why. Here we create a couple of things. The first one is a random context. Then we create a custom hook to subscribing to our context called useRandomContext. Then we have a random store where we'll create two state variables and an effect that when the something variable changes, it will update the other thing variable. At the end, we have a random provider for wrapping our component that will use our context. So now, let's create our component. Here we have a component that subscribes to our random context and returns a button that when clicked it will update the something variable. At the end we have our component wrapped with our random provider to make sure that we can subscribe to our context. Now I guess we all have all the conditions that we might need to diagnose the issue. If we have a console log with I just rendered to the root of our component and we click our button, we should expect to see only one I just rendered because we are only updating the something variable, right? The thing here is, what will happen is it will render twice I just rendered. Why? That is because we forgot something. We forgot that we have an effect that will update the other thing variable when the something variable changes. So when this happens, it will update our context, and then our component that's subscribing to it will have to re-render to get the new values, even though it's not listening to those variables. Now, why does this happen? This happens because every time React detects a change to something inside of its context, it triggers a re-render on all the context subscribers so that they can receive new changes. And yeah, this is the issue of why am I getting unnecessary re-renders. Now, you might wonder, how do I fix this? Well, according to Dan Abramov, there are 3 solutions that you can try to fix this issue. The first one is split the contexts. This is actually the preferred approach, and it consists on passing the variables that change too often to another context. In this case, what we do is we create a second context where we pass the other thing variable, removing it from the other context that we had. So this makes sure that when the other context changes, we don't have to worry about unnecessary rendering on our component because we will only be subscribing to the random context. The second approach is split the component in two and use memo. This approach basically consists of transferring the return of your first component to a second component, like we do in here. And in this second component, what happened is we wrap this component with Mimo, and we receive the needed context variables as props. What this will do is, in case the first component re-renders, if we are listening to these variables and they don't change, then it won't be expensive because it won't do anything. It will return the same as you had because, yeah, we are wrapping it with Mimo and saying only when something in set something changes, then this component will re-render. And then the third approach is wrap your return with use Mimo. If we don't want to split our component into two like we did previously, we can wrap the return part of our component with the use Mimo hook and only listen to the set something and something variables. Our component would still re-render, but the part inside of use Mimo, since it's memoized and listening to variables that didn't change, then it won't return until these variables change. So yeah, that's the ways of fixing unnecessary renders caused by your context. So even despite context serving us pretty great during a year and a half, we decided to stop using it. And one of the reasons why was our state was only comprised of service state. Now you might be wondering what server state is. Before anything else, it's important to know about global state. And you might wonder, hey, what's global state? Global state is the state that is comprised by the client state and the server state. And each type of these two states brings different challenges. Let's start with client state. Client state is the state that is owned by our application. It's often referred to either client or UI state. This state is temporary, it's local, and generally doesn't persist between sessions. Then we have our server state, which was the state that our application was mostly built upon, which is the state that's persisted remotely, is usually persisted on a database or something like that. And this state is asynchronous because we have to use synchronous APIs to interact with it. And there's no guarantees that this state is always up to date because, yeah, we might have a version of the state right now, but there might be some changes on the database. Server state also comes with that bunch of challenges. It can be like data caching, doing some background updates, deduping requests, identifying and dealing with outdated requests, some performance optimizations like dealing with pagination or lazy loading data, and last, dealing with optimistic updates. So as we were using only server state in our application, it didn't make sense for us to keep using React context because, putting in perspective, we should use React context only for dealing with our UI state or client state. What we then started using was React Query. For those of you who don't know, React Query is a protocol-agnostic collection of hooks for fetching, caching, and updating server state in React. And it's amazing. What we ended up doing was building our own custom hooks for everything we had in our context. Like, imagine that we have a context for dealing with authentication or with dealing with a to-do application or something. What we ended up doing was we created a custom hook for either doing use authenticate or use update to do or use create to do and stuff like that. So we'd create custom hooks using React Query inside of it, and this was so much easier, was more reusable because we didn't have to rely on context everywhere. We just spin off our own custom hook of React inside of the components that needed to use that server state. And yeah, we are so happy with it because it made so much easy to use it, because all the things that React Queries offers you, like caching your data or dealing with optimistic updates, and it's so amazing. React Query, you should all give it a check. And we used React Query for 6 months, I guess, and we still are using it. It's really amazing. But then we come to the conclusion that we were needing some type of UI state. We needed to share some data between components, and we thought, should we go back to context, or should we try to search for something new? And this is when we got to know Zustand. Zustand is a state management utility that it's based on hooks, so its APIs are only hooks, and it has a really easy learning curve. It's so easy to use Zustand. Besides this, it also has transient component information, which means you won't have re-renders every time the state updates, unless you want it to. You can also want to do that if you want. And it doesn't bring you context providers. It's so much easier to use, and it is the best of both worlds for us, because we didn't have to go back to Redux or context, and Zeus 10 took like half a day to configure and start using in our application. So yeah, I guess that's it for state. Now we come to the last part of our talk, which is testing. As I mentioned previously, we decided to migrate from class components to React hooks, and the migration itself went well. Everything was working as it was previously, except right now we have almost half of the lines of code we had thanks to hooks, and everything was much readable. When everything was looking really great, someone remembered, hey, everyone ran our tests, and this was what happened. Almost half of our tests were failing, so you could probably imagine that this was our reaction. We were left to wonder, what the hell is happening? Our components work exactly the same way that they did previously. So we did some research, and we came to the conclusion that testing implementation details were to blame. Now, you might wonder, what are implementation details? Implementation details are the things which users of your code will typically not see, use, or even know about. And this is a quote by Ketan. So, when we looked at our code, we came to the conclusion, yeah, our tests are deeply tied into implementation details. They were tied into things like the component state, tied into things like the props that the component received, and at the time, we knew that we had to stop using Enzyme and move to the React testing library. Now, you might be wondering, why move from Enzyme to testing library? Well, as I mentioned previously, we had been using Enzyme for 2 to 3 months before we decided to migrate to the React testing library. And before anything else, it's important to mention that Enzyme is really great, and it supplies a huge amount of tools to test your components. The thing here is that often, if you don't worry about focusing on the user-centric perspective, you might end up tying into your implementation details. And here are things that I personally don't like about using Enzyme. The first one is shallow rendering. Shallow rendering is the way that Enzyme supplies you to render only the shallow part of your component. So if you have a component that has children inside of it, it will only render the component part and won't render the component children. While this might be helpful in some scenarios, this is not the way that the user interacts with your component. When the user interacts with your component, it interacts with the component itself and with the component children. So only rendering the shallow part, we might end up forgetting to test something that we didn't even know that was necessary to test. The second part here is find. Find is the way that Enzyme supplies you to query for stuff on the DOM. Well, find might be great. It allows you to search for things like the component name, ID attributes, and these are things that the user then doesn't see or know about. So this is not particularly a great way to query the DOM for stuff while focusing on a user-centric perspective. And finally, the last point is state. This, in my opinion, is one of the things that definitely ties into your implementation details. So when interacting with your component, the user doesn't need to care if the state of your component is 10. What the user cares about is, if I click on that button, will a model show up? Or stuff like that. So by tying your test into your component state, you're definitely tying into implementation details. So as I mentioned, the reason for leaving Enzyme was to start using the React testing library. And with the React testing library comes its main guideline, which you can see here on a tweet by Ketan. And it is, the more your tests resemble the way your software is used, the more confidence they can give you. Ketan is the creator of the DOM testing library, which is the base library where all the libraries from the testing library family were built upon. So we have used the React testing library for over a year, and personally it changed the way that I write my tests. I became so much more interested in writing tests. It became so much easier, and yeah, our tests could survive real code migrations if we didn't change our implementation itself. So here are a couple of things that I personally am really happy with using thanks to the testing library. The first thing is React testing library promotes accessibility. By using queries that are accessible to everyone, which are the ways that we can search for stuff on the DOM, we can use queries that reflect the experience of visual, mouse-assistive technology users. And by granting priority to the queries that are most accessible to everyone, we will make sure that our tests find some accessibility issues in your components before we even find them on your application. Thanks to these queries that we can see here, which is the query by label text, the query by placeholder text, the query by role, the by display value, and the by text. Here we have a small example of how to use it in the React testing library. What happens basically is we render a component and we destructure our query and we query for stuff on the DOM. In this case, we are trying to query for an element on the DOM that has a label text called username. So this was one test that I started to use and made me understand that we weren't tying or area labeled by attributes properly in your components, and these are the types of things that the React testing library will help you find. The next great thing that the React testing library has is it lets you create your own queries. It has an helper which is the build query helper, and it's important to know that if we decide to follow the approach of building our own queries, we start by creating queries that promote a user-centric perspective instead of an implementation details one. And the third thing that I really liked about the testing library, it is user-focused events. The React testing library comes with a companion library, which is the user event library. And this library allows you to interact with a button. In this case, we are trying to do a click event on the button, which has the name save on it. And what the user event library will do is it will trigger all the events that are usually associated with clicking with a button. Instead of just doing a firing of an event click, it will fire all the events like the mouse hover, the mouse down, the click, and all the events that are associated with the click process itself. And last but not least, it has a bunch of asynchronous utilities that you can use to query the DOM for stuff or do some specific assertions, either being by the wait for or the wait for element to be removed. So these are a couple of things that I really like about the testing library. So I've used the testing library for over a year by now, and as I mentioned previously, and as you can see from all this stuff on this past slides, React testing library is great. I personally started enjoying writing tests more than I did previously, and I definitely advocate for using it all over. So here are a couple of lessons learned and mistakes that we did while using it in the past year. And I'll start by the using ACT one. So using ACT. For those of you who don't know, when writing UI tests, there are tasks like rendering or firing events or doing some data fetching that can be considered as units of interacting with the user interface. ACT is a provider that React offers you to make sure that all the updates related to these units have been processed and applied to the DOM before you try to make any assertions. So, putting this in perspective, what we used to think about was, so rendering is a unit of interaction with the DOM and firing events is a unit of interaction with the DOM, so we should probably wrap all of them with ACT. The thing here is we don't need it, because React testing library already wraps all the utils that will interact with the DOM with ACT so that you don't have to do it. So generally you never need to use ACT in your tests. The second mistake we used to do is using get by query with the assertion expect not to be in the document. So for those of you who don't know, get by query is a query that will throw an error when it doesn't find what it's looking for, but if it does, it will return that note on the DOM. So using a query that will throw an error with an assertion that we want to assert that something doesn't exist on the DOM is basically as begging for our test to fail. So instead of using get by queries to assert that something doesn't exist, we should use the query by queries, which is a query that will return null once it doesn't find what it's looking for. The next query is using await with fire event or on non-synchronous queries. So basically, this is pretty simple. We don't need to await for queries that are synchronous. Synchronous queries in the React testing library are queries like the get by and the query by, and we shouldn't wait for firing events on as well because they are also synchronous process. So instead, what we should do is remove the wait. I had a question once asked, was that someone asked me, which was, but then I saw an example online where I'm using a wait on a fire event. And I did some research and it took me quite a while to understand what the docs he was looking at was the view testing library. It's only on the view testing library that firing events needs to be awaited for. Using a wait for with an empty callback. So for those of you who don't know, wait for is an asynchronous util for the React testing library that allows you to wait for your assertion to pass. So if we provided an assertion, it will wait until that assertion evaluates to true. In this scenario, what we are doing is we are passing it an empty callback. So what it will do is it will wait one tick of your test before going to your assertion. While this might work sometimes, it doesn't guarantee that when it gets to your assertion, it will pass. So instead of doing this, what you should do is you pass your assertion to inside of your wait for, and it will loop it until it evaluates to true. Using cleanup. Cleanup is a util that the React testing library offers you to basically clear up the DOM after you do everything. So it would make sense that we use jest and we say, okay, after each test I want to run cleanup, right? The thing here is we don't need it. If we are using jest or a framework that supports the after each global, then the React testing library will automatically run cleanup for you. Using wait for with synchronous queries. So in this scenario, we are using the wait for util to wait for this query to validate to true. So we are going to wait until it returns a progress bar. So for those of you who don't know, there is actually an asynchronous query in the React testing library ecosystem, which is the find by. So instead of using wait for with get by query, we should use find by query to return to wait for what we are looking for. Using side effect instead of wait for. This one is actually a tricky one, but what we are doing is we are waiting for your user event to be clicked, and then we are waiting for our assertion to pass. Well, this might make sense on the first instance. This might cause you some unexpected examples, because as I mentioned previously, wait for will loop the code inside of it until it evaluates to true. So what might end up happening is you click on this button 100 times until this expect validates to true. So what we should do is we should remove the things that will cause side effects inside of our wait for to outside of it. So what we should do is pass your user event click to outside of our wait for, so it makes sure that it won't loop the assertion that we want to wait. So well, these were a couple of mistakes that we had with the React testing library. Here is one thing that definitely gave me a couple of headaches during the time of using the React testing library, which is the error was not wrapped in act. So you might wonder, what is this error and what happened and how does it happen? So let's look at our code. Here we have a function which is called display Pokemon. This component basically returns a prop, which will be a function that will be responsible for getting our Pokemon data. And what we do is we have a state variable, which is if its component is loading, and we have a function called getSelectedPokemon, and this function receives a Pokemon. Once this function is called, it will set our loading to true, and it will fetch a request to our getPokemon data with our Pokemon. Once it ends, it will return the loading to false, or if there's an error, it will return the loading to false. On the render part of our component, we have a button that when clicked, it should basically trigger a request to get our Pokemon that it's called Pikachu, and we have a span that will show if it's currently loading or not. So you might wonder, how am I going to test this? This would probably be a test that we have. This test should call getPokemon with Pikachu. So the first thing that we do is we say I want to mock my getPokemon data function. So we pass it a jestfn. We render our component and we say I want this component to receive in the getPokemon data my mocked function. And then we click on the button that has the name Pikachu. Afterwards, what should happen? We should assert that the Pokemon data was called with Pikachu. So yeah, we assert if it was called with Pikachu. So you're probably thinking, yeah, this test is great, it's doing everything that we might need. So when we run our test, this was what happened. An update to display Pokemon inside of a test was not wrapped in act. When testing code that causes React state updates should be wrapped into act. So you might be wondering, well, why is this happening? I'm testing everything that we need. This warning is here to let us know that we are forgetting something into our test. What do I mean? Well, if we look at our test here, we are waiting that Pikachu is called, but we are forgetting something. There is actually something in my test that we are not covering, which is the set is loading. So this warning is there to tell us, hey, you are testing this scenario, but there is a state update that it's been called, it's been done after you end your test. So don't forget to test it as well. So before anything else, let's thank to the React team for giving us this heads up, and let's fix our test. How would we fix it? Easy. Or we use a wait for query to assert that basically the loading did disappear from the DOM, or we use the wait for element to be removed util to wait for our loading to disappear from the DOM as well. So yeah, that's it for testing. So this wraps my talk. I'd like to thank you all for watching. As you can see, it has a bunch of content because yeah, it was an entire process of growing an application for over 2 years and trying to figure out the ins and the outs and the whys of the React world. And yeah, I guess that's all from me. My name is Afonso. Thank you for watching, and I'm looking really forward to seeing your questions in the Q&A section. Bye.
Wonderful. Thank you for that. So, Daniel, how are you feeling now?
Yeah, really great.
That's great.
Hope everyone enjoyed.
I'm sure they did. And just a reminder to everyone, Daniel will be with us for the Q&A. So feel free to write your questions in the chat and we will ask him your questions then. So I'll see you soon.
I'll see you all soon.
Bye. So it's time for our next speaker, which is John Koehmstedt. Let me tell you a little bit about him. John Koehmstedt is a senior software engineer at Facebook with a background in startups. He started working in React in 2016 while at the Human Diagnosis Project, where he converted their entire application using Redux, which was relatively new at the time. He's followed the changes in state management patterns since, and he's worked for various startups using React, and now at Facebook, where React is used prevalently. His talk today is titled 4 Lessons from 4 Companies in 4 Years. So let's give him a warm welcome. But I don't see him backstage. Oh, because it's early. So we are actually running a little bit ahead, which is better than running behind. So that was entirely my mistake. And let's take a little break, 5-minute break to get a coffee, or in my case, I should not be drinking any more coffee because it's getting quite late. So yeah, let's take a 5-minute break and we'll be back soon. And we're back. So my face is covered because I'm about to get this off. But I wanted to tell you about our sponsor and our friends at Stream. So a massive thank you to them for sponsoring us. So let me tell you about them. So Stream is the best in-class enterprise-grade chat and activity feed provider, serving more than 1 billion end users. Stream's feature-rich products include robust client-side SDKs for iOS, Android, React, React Native, Flutter, and support for the most commonly used server-side languages, scalable and secure APIs with a beautiful UI kit. Stream is the fastest, most scalable solution on the market today, enabling application product teams to increase user engagement and retention and decrease time to market. Stream is headquartered in Boulder, Colorado, with an office in Amsterdam. So thank you to Stream, and you can either follow the link that I'm about to, sorry, the QR code that I'm about to put up on screen, or you can Google them and find them. But thank you to Stream, and make sure to follow the QR code to get your 28-day free trial. So thank you, Stream. And now back to our regular content. So I see that John is here. I'm going to pull him up on the screen in a second, but I'd like to tell you a little bit about him first. So actually, we talked about this. So his talk today is titled 4 Lessons from 4 Companies in 4 Years. He's a senior software engineer at Facebook, and you heard me say all the other things earlier. So let's give him a warm welcome. Hi, John.
Hi. Can you hear me all right?
I can hear. There we go. Yes, I can. How are you doing?
Good. I'm doing great. Thanks for asking. And yourself?
I'm doing well, thank you. How are you doing? Are you nervous? Are you excited? What are your main feelings right now?
I guess you're asking about this talk. I am
Yes.
a little nervous. I am excited. I think that these lessons are things that I wish I had known when I was beginning in my career and working in React. And so it's things that I'm looking forward to sharing. Some of them to me seem maybe a little bit more obvious, and I hope that people do actually find value out of it. But yeah, I am excited. Thanks for asking.
Amazing. That's wonderful, because it's truly one of those things that I think it's so useful to get to speak to someone or listen to someone where they can share things that they wish they'd known at the beginning of their career. So it's wonderful that you're doing this. Thank you so much. So I'm not going to take up any more of your time. Shall we get into it?
Let's do it.
Do you have your presentation? Are you going to pull it up?
Yeah, I'm going to try. I haven't used StreamYard before, so I believe I'm just going to share my screen and then present.
Okay.
So I'll try that.
Okay.
But all right. Well, before we do that, I'll just introduce myself a little bit. As Chrissy mentioned, my name is John Koehmstedt. I'm a senior software engineer at Facebook, and this title is titled 4 Lessons from 4 Companies in 4 Years. So you can infer from that I haven't been working at Facebook for more than 4 years. In fact, I've sort of been in a number of different startups that in the startup world, you find a lot of React because it's easy to build something quickly, move quickly, and get out there. And so from building things quickly, you learn a lot of lessons, things that maybe you wish you had known a year in advance. And so I'm hoping to share some of those lessons with you today from those companies. So let me see if I can share my screen here. All right. Well, all I can see is my screen. And so I'm not sure if anybody can.
I will pull it up for you.
Okay. Can you see? All right. Great.
Yes, we can see it. Okay, good luck.
All right. I can't see or hear anybody, so I'm just going to keep talking. But I did save a slide for some questions at the end. And also, I believe there's a Q&A after this. So looking forward to maybe some questions. But all right, so you'll see here below the title, it says a short talk about setting yourself up for success. As I was reviewing some of these lessons, I saw sort of a theme of these are all things that a year later, you kind of wish you had known to set yourself up for success. Maybe as you're building it right in the beginning, it doesn't matter so much, but a year later you're like, oh man, I wish I had done this to begin with. So let's just start from the beginning. I will say when I first started planning this talk, I was very excited about sharing sort of a how-to coding session, but I was told by the React.js Festival, they wanted this to be more case study, where you sort of share your experience. So hope that's all right, that during this talk, I plan on sharing just a few anecdotes from my personal experiences more than here's a how-to, and hope that you get some value from that. All right, so lesson number 1, use state management right off the bat. So in React, one of the main benefits of React is that instead of having this giant one JavaScript page that's some landing page we need to put all of our functions in, we're able to create state management and access variables 100 files down. So I learned this lesson when I was at the Human Diagnosis Project about 4 years ago. This was sort of earlier on when I was working in React, and this company had no state management whatsoever to begin with. They had a beautiful, wonderful website that had literally like dozens and dozens of files that would just pass down these props to another file down below, and you would have no idea where it actually came from and where it was being updated at the top. And so we made a big effort at the Human Diagnosis Project to switch everything to state management. And that was a huge undertaking, going from absolutely nothing, where we had an existing website built in place and we had everything there, to, okay, we need to instrument this whole framework and find where all these variables are coming from and create reducers and actions for everything. So over the years, there's been sort of various techniques to get around not having a system in place. And so when you go to add the system, it's not as quite simple as just easily migrating. My recommendation is when you start a project, even though it might seem easy to avoid this, because maybe it looks like, oh, I only have a landing page. Why would I need state management? That landing page is inevitable to turn into a much bigger system that has your email system, that has a user sign-up system, that has more and more, and it gets bigger, and you'll wish that you had state management right off the bat. So I recommend that. Let's see. I will say my experience at Facebook has been really wonderful in this regard. Facebook has not only one sort of state management system set in place, but there's like 5 different state management systems. And at first you think, oh man, that's 5 different things that you have to learn. But from what I've found in learning these different state management systems is that the concepts are really all the same. Let's see, y'all. I'm going to just turn that off. A lot of the concepts are exactly the same. And so I found that if you can learn the concepts of a state management system in one place, it's easy to transfer over to the others. Even some of the proprietary systems that Facebook has created, I've been able to pick up those, and it makes a whole lot of sense. Let's see. Okay, so I'm going to move on to our next point. All right, strongly type everything. So some of the worst bugs that I've experienced in React tends to be where there's some sort of, after you've spent hours trying to investigate why a page isn't loading or something's breaking, or even like a site is down for some reason, there's some integer that was supposed to be a string, or there's some like just one type that was supposed to be something else. And from my experience, I've found when you make a migration from not having strongly typed JavaScript to adding in TypeScript or adding in Flow or adding in some other typed framework, you end up finding hundreds and hundreds of problems that are already existing, and it makes you wonder how the site was even working. So this is something I recommend definitely doing from the beginning. And it's very easy as like a startup or somebody who's just creating a project to say, I don't need this, it's slowing me down. I just want to write the code that I need. I know some of it might not work, and I'll add in the strongly typed language later. It's very easy to make that argument to yourself. But when you do add it in later, you're going to find so many mistakes that you made, and you'll wish that you had just started to begin with. I know at one of the companies that I was working at, Catalog, we had no strongly typed language whatsoever. And when I was brought on, one of my tasks was to work with the team to add in TypeScript to the whole application. And we had a couple people tasked to this, and they never were able to do it because they weren't able to keep up with the development. We would have had to just stop development altogether and say, okay, everybody work on this. It's one of those things that's really difficult to slowly integrate over time. And from my experience at Facebook, I've seen that they've made a very strong effort to implementing and migrating to Flow, which is the open source strongly typed system that Facebook has built. And it's been absolutely wonderful that everywhere you go, there's over 95% or so coverage of almost every file. Whenever I find that there's less than 80% of coverage, it tends to be with a third-party library that has no typing interface. And so that's actually a good point. I found that for me, it's even worth it to find these third-party libraries that don't have typing interfaces and add one yourself. I recently added one of these in Oculus platform, and it revealed a number of different misusages of this library. There's probably hundreds of them, and we're still just sort of patching those up. No real code errors that were problematic, but it was just realizing, oh my gosh, there's so many places where this is being misused, and then people end up just copying and pasting code and just replicating that same error over and over again. So this is something that I think takes a little bit of time up front, but it's totally worth it. Strongly type everything. That's something I recommend. I will say as a side note, if I'm being recruited for a company, this is something that I actually ask them about. I want to know how invested they are into strongly typed systems. And if I'm joining this company and going to be working on this code, like how ugly is it going to be? So I'm a big fan when a company says, oh yeah, we use TypeScript for everything, or we use Flow for everything. All right, let's jump on to the next lesson. Don't be afraid to create a new store. So what do I mean by this? When we're using a state management system, there tends to be an action, a reducer, a store, and that store holds anywhere between 5 and 15 variables. And those variables are then accessed from components down below through some sort of subscription. And what I found a lot of times, it can be extremely tempting as a developer when you just want to add one variable to say, okay, what's an existing store that has this variable already that I can just add it to? And that's fine when you add one variable, but then there's 20 people that end up doing that. Before you know it, you have one store that has a bunch of unrelated variables that all of your components are subscribing to these variables. I will say this is probably one of those things that's more of a personal preference than it is something that could cause system-wide failures, and it's up for debate. But in my opinion, I found that having stores with somewhere between 5 to 15 variables makes it very easy to track down where your dispatches are going, where those actions happen, how to debug something. If you need to have 2 separate applications, you can easily split them in a Redux scenario. You can have like a totally different store for that scenario, whereas in more of a Flex environment, you can just create different stores altogether. And so that's something that I highly recommend, is don't be afraid to create a new store. For a personal anecdote, I was implementing a new feature at Oculus, and I noticed that there was a feature that had been developed that had a store that had all the variables in it, and the team that was creating this new feature said, oh, well, eventually we're going to have the same variables in that store, so let's just copy it over and reference the same strongly typing that we just talked about in lesson number 2. And what ended up happening is when somebody needed to add a variable to that old system, but it wasn't relevant to the new one would then complain, hey, you're missing a variable. And vice versa, when you add something to the new one that the old one didn't need, it would complain, you're missing this variable. And so both of these stores ended up adding all these variables that probably half of them weren't relevant in the other one. And it took us a while to figure out why this was even the case. But when we figured it out. It was because when they first created the store, instead of just creating a new one that was empty and adding their variables, they tried to replicate one, thinking maybe they were thinking ahead. But that's something that is probably going to exist for a while. It doesn't cause system-wide failures, as I mentioned. It's just really an annoyance. So I recommend just go ahead and create a new store. If that means that you have to create another reducer file and another action dispatcher file, those conventions are there for a reason, and I think it's totally fine to have those files. It doesn't create more overhead of performance. Okay, let's go to this next lesson. Okay, so don't overgeneralize components. So I found that in React, one of the beautiful things about React is that components can be generalized. You used to have this huge file that had a specific object, and in a different file it had a similar object, and now we say, well, instead of having a big JavaScript file, let's create these components, and we can build a framework out of it. So we've got React where these components are loaded in dynamically. This is wonderful, but as engineers, sometimes we tend to get a little ahead of ourselves and say, well, this specialized box actually is just a box, which just has a field, which just is a thing. And before you know it, you've got this thing component or this entity component. And I found at a number of different companies, some engineers can get a little overzealous about creating a system that is generalized to be able to do anything. And it's sort of exciting to think about that, but it ends up creating a whole bunch of confusion, and all of a sudden you're adding in a field called type in your thing component that now you're using polymorphism to load in some server-side object that tells you what type of form this is. Just scrap that whole approach. My suggestion would be just create specialized components. It is totally fine to have a really long name that says this is the specialized so-and-so form field box component. And if that's used 2 or 3 times, I think it's totally fine. You don't need to necessarily load in the box from the form from the specialized component. So in terms of some anecdotes, when I was working at IBM, I was working on a team that was creating a ticket tracking system, and we decided to make a dashboard where people could determine what tickets they wanted to see first, and they could see a graph of these tickets. And in that dashboard, we said, well, this dashboard could really be used for so many other things. What if somebody wants to track metrics for this? And every dashboard could be customized to somebody's own perspective. They could, save it for themselves. And before you know it, we had this dashboard component that had a graph component that had a box component that was a sizable component, and we were trying to make basically a visualization framework that was way overgeneralized than it was necessary for that specific task. And we ended up delaying our deliverable for it. So this is something that I recommend being careful about. I'll say even at the human diagnosis project that I was at, we were trying to encode medical information into a knowledge graph such that we could run machine learning predictions to diagnoses for medical cases. And we wanted to encode this information in a highly generalized fashion, which made sense theoretically, but when we ended up creating these components, they were just, they ended up being too generalized that it caused more confusion from an engineering perspective than it actually was able to gain value from a machine learning perspective. I will say I've been extremely pleased with my experience at Facebook in this particular regard, where we tend to have very specialized components with this really long name that at first seems a bit ridiculous, but then as an engineer, when I'm going to try to find a particular file or component, I can use Control-P or Control-H, Control-Y and start typing in my file name, and there's 6 different options, and one of them is clearly the right one that I want. It makes it very easy to find what you're looking for right in the moment, to search for examples that you can copy and paste. There's just, in my opinion, a whole lot of value here. So don't be afraid don't overgeneralize components. It can be quite tempting, but later on, you'll appreciate just making things specific. So, gosh, with that, those are those 4 lessons. I sort of just zoomed through that a whole lot faster than I thought I would. So I'm going to go to questions here and see if I can not. There you go. I'm not sure if anybody was actually able to see me during that chat or if it was just the slides.
No, you were in the corner, and
oh, great, because
so,
I like using my hands. So hopefully you were able to see some of that.
No, I'm sure everyone paid attention and saw. We have a question from someone, which I might as well just ask now. What do you recommend for state management?
So for state management, I mentioned at Facebook, we've got like 4 or 5 different systems. I was a huge fan of Redux before I went to Facebook. One of the reasons I was a big fan of Redux was actually because of the convention. I think a lot of people don't like it for this reason, because you need to have basically 5 files in place in order just to get one dispatch to work. You need to have this store, you need a reducer function, you need a dispatcher function, you need a action function, you need a connect in your component. But I found that once that is in place, it actually makes it a lot easier to track down what's happening, as opposed to some of these other state management systems. It can get a little complex. So I'm a big fan of Redux. At Facebook, they've made a big push to moving towards hooks and to contexts. And when I have seen context being used, it's actually, I might be conveyed. I might be convinced to move to that side. It just, I guess for the reason it seems easy to set up. So I am worried that it's going to be hard to track down where the context is coming from and at what parent component is that provider actually being passed in. But it's very easy to set up. You can just say, create this context and add these variables. Boom, done. And then down below, access that context and use those variables. So those are 2 that I would recommend. Contexts if you want something just quick. Redux if you want to do it in the right way, that it will be easier to sort of track down for other developers later on.
Good answer, thank you. And someone else actually just asked something as well. Hey, John, should I go Flow or TypeScript?
Well, I feel like I have to say Flow, having worked for Facebook. I'm probably biased at this point because I've spent so much time in the past like 6 months converting things to Flow and adding Flow, and I just think it's wonderful. But I can't say I really know like the particular difference that makes one better over the other. I think in this sort of argument, it's more just choose one and stick with it. So here was what I'll say. It seems obvious at Facebook to do this, but if you're a startup and you're interested in hiring talent and trying to find a lot of talent out there that you may be adding your pool, there's probably more people who know TypeScript and are interested in working on TypeScript. And so for me, I think if I were starting up a company right now and I was interested in finding talent, I'd probably stick with TypeScript for that reason. It might make it easier to hire.
Good. We have another question from another chat, which it cuts off. So I'll read the question to you with the remaining words. So what do you think about manual rendering by using state? Assume that we are not using state in our HTML. I'm using a JS variable somewhere else. So when my JS variable changes, I want to render, basically. That's what it says.
Yeah. I guess the first lesson that I mentioned in this whole talk was use state management right off the bat. And so it makes you wonder, in what scenarios would you not want to use state management? In what scenario can you just render things based off some JavaScript variable that's changing here and there, instead of having some big old system that you need to implement? And I think there maybe is a few use cases. Like if you have some landing page that you just want somebody's email and you just want to trigger like thanks for signing up. In that case, maybe staying away from a state management system makes sense. But my general idea is anytime I've built a project in the past, it's started out simple and gotten more and more and more complex to the point that if I didn't add state management in the beginning, I wish I had. And so what I would think about manual rendering, I would say try to find a state management system that works for your use case. I don't know if that really answers the question. I may not have understood it perfectly, so feel free to ask differently if I didn't.
Like you said, if I'm sure they'll follow up if whether or not they're happy with that answer. We have another question. I didn't expect to do questions now, but we have so much time left that we might as well.
I guess I didn't expect to run through this talk really quick.
It seems to be a running theme. We're constantly ahead of time. So dear audience, please continue asking questions. We've got all the time in the world, so please go ahead. So next question. Will TypeScript someday be a part of ECMA script?
I'm not the right person to ask that question, but I believe I remember searching for that myself and seeing in the ECMAScript documentation that they had that in the plan. And so I would recommend just Google searching that and looking for documentation. I think they have future plans in their documentation, and they even have release dates. So I wouldn't be surprised if that's in there.
Mm-hmm.
My guess would be yes.
Sounds good. So I'm thinking I have 5 questions in front of me. Should we do them now, or should we save them for later? What do you reckon? I guess we could ask them now, couldn't we?
Yeah, just in case you see me looking on the side, I'm reading some of the notes that I made for myself just to see if there was anything else that I didn't mention that I'd like to add. But
no worries,
I'm open to just tossing out questions.
Oh, good. There's questions popping up. Okay, so next one. Can you share any thoughts about React Server components?
I'll say just in general, I mentioned that when it comes to state management, it's important to just understand the concepts, because if you go to like 4 or 5 different systems, just having those concepts can help you pick them up really quick. And even when it comes to server-side components, regardless of React, I think I'm a big fan of server-side components in general, no matter what the front-end framework is. I think I worked at this company, Branch International. I didn't mention that during the talk because Branch actually didn't use React at all, but we made a heavy investment there into server-side components for our Android application. And that was awesome. That was a big deal. And the biggest deal there, I guess, was that for the Android applications, let me back up. We would release new code and deploy our code to production every 45 minutes. At this company. It was amazing. They had just wonderful continuous integration. But when it comes to the Android app, it was every month. And this was because we wanted to be really careful not to create things that weren't backward compatible, because so many of our users had old applications from years and years ago. So when we made this transition to server-side components, it allowed us to make tons of changes that otherwise would have taken a month or 2, because we were worried about it being not backward compatible. But in this case, we were like, oh, well, let's just change the server-side component rendering, and then we can have a whole different front-end display for that user. So I'm a huge fan of server-side rendering in general as a concept, regardless of whether it's at React.
Great. More questions. So Marta asks, will TypeScript stay with us, or is it just a temporary trend? What's your opinion?
I would be really sad to see TypeScript go. I feel like there's been a few other strongly typed languages that the fact that TypeScript comes to mind so prevalently, and when I look at all these companies that have job descriptions that are advertising, they have TypeScript, and when I talk with friends who are running companies, they're implementing it. It seems like something that's going to stick around for a while. Will it stay with us? There's no date there, so will it stay with us for the next 500 years? Who knows? Probably not. Will it stay with us for the next 5? Yeah, probably. So I think it's a worthy investment.
Good. It's funny that I'm moderating this for my colleague Anna, and I'm organizing essentially a rival summit on Vue. So everything all of you guys are saying, I'm like, okay, that's great. So Also, please buy your tickets for Vue. But we'll come back to that. I will be making an announcement later on. But okay, next question. What about backend solutions for React?
Well, I might not be the right person to ask for this. I think my perception of React is that it's built to be a front-end framework that should be agnostic to a backend solution. I will say there's been a few times that I've tried to create a Ruby on Rails backend application using React on the front end that I feel like I've hit the wall, and I'm just like, why isn't this working? It is not meant to work super well with Ruby on Rails, and maybe that's changed since I did it. Let's see, the times that I've used React has been mostly with like Python Django or some custom implementation more than Ruby on Rails. So I would just say, yeah, the only comment that I have there would be if you're using Ruby on Rails, it's probably going to take a upfront investment of getting that integration. I know they have a number of different commands that are supposed to set it up properly, but it just hasn't worked for me in the past very well.
Mm-hmm. Fair enough. So I'm just thinking out loud. I think too much of a good thing isn't necessarily great. So even though I still have questions for you and we still have the time for it, I do think I should save those questions for later. Oh, there goes another one. Question. What do you think about using Redux structure, reducers, actions with hooks and context? Never mind, just forget everything I just said.
Using Redux structures with hooks and context. Huh. I don't know. I don't think I have the right answer for that. So forgive me for just giving my best try here, but I think it's not really designed to, I feel like my experience using hooks and context is not designed to use Redux structures. And so it feels like if I were doing that, it's probably just because I've spent a lot of time in Redux and I'm trying to morph something that I know into what it's supposed to be. So just my immediate assumption would be that this is probably not the right approach, and we should read the documentation and read examples and find out how this is supposed to be. I bet you there's a ton of like how-to documents out on the internet that say hooks and context for Redux users. That's specifically designed to like people who think this way and who are used to this structure. Here's an example of how to do it. Maybe what you were getting at, Elena, was that I liked the particular structure of Redux, and hooks and context don't necessarily require that. And so if you use that same structure, it could have the best of both worlds. And I like that argument. If that's the argument you were making, that would be great.
So we'll see what Elena says. The person actually that asked you about the backend solutions for React says thank you for your answer. And we have another question from someone else saying, what about picking a CSS framework to work with React?
I'm not the right person to ask for a CSS framework. Whenever I've built applications from the ground up, I just kind of find what's new and popular out there at the moment. I think right now I'm using Xstyle a whole bunch, and we're trying to remove all CSS. I've used Foundation in the past that I personally really liked that, but I don't have a great suggestion. I'd say whatever works for your use case. I don't think you're going to have a hard time hiring one developer over the other from that, and I don't particularly see like a year down the road being really upset because you chose a particular CSS framework.
So, okay, unless the audience keeps asking questions,
Yeah.
I'll ask one more question.
Oh,
Never
okay.
mind. We just got a question. This is wonderful. I'm actually really enjoying this. So,
I see the question here by Adolfo.
Yes, it's on screen as well. So any
awesome.
advice about how to organize your components by folders and names to accomplish what you said before? Find them easily. Thank you.
Let's see. Any advice I give on a particular naming convention would just be my own personal experience. But if I can try to abstract that to general advice, I would say I want my components to be highly specialized, as I mentioned before. So I'm okay with a really long name. I'm fine with that. Some people think, oh, this has got 30 letters. This is horrible. And I'm like, that's totally fine with me. If that helps me find my components, I'm okay with that. I am okay with having like 300 files in a folder, which sounds a little strange sometimes. But as long as I'm able to quickly find that file when I'm searching for it, that's fine with me.
Is that your final answer?
I guess as a developer, I want to be able to read the path of folders and the file and know exactly what the file does. I shouldn't even have to look at the code. I'm a big fan of test plans and file paths that I don't even have to look at the code. If I read the test, I know what this whole system does. If I read the path and the file name, it should make sense what it does. If I then go into the file and there's a thing there that does what it says and there's another thing, those should be two files. That's my opinion.
Great. Okay. Different question. How would you organize your Redux folders? My company wants us to group reducers, constants, actions, and store together, and separate folder for action types. Would you agree with this structure?
It's when they say here, let me read this.
Okay.
In a separate folder for action types. So separate folder for action types makes me believe that they have a single folder for the reducers, constants, actions, and store together. And that seems to me like an overuse of that particular folder. Why not have a folder for each of those? I don't think it hurts in any way. So that seems fine. I like the fact that you have those all separated already in different files. In terms of a folder structure, I personally would say create your reducers into a folder and your constants maybe one up above that, and your actions into a folder and your store there too. And so again, when I read that folder path, it should say my app, my feature, this like state management, my store, and then the name of the store. And you're like, oh, this is the store for that feature for that app. That makes a whole lot of sense.
Yeah. Honestly, you and I are on fire. The questions just keep rolling in. I thought we would have ended ages ago. This is fantastic. So, next question. Is it better to use CRA or build things from scratch?
So I don't know what CRA is, but in general, I think maybe we can paraphrase this to just, is it better to use an existing application or existing component or build something from scratch? Is that all right if I make that assumption?
Yeah.
I find it really depends on the business and your time.
I'm sorry. The person or another person said it's create React app. That's what it is.
Oh, okay. Oh, thanks.
Oh, actually, the comments are just blowing up. Everyone's saying that. So we both learned something new today.
All right. I guess I clearly haven't like started from scratch in a while, as opposed to just coming in and working on existing applications. But all right, is it better to use create React app versus from scratch? Every time that I have created from scratch, I've used a create React app command. But from my memory, when I last did that, there was like 30 or so different commands to choose from that had different frameworks and templates. It wasn't like there was just one that I had to choose. In that command, there was a bunch of different options. I was fine with that. I think starting from scratch seems a little ambitious, but I mean, if you consider yourself to be an expert, you know exactly what in those template React apps that you don't need, and you know exactly what you do need, then go for it. Great, more power to you.
Great. Next question about
Everybody's
Facebook. I know the comments are just About
I guess something you never want to do as a speaker. It's like, I don't know what that is. But thanks everybody
But
for
we're all
allowing me to be
human.
humble. Yeah.
Right? Yeah, it's definitely a reality check, isn't it? So about testing in Facebook, besides Jest, are there any other OSS technologies?
Not that I know of. I use Jest for all of my testing, and so testing. Oh, in Facebook specifically.
Yeah, Facebook.
I'm sure there are, but the only ones that I use are Jest. There's got to be like 50 or 60 different testing frameworks that I've seen. I mean, I just wrote some tests in C# recently, and that was a real headache. Everything was customized, but when it comes to testing in JavaScript, the Jest tests are pretty robust, so I just use those. I'm going to just real quickly review. Yeah, I don't think that there was anything else in my lessons that I wanted to share. So how are we doing? It looks like the questions are dying down a little bit.
So there's another one that I definitely want to ask, which is this one. And then I think they're dying down for now. Any advice for architecture or structure in terms of folders for a basic starter project, i.e. services, core, data, etc.?
Well, even though I was just saying, oh, I don't know what CRA is, if I can just reflect back on my experience from creating applications from scratch, it's usually been, I'm going to go as a starter, read like 4 or 5 of these to do like how to demo apps that usually is 30 minutes to an hour of each of them. I'm going to pick out which Create React app starts, and from there, it usually gives me a folder structure. In terms of data, I think, if you're talking about backend data in which database to use, that's sort of a whole nother topic. But in terms of state management, we talked about that. I think I'm a fan of Redux, and I think it's very simple to implement that with a lot of these starter applications. In services, I don't know, just a personal preference. I have a folder that I tend to call services, that this is a service that is reaching out to a separate service outside of my application. And so I just personally tend to name things a service when it happens to interface with something outside of my app. But I don't know if that's relevant to this. My main advice here would be find one of those Create React app scripts that work for you, and stick with that folder structure until you find something that you like better.
Okay. There's another question. It seems like no one wants you to go. Okay, possibly last question. In your 4 companies, what was the best CSS approach that worked, that was the easiest to maintain and use? Was it CSS in JS, CSS global files, or Tailwind/Bootstrap class dumping style?
So I caveat, I do generally consider myself a backend engineer more than a front-end engineer. And so I don't tend to spend a lot of time in CSS and CSS frameworks, but from just my personal experience, anytime I found that there was inline CSS in files, it's been sort of a headache. So I do like when I have like an XCSS file or some sort of compiled CSS that has variables that I can reference everywhere in my application. So I prefer, I guess, these global files that are compiled, that have variables that I can embed things into. So instead of saying like, here's this one CSS thing that I need to add another one, I want to be able to embed rules that says for this particular page, for this application, for this component, for this thing, here's what the CSS should be. And that also allows me to test that component very nicely. So I feel like I just sort of threw up a little bit of advice there, but hopefully that helps. Anything that you can add in a variable that you can reference around and anything that you can pull outside of an inline application. Like if you find yourself saying style, like in HTML, if you add style equals, display bold, like, okay, that you need to figure out a way to get that out, in my personal experience.
Okay, so for sure, last question, because we have a Q&A soon, and I have an announcement to make before that. So last question, everybody, please continue asking John questions, but save them for the Q&A. That's actually more of a mental note to myself. But last question, any advice to split component business logic, connections with Redux store and presentation, so FE container, component business logic, and component view is okay?
Okay, so I will say, from my experience, I found a lot of people, including at Facebook, shift towards these functional components that remove a lot of the business logic and just tries to keep, here's just the thing that's rendering, and here's a few, like when we, as I've sort of, well, let's see, is this just for Redux store presentation? I guess my answer is relevant to hooks, but as we've sort of made a shift to hooks, it's made it a lot easier to do this, to create these functional components where it's very easy to separate out business logic. You can take a whole function that's meant to do something specific, pull it into a separate file, and then you've got just your functional component that maybe calls that file. So in general, I am a fan of separating business logic and connections with Redux store and presentations from just component rendering. I do think I am a fan of the shift towards hooks and making things just render what they need to, as opposed to a component that manages all of its logic as well.
Okay, great. So black dots, I see your last question, but I'll save that for the Q&A because I need to give John like 2 minutes to breathe. I'll make an announcement and then we will see everyone very, very, very shortly for the Q&A, actually in 5 minutes. So John, have a cup of tea or something, relax for 5 minutes, and
thanks everybody for the flurry of questions. It's been wonderful. As you can probably tell from me, I don't feel totally qualified to necessarily answer all of these, but I hope you can appreciate me just trying to provide my personal experience, as this was the case study festival. And hopefully those 4 lessons, even though we went through them really quick, are things that will help you save some mental pain later on when you're realizing, oh wow, this would have been really bad if I had created, if I hadn't created new stores, or if I hadn't done the strongly typed early on, or if I hadn't created state management. So my best wishes to everybody in the chat. Thank you all.
Thank you so much. See you soon. So, oh, whoopsie, I need to get that question off. And that, oh, crikey, what a mess. So, like I said, I do have a quick announcement to make before we go for our break. So, our dear attendees, thank you for commenting on YouTube and Pine that you're enjoying the talks. We really value that because all of our speakers and team members worked so hard to make this event happen. And it really is a team effort. It's a group of maybe like 50 people in total working so hard. So we're having a giveaway for our events among those who will post on Twitter and tag our official account of Geekle of @Geekle Official, and write what you liked most about the event, whether it was the speaker, a topic, or anything else that you enjoyed. There will be 5 winners, and they will get 2 free tickets for any Geekle event of their choice. So thank you for listening, and I'll see you after the 5-minute break. how do I? Hi everyone, we're back. I cannot figure out how to get. There we go. So we're back for our Q&A. So let's have the people that are already backstage, let's have them join us. If anyone else wants to join, they will come. So hi, Daniel. And hi again, John.
Hi.
So we are getting a lot of comments thanking you both for your talks. So since John just answered quite a few questions, I'll start with Daniel. So let's get going. First question is, how was your experience building forms during your time in that project?
Okay, that's definitely a tricky one. When we started at the project, in that particular project, we decided to build our own custom form validation solution. And that soon became a nightmare to maintain, basically, because, well, it might be easy when the application is very simple, when the form is not that big. Once it becomes bigger, and we have a lot of variables changing and values changing, we got to have a couple of issues with closures because values components were referring previous states of the variable of the form, and basically when it was really tricky. So what we ended up doing was migrating to React Hook form, which is really great. We started using React Hook form and integrated it with Yep for the validations part, and basically it made all the process of validating stuff much more easy. We didn't have issues with closures regarding values on the form, and yeah, became so much simpler.
That was a very quick answer. I just want to remind everyone that we do have about 30 minutes for this Q&A, so feel free to take your time. There's no rush. Okay, thank you for your answer. John, question for you. Do you prefer to keep test SCSS utils, container, and view files in the same folder of component?
That's a great question. I think this is really a personal preference. I personally like to keep them in separate folders. I think a lot of the testing frameworks actually are set up to search for tests in separate folders. And so I try to separate them out to make it easier to find exactly what I'm looking for in those testing scripts. And so I find it really nice also as an engineer when I'm just going through code, I can see, okay, here's my components. Oh, I wonder what tests there are for this. And then there's always a folder right next to it instead of trying to see all the files and having tests sort of like interspersed between them. And I guess I would probably say the same thing about SCSS, except for the fact that there's not a script trying to catch it. It's just nice to have it in a separate folder to check. So personal preference, yes, I do prefer that.
Great. Question. So
and
I don't
hello,
have.
Adora, and hello, Daniel. Good to meet you.
Nice to meet you all.
Yeah, so I brought Adora in, but this is Adora. So I don't have banners for all the questions, so some of them I will just be reading out loud and some of them will be up on screen. So I have a question for Adora. In your opinion, what are the least efficient methodologies for an engineering team?
In my opinion, what are the least efficient methodologies for an engineering team?
Yes.
Least efficient. That question can mean multiple things, so I'll go ahead to answer it how I understand it. And I would say that methodologies for teams that are least efficient. When you're thinking about engineering teams, you're thinking about possibly building a culture in that team and in that space. So when you're talking about things that you feel like are not efficient, either because they don't maybe make you move forward, or they just don't make your employees happy or your team members happy, it goes down to the kind of culture that you are building within the team. And the culture is very important because as much as we talk about, everybody, or we try to talk to people in management about, diverse hiring and inclusion and everything. If you do not build a culture that actually promotes that inclusion within your team, you get a diverse hire, you get different kinds of people, and they'll still come to that team and they'll still not be happy, right? So in your mind, you've sort of done the work that you thought you were supposed to do, and to get, you've been intentional about your hiring, and you have like good representation across different spheres and different demographics. But somehow people are leaving, or people are not happy, or people are not doing the job well. It could be from how people interact in the team. It could be respecting people's time. It could be how you talk to people when you are reviewing somebody's pull request, for example. If I'm a junior engineer and this is maybe like my third or second PR in this particular repo and I do something wrong, the last thing I would want someone to do to me is to be harsh, because I would feel like I would kind of go back into my shell and don't want to come back out again. So I think that if you don't promote a good culture, then whatever you do is going to be ineffective or less effective. But trying to trying to appreciate people's spaces, promote good cultures, and just be deliberate, not just about the fact that you are trying to have representation in your team, but also that you are hiring the kinds of people that when they come into that team still embody that kind of culture that you already have within the team, is something that will help a lot.
Great, thank you for your answer. By the way, I wanted to say if any of you at any point want to add something to what someone else said, please feel free. Discussions are very much encouraged.
I'll add something to that.
Yeah, go on.
Just from if I can think of like an example of something that I've done that was very inefficient. I worked at a place one time where we had 2 required reviewers per PR. like you had to have 2 people required to review it. And at first we're like, yeah, this is a great thing and it's really going to help. And then inevitably we had a ton of like pull requests and diffs and stuff that would just sit up there and it would be hard to get people. That really was a inefficiency. But I like what Adora said. I think it really depends on the people in your team and what works well for them. I've found some of the most efficient teams that I've worked on is more finding what works best for each member of the team, as opposed to finding a particular strategy that works best anywhere. Is finding like, how does this team work well? And I think even you as an individual, if you want to be efficient with your team, coming to the table with that attitude can be really helpful.
Great, thank you. So next up is Daniel. So did you only use the testing library in Jest for testing, or did you use something like Cypress?
So yeah, we divided stuff into the following perspective. We use Jest and React testing library for building unit and integration tests. So we tested each component individually, and then we tested the integration of components with each other. And then we decided to start using Cypress to building the end-to-end tests, which would be tests that required testing the interaction between pages, testing interaction with the backend and stuff like that. So my main answer to this question would be, yeah, React as a librarian just for unit and integration tests, and then Cypress for the end-to-end, because it's more easy to use Cypress for that than the testing librarian and Jest.
Great, thank you. Next, question for John. Why is it bad to dispatch more than once per action?
This can be really tempting. It's like, well, I have 2 things that I want to do. But I guess the reason why this can be bad, and just to maybe rephrase, we're talking about you've got somebody click some button, it creates an action, and then you dispatch to update this form and you realize, oh, but I also need to dispatch there to update that form. Maybe I'll just have 3 separate dispatches. But what I found in my experience is those dispatches can sometimes cause other ones, which then can maybe even cause other ones. And you run into race conditions where you're expecting something to happen and something else might overwrite the thing that you're expecting to happen. And that sort of bug is really hard to track down. It's like, oh my gosh, why this thing? It just happened. I saw it happen in my debugger and then it just goes away. Why? It's because you've got multiple dispatches. So how do you solve that? It's like, well, I still want to do these 3 things. And so I would recommend trying to find a way to create a new action that does all of those 3 things in one. And you dispatch this new super action that does those 3 things. And that way you can guarantee which one happens first and when.
Good answer. Thank you. So I have a question for Adora. Oh, also, so Black Dots, my favorite viewer, the most active viewer. So Black Dots, please at the person who the question is aimed at, because for me it's a little hard to understand, but it would be great. Thank you. Question for Adora. How do you handle non-mission oriented participants? Can they be performers too?
Handling non-mission oriented participants. I think the most important thing is not everyone is going to share the same vision as you. Like, let's tell ourselves the truth that there are some people that will join your team or join your company not because they enjoy the work that you are doing, but just because they want to eat. And in that context, like, not everyone is going to have that same shared mission or shared vision as you. But I think that it's not by having a shared mission that makes you a top performer. If I'm being very honest, you might really want something, or you might believe in something, but you might still be very lazy to do the thing or put in the work that gets that thing done. So the fact that you believe in it doesn't actually now make you a top performer in that context. I think it's important to, whether the people that are coming on, the people that are onboarding are like have the same mission or the same vision as you. I don't think that that's very necessary. I might be wrong, but this is what I believe, in my opinion. I don't think that that's very necessary all the time. I think what's important is people that are ready, people that are willing to learn. I think that that's one thing that is always very important. Teachability is something that I don't joke with at all, because except maybe you're a startup and you're a very fast-paced environment that is moving too fast, and you might need to make some trade-offs, like, okay, I need to hire somebody that is very experienced over this because I need to get to a certain place in this certain time. But if I was, for example, me personally, already running a stable company, I would want to have that balance with these people that have that experience and people that don't probably have as much experience, maybe don't even care about any mission or vision because they are just graduating from school and the first thing on their mind is to get their first job and get their first check. But they are willing to learn and they are seeking growth opportunities. They are enthusiastic and they are not afraid to try new things. I think that these qualities are more important than people sharing the same goal as you, because people can share the same goal as you, but nobody's willing to put in the work to get you closer to that goal that everyone is thinking about. And then what do you do then if you're stuck with those kinds of people?
Definitely. That was very, very insightful. Thank you for that. Actually gives me a lot to think about. So next question is for Daniel. Daniel, what did you add to the project that you didn't discuss during your talk?
Oh wow, so many things. Like, I guess one of the things that John talked about was TypeScript. I saw a question about TypeScript. That was one of the things that we added to the project. It definitely made the entire process of managing contracts with the APIs more simple and more easy to understand. Let me see what other things. Yeah, React took form to handle forms. That's definitely one of the things that we benefited, and it was really great. And one of the things that I have to give a big shout out is MSW. MSW basically allows you to it's MSW. It's called mock service worker. It's basically a service worker that you can use to intercept your request. This can be used on the UI part or on the tests. And this is really great for UI when you already have a contract with your backend, but your backend is not ready. You can use MSW to set up like a mock server or something like that, so that you can use in your application while the backend is working at the same time. And for testing, it's really great as well, because we also intercept all your requests, and you don't have to worry about mocking Axios or mocking fetch and having to worry about mocking all the stuff. So I guess these are the main things that I remember right now that really we benefited from by adding it to our project.
Great, thank you so much. Here's a good one. This is a question for everyone, so I would like to hear from everybody, please. What technical book or books should every engineer read, in your opinion? That's a really good question.
That's a really good question, yeah. The ones that come to my mind right now, it's definitely 7 Habits of the Highly Effective Engineers. Not engineers. 7 Habits of Highly Effective People. Yeah, that's it. And the other one, probably more on the technical part, I'd say the Clean Coder is definitely a must read.
Thank you, Daniel. Everybody else, please.
Yeah, so you mentioned the book that my talk was actually based on, and I was going to mention that, but that's a non-technical book. I'm currently trying to do this now because I had a technical book in my hand at the moment, and I'm just going to show it on the screen. So this is the book. It's called Accelerate: Building and Scaling High-Performing Technology Organizations. And I think this book is very important because of the way technology is going recently. Everything is moving to the cloud. DevOps has become more important. So I think that engineers, whether DevOps or not, just because, especially if whatever you do has anything to do with the cloud in some way, this is a book that I would really recommend that you read, because apart from the actual technical bits, it talks about measuring and changing your culture to adopt, the cloud. And then there's some research that was done about like current different teams, how they are currently doing things, and the move to the cloud and like scaling and all these different things, especially in the context of organizations and teams. And I think that I don't know if it's visible enough, but I'm not going to try and mention every single author's name so that I don't spoil it. But I know there's a Nicole Fosburn, I think. She has a PhD. There's a Jez Humble and there's a Jin Kim, I think. I'm not sure. I'm going to write it down here. Hopefully. But yeah, this book I would totally recommend to anyone currently. Accelerate. All right, let me read the full title. The Science of Lean Software and DevOps. Accelerate: Building and Scaling High-Performing Technology Organizations.
Thank you. And John?
I second the Clean Code book. And in general, I've mentioned that with a lot of the in my talk, I mentioned that state management systems. I found I've used 4 or 5 or 6 of these, that a lot of the structures carry over, the concepts carry over. And so I'm a big fan of finding, as an engineer, what's a way that I can find good structures that carry over to different technologies as they change over the years. And so I think really any book that tells you about good design patterns is something I'd recommend. I know that there's a couple classics out there that I can't think of the particular author. I did just Google design patterns, and there's one by Eric Gamma. but I don't think that's the one that I read previously. And then I would say, this is going to sound a little funny, but cracking the coding interview, I feel like this is sort of a classic that actually has a lot of really good like advice from an engineer in there. And something, the basis of the question is about reading books, but I'd say something that's really helped me accelerate as an engineer is feeling comfortable reading documentation and getting to this point where I can say, okay, the book is really helpful to help figure out, like when I was learning Rails 6 from Rails 5, I got the book and went through a bunch of it, and there's a lot of good stuff there. But just being able to dig into documentation, maybe even finding source code and trying to make sense of it, it sounds so daunting, but once you really get the hang of it, or once you are able to like find a bug in the source code and make a little change, you feel so confident and proud of yourself. And I remember feeling like I can do anything. Oh my gosh, if I can do this, I can do anything. And so I'd highly recommend just digging into some source code or documentation.
Thank you all.
Actually,
please go ahead.
I was going to say that I agree with that. This is something that somebody has actually told me before, a very high level engineer. And I remember the day we had this conversation, and he was telling me that one of the best ways to actually learn how to write code, it sounds stressful, but it's actually by reading code. And when he said that day, I'm like, why? It's so stressful. But then I got to, and I think that's what made me go look at PRs. Even if I wasn't added on that PR, I'll just go ahead and go read the PR, go read other people's code. And a lot of things became clearer in that time. So I honestly 100% agree that reading documentation and reading source code helps a lot. Because I am a living witness to that.
Thank you all. I think you gave very good recommendations. We still have 7 minutes, and we're actually doing really, really well with time. Here's a question that I personally find very interesting. So Daniel and John, I never imagined that I would be the one hiring people, but here I am. What kind of React.js interview questions would you like to give, or what's a good example project for you to gouge?
Well, I guess that regarding questions, it's really important that you measure the technologies you're using in your project, or the project that you want that the person that you're interviewing to integrate with. If you're using TypeScript, start by asking a couple questions about typing JavaScript. If you're using some Redux, it's important that you get to know if the person knows Redux or the structure that comes with Redux. The organization, it's definitely really important that the person that you're interviewing knows what the environment that they are going to join, basically. Good project for you to gauge. I'd say it should be something simple that you take. Usually there are takeaway exercises. You could easily set up a couple of questions in stuff like HackerRank and stuff, so they have a bunch of questions that you can use for takeaway exercises. But then I say it should be an easy project that you should be able to evaluate stuff like, does the person know how to test React? Does the person know how to use hooks or use class components? Do they know how to add TypeScript? All the main things that you basically is part of most of the React ecosystem nowadays. I'm not sure what's the take of John on this.
So I'd like to add to that obviously when you're interviewing, you want to make sure that you find somebody who is qualified for the job and can do the things that you're looking for this job description. But I found that the project-based approach can really deter a lot of people away from your company. It can create a bad taste in the mouth of a lot of different people for maybe when you don't hire them and they've spent 40 hours, even though you've only asked them to spend 3, and that's just inevitable. I'm really not a big fan of projects. And if I'm ever in an interview and somebody asks me to, I say I'm unwilling. And so there's ways to get around that. I think that there are interactive project interviews where you can sit down with someone and actually code with them. And I found that to be really a great measure of being able to see how somebody works. I've done that, and it was very stressful as an interviewer, where, for like an hour or two, you're sitting there and actually working on a project. But at the end of it, I was like, oh, that was actually really nice. And I felt like I got to actually work with this person and show what my working with them would be like. So I am a fan of that. But even more so, I think I would be a fan in the talk that I just gave. There was a question about, like, should I use something that exists or create it from scratch? And I think that question actually has parallels in interviewing too. There's a lot of really great companies that invest tons of research into finding out how to remove bias from interviews and what questions should be asked in order to determine what are good. And they can get you 80% of the way, I think, in the interview process. And I think if I were to go back to hiring as a director of engineering, which I was before, I would definitely look at finding a third-party company that does a lot of this vetting. As an interviewer, that's been some of my best experiences too, where I've interviewed with a company, super stressful. I do it once, and all of a sudden there's 40 companies I have access to. I think that's a really wonderful system. I'd recommend it.
Thank you. So we have 3 minutes left. So I suggest we do one fun question and one serious question. So for the fun question, Daniel, this is for you. What's your favorite Funko?
Okay, that's definitely a tricky one, but I'm gonna get up and get it.
Okay.
So I'd say it's probably this one. It's an edition from 2008 Summer Convention of Reddit, which is a character from the Batman mythology.
Nice.
So this is definitely from my collection, my favorite one, basically.
How many do you have in your collection? Because that I can't even count.
Yeah, around 80 or something.
Wow. Wow. So you're committed. Okay,
Yeah.
so
Well,
2 minutes. Okay, thank you for that. Last question. Let's do one for Adora. I think this is a good question. Adora, for a junior dev, what should I focus on to become a good leader? How to learn more about it using books and videos for theory, or is it more of a hands-on learning experience?
I think it's a little bit of both. If you ask me, if you read a lot of things and never put it to practice, then you still don't know the thing. That's how I am. That's what I believe. I feel like most times, even if you're not able to read, so far as you've had an experience, you can learn from that experience. I'm someone that really believes in learning by doing. So I would say, as much as you read self-development books, as much as you read leadership books, if there's any opportunity in your team that allows you to be a leader and you can take it, I would suggest that you take it. If maybe there's a new person that gets hired and there's they need help and they're onboarding and they need help like figuring out a bunch of things, you can reach out to them and offer help. Little things like this is how you can actually start, and you can go from there.
Wonderful. Thank you so much. I can truly say, and I mean this wholeheartedly, I don't think I've ever had this much fun during a Q&A portion. They're usually so stressful because you're scrambling for questions, but this has been so much fun. It was an absolute pleasure to spend time with all of you. Thank you so much for being here. Thank you for your talks, and thank you for the Q&A. And I'll hopefully speak to all of you soon. So thank you, and see you later.
Thank you. See you all later.
Thank you.
Great questions, everyone. Thank you.
Okay.
Bye. So, it's just me now. We are about to go on a 15-minute break, which I think is well deserved, if I'm honest. The person asking, what are those in the background? So I don't actually know myself what they are, but they're called Funko Pops, if you want to Google them. So anyway, so before we go on our 15-minute break, I have a quick announcement. Give me 1 second, please. Right, so I would like to announce our Cybersecurity Summit flash sale. So let me just pull that up. 1 second. I'm looking for it. can't find it. Oh well. So, like I said earlier, I hope everyone is enjoying the conference, and it's time for our flash sale. So, mastering DevSecOps and security operations in 2021 is a matter of success or failure of a project. The world is changing very, very quickly, and so are the cybersecurity threats. To stay up to date and be ready for the latest updates and security challenges using clouds, scaling the user's remote access, apply the most actual and relevant security standards, one has to upgrade their knowledge as often as possible. IBM is projecting that by the year 2022, there will be 1.8 million cybersecurity jobs. Skills in cybersecurity are in very high demand, so join us to learn more about this exciting opportunity. And the flash price for the Cybersecurity Summit will be $59 with the promo code REACTFlash. Now, I'm going to do my best to find it again because I want you to see the there we go, I found it, the QR code. So please go ahead and either scan the QR code or visit the link that's on the banner and get your tickets for just $59. This is the lowest they'll probably ever be. And the number of tickets is limited to 20, so be sure to grab yours. So anyway, with that being said, we have 13 minutes until our next speaker. So let's take a break, let's stretch our legs, grab a snack, get something to drink, and I'll see you very soon. And we're back. So I hope everybody got a drink and a snack and everybody's ready to continue and get going. We still have around 4 hours left, so plenty of time, lots of hot topics. So stay tuned. So let's welcome our next speaker. I'm praying that I'm pronouncing his name right, but he's backstage, so hopefully he will correct me. Håkon Krogh, hopefully. So Håkon works for Crystallize.com, and his talk today is titled How We're Running Crystallize.com on Turbo Mode Using Next.js. Håkon is a front-end developer at heart with a passion for performance and outstanding user experience. He is head of engineering at Crystallize during the day, pushing API performance and developer experience. And at night, he is nerding out on new web APIs, protocols, and tech. So also, actually, I'd like to tell you about 2 previous talks he's done. In 2019, he spoke at React Amsterdam on the uncanny valley in React. And then also in 2019, he spoke at React Norway about high-performance React e-commerce. So I'm about to pull him up on screen. So like I said, let's give him a warm welcome. Hi.
Hello.
Please tell me I pronounced your name correctly, please.
It was about like 90% correct.
Really?
So
okay, how do we...
It's a pass.
It's a pass? That's good.
Yeah.
What's the correct way of saying it?
Håkon.
Okay, I wasn't even close. I'm so sorry.
Oh, come on. Give you some credit. It was good. I've heard way worse. Way worse.
Well, thank you for being patient with me. I will pronounce it correctly from now on. Håkon.
That's very good. Yeah.
Thank you.
Almost native-like. Yeah.
Wow, thank you. So how are you feeling today?
I'm good. I'm psyched.
Yeah?
I've been waiting for the festival for some time now. I'm got some really interesting things, I hope, to share, and really enjoying the online format. I mean, a physical conference has its perks, but then online has different ones. So I think it's a very good thing.
I think one of the biggest benefits that I can say from just our experience here at Geekle is we're able to reach a much wider audience. And that's so beneficial because truly you can be anywhere in the world, pick a time that's convenient for you and your time zone, unlike me, who's going to be here until 2 a.m. And you can just tune in, and it's truly amazing. I think it's there's not many good things that came out of COVID, but I think this is one of the few things that truly has been a very positive change, in my opinion. But anyway, I won't take up too much of your time. I could just sit here and talk forever. So we will see you again at the Q&A, and obviously I'll see you at the end of your talk. So I'm going to pull up your presentation on screen, and I'll let you get on with it. So good luck.
Thank you very much. Okay, I guess we'll talk later then. So, hello everybody watching. I have been working on my presentation for some time, and with great pride this time I can say it's only been me. I haven't had my head of design with me, so my apologies for any weirdness and the visuals. Anyways, let's get to the case. I am working for Crystallize, as previously mentioned, and the talk today is going to be about how we're running Next.js in turbo mode. So let me give you a brief introduction before I begin. This is the team of Crystallize, and that's me at the very end there. I am the head of engineering, trying to lead a brilliant team of skilled people, and we're trying to establish a new kind of business model out on the web, which is headless e-commerce, which is a very popular thing these days. I've been a front-end developer for a long time, 10, 12, 13 years or so, pre-jQuery days. I remember the introduction of jQuery as being something really big, and that was going to save everybody, and it did for some time. So anyways, that's me at work, and this is a picture of me at home when I'm not working, trying to teach my 2 kids how to do skiing. I live in Norway, and we have snow, lots and lots of snow. And skiing is one of the essential things you need to know how to do. In fact, when I was a kid, I had to ski to school sometimes because you couldn't bike and there was too much snow for the cars. So now you know that. This talk is about our website, crystallize.com. It's, as I mentioned, we're a software as a service. I'm just going to give you some context. We want to be a headless commerce toolbox, and we're both a PIM and CMS, just to throw all the abbreviations out there. Essentially, we're something that can enable you to build a shop or an app, something, website, app, whatever, that can sell your products. And to build crystallize.com, we looked at a whole bunch of different technologies. And from all of the things that you see here, we're going to ended up using none of them. In fact, most of the tools that you see here, or frameworks, libraries, call them what you want, would in fact slow us down more than help us. So this talk is going to be of neither of them. We're not going to talk about them. We're going to talk about the bare essentials of web and how they help us maintain super performance. Let's get to business. crystallize.com. So before we dive into the code and the performance and all the details, I want to give you a bit more context of what we're trying to do. So for our website, we needed to know before we started 3 years ago, we had to ask ourselves the question, what should it do? Well, it's mainly 2 things, and one of the first one being marketing. It's the go-to place to find out about Crystallize. It should promote our product well. And the next thing is documentation. So once you know the product or get to know the product, you probably want to know how it works. So it should also work as that. So it's marketing and documentation. How should we do it? Well, there's essentially 2 things we wanted to do. First of all, it should look good. It's like stunning. We want a very unique identity, which is why we have our own illustrator who draw this wonderful drawing of the man here being so amused. So that's rule number 1, which trumps everything. It should look good. Second, it should be fast. Fast is kind of the mantra of Crystallize. We're software as a service, and the API that we deliver needs to be fast. And I'm talking fast. I like proper fast. Not just your average fast. I'm talking fast. So we had to figure out what that meant for us. I mean, what is fast? Is it just, being faster than your competitor? Is it being fast at the marathon, or is it being fast at the 100-meter dash? What is fast? So in order to answer that question, we had to find out who our target audience would be. And I'm not going to spend too much time on these details. I'm just going to run through it quickly. So typically, it would be someone who is in a website for 2 to 5 minutes, looks at probably less than 10 pages, and reading about our product or documentation. Pretty much it. Okay, so knowing the target audience, we can then box them into one of 2 categories. Is it the load performance that we're interested about, or is it the runtime performance? And what's the difference? So I guess you would imagine load performance as the initial boot up of the website. Like, how fast does it take to images to show, the font to show, the layout to be painted? That's the load performance. And the runtime is sort of everything after that. How fast does page navigations take, any interactions, any state updates, and so on and so forth. But given our target audience, who don't really spend a whole lot of time on a website, doesn't look at a massive amount of pages, essentially just reading and scrolling, it's kind of obvious that what we're looking for in our website, it's load performance. And this matters the most. So when someone is interested in reading about our product, they should get the page served immediately, fast, and don't have to wait for things to load. Runtime is more critical to a different kind of website, like our back office application, which runs for hours and hours. Sessions are really long and they visit hundreds of pages. Then that's more important. And I guess we also have to answer the question, why we want to be fast. Why do we want to be fast? Well, it's an obvious question. It's an obvious answer to the question, isn't it? It's happy visitors. The faster you are, the happier the people. You're right. The more pleasant experience. The faster the sites, the less bytes you download. Potentially, usually at least. That's how you make a fast website. So the less bytes to download means you get a cheaper phone bill. Hey, that matters to some people. And it's one of the reasons. It's definitely one of the reasons. It's not the reason. It's not the top reason, actually. Nope. Could it be environmentally friendly? As I mentioned, being fast typically means you download less bytes. Okay, and that means we transfer less bytes over the wire. But, there's less work to do for the proxies around the world, less work to do for the CDNs. There's actually less to consume by the device that you're using, like your cell phone, which means it's using less battery to do it. And that's better for the planet. It's one reason, yes. It's not the reason. So to get to the brutal truth of why we wanted it to be fast, the number one reason why we needed to be fast, it's search engine optimization. SEO. It's not always the argument when developers advocate for performance, but for us, this is the number one reason. And why? Well, if you've been paying attention to what Google has been doing for the past few years, you might know. So back in 2018, they were on about that speed now mattered in mobile search ranking. So if you're slow, that's not so good. And then later on, in a couple of years later, just to 2020, they announced that the ranking signals would matter. Essentially, the metrics that they pull, the speed that they measure from actual users will matter in the ranking. This is critical stuff. And in this, you can read 3 very important words in its core web vitals. And for those of you who doesn't know what the core web vitals are, let me give you a quick run through. It's 3 metrics made up by the Chrome DevTools team, or I think DevTools team, I'm not sure. It consists of 3 metrics here that are something which should be reasonably easy to comprehend and to measure, at least. The first is LCP, largest contentful paint, which is the largest contentful paint on the screen. Essentially, the moment in time when the website looks like it's ready-ish of booting, or the largest part of the booting is done. And everything under 2.5 seconds is good, and the rest is bad, essentially. And the next is the first input delay. Again, this is very much something that the users care about. It's how long delay is it for the first interaction. So immediately after the website is loaded, the user might try to click something. And if there's a delay from the click to the action, that's your first input delay. And obviously, any delay is bad. If you have someone click a button, for instance, if you're landing on a product page and there's a huge buy button and you try to click it and it doesn't work, that might be because of really long first input delay. And it's bad, very bad for an e-commerce. And would be for us too. We don't want to have frustrated users on our website. And the next and last part is the CLS, the cumulative layout shift. Very fancy name for measuring the stability of the layout. Essentially, if you have things moving around because you've got images loading, which pushes content down, for instance, or if you have a web font that loads in late that changes the size of the text, then the layout will jump, and the user might lose their position where they were at when they were scrolling. Super annoying. So if that happens, you'll get a penalty for that, and then you can see that in the CLS metric. Okay, core web vitals. So all of them are in the load performance arena. If you go and look back, you can see that all of these matters in the load scenario, which means we can use it as a way to audit our own website. This matters to us. We can use the core web vitals for Crystallized.com because this matters a whole lot for what we want to do. So how do you test it? How do you measure it? Well, you could do a quick Google search and find out. There's usually some brilliant people that can answer it. Essentially what you need to do, sorry for that last one, what you need to do is to use Lighthouse. This is a Google tool. It's in Chrome in DevTools. You can open the performance panel and do an audit on your current website. But if you haven't done that, I suggest that you instead go for an online tool like PageSpeed Insights, which is using Lighthouse to do a performance audit on any given website, which is really cool. And it's really simple too. You just input the URL, wait a few seconds. Now we're testing the conference website. I'm sorry. I didn't want to test around my website just now. I'll do it later. So for now, this is the conference website, and it's not scoring very good, but that's okay. I can help you make it better, but I think you know too. Anyways, you get a single score back, and you can see from the information below that anything from 0 to 49 is in the red zone. 50 to 89 is in the orange zone, and only 90 to the 100 is in the green zone, which makes it really difficult to get to the green one. It's also very, very hard to get to 0. I have to tell you that. I think I've seen 5s and 6s and stuff. I haven't ever seen a website score 0, so it's practically impossible. But as you can see, it's a single score you get back. And I just have to admit that this is a wonderful resource for developers. Having a single score represent the performance, well, load performance of your website is a wonderful tool for you to use to people that don't understand the fundamentals of web. You can't go to a project manager and say, hey, our first contentful paint is not where it should be, or the CLS is bad. No one's going to get that. But you can show them this and say, hey, we got 24 out of 100. We should do a lot better. We should be at 90 at least. It's a lot easier to communicate. So I truly love this, although it simplifies things a whole lot. Still, it is very valuable. Everyone in the chain gets this. You're getting 2 scores back, desktop and mobile. These are just simulated, they're called lab data. And the reason why you're getting different results is because, well, a desktop machine is more powerful than a mobile phone. So the first contentful paint is always going to be faster because it takes the desktop shorter time to paint, essentially. All right, enough background already. Let's get to the real juice. Let's look at what our first attempt of making Crystallized.com. And finally, we get to see some actual stuff. Okay, so back in 2017, we got real creative and we came up with the first version of Crystallize.com, which looks like this. And it was beautiful. We were really happy, and it was a create React app with a custom SSR rendering running on AWS Elastic Beanstalk. Is a mess of a setup, but it worked, and it was beautiful. It checked the first box. It was stunning. We loved it until we did a performance audit. So we ran it through Lighthouse, through PageSpeed Insights, and we got this result back. Look at this. I mean, our largest contentful paint is 13.6 seconds. This is mobile score, but 13.6 seconds. That's a long time to wait for Crystallize. I mean, even I would be impatient. I mean, if you don't even know Crystallize, you would leave way before that happened. The 15 seconds the time to interactive. Obviously, we needed to do something. So it was time to roll up our sleeves and grow up and get to work. So the first thing we did was scrapping our Create React app, and we went for something which at the time started to look mature. That was Next.js. So it was a performance ready. So we were hoping that we could apply Next.js. And this is more or less what we did to get from here to here. And now I will be showing you 5 take-home tips plus a cheat at the end that will help you do the same if you're struggling with the same stuff. And the first take-home tip you can take home with you is this: design for performance. And the reason why this is number 1, it's because it's the most important one. Without a proper design as a foundation, you won't be able to have good performance. I brought in the head of design, Didrik, that's that dude, and we came up with the current version of Crystallize.com, which is a whole lot easier to optimize for performance than our previous version. The desktop version looks like this. The mobile version looks like this. And if you look at both of these versions, it's pretty much, there's some text, there's some buttons, there's a custom font, sure, but everyone has that. And there's a simple illustration, which is kind of vectorized, so it's easy enough to optimize. And the mobile version doesn't even have an image at the top here. So that's easy enough to do. Well, it has our logo, I guess, but not more than that. So this is rule number 1. So we applied a simple performant design, still beautiful in our opinion, across the entire site. So if you want to do the same for your own sites, you need to start here at the design. This is where everything is, the foundation is laid here. So the second take-home tip is you have to tailor-make your CSS. We had tailor-made CSS. So this is the second one. And that essentially means no material UI. No ready-made framework that has all the buttons and layout and all that. It is easy for you to make a website in using one of those libraries, but it won't take you all the way in terms of performance. If you want top-of-the-class performance, you have to scrap those libraries and tailor-make it yourself. We chose style components for our website, as a lot of people do. And if you're not familiar with style components, this is how you do a simple button. Essentially, you're tying the styles to the component. It's an explicit binding. And that, to me, is a beautiful, beautiful thing. Because having the explicit binding for the styles to the button means you can always have confidence that when you import something, the styles will follow along. And if you remove that component later, you know that the styles for that component will also be gone. And it will also, boost confidence when deleting CSS, because you know can be quite confident you're not deleting CSS that anyone else is relying on. So to me, beautiful, beautiful thing, which leads me to the next take-home tip, which is really cool. I really like it. It's critical CSS done in the proper way. Now, for those of you who haven't heard the term before, critical CSS means sending the CSS that you, at the bare minimum, need to paint your layout alongside your HTML or inside your HTML payload. Let me explain what that means. So back in, well, traditionally, you have one separate HTML file for your HTML. You have a separate file for your CSS. And in the HTML file, which is the big box here, you would say link to a style sheet, which is called style CSS or something. And then the browser would then parse the HTML document and then download the CSS file, which takes a bit of time. And if you want to save time, you don't do it this way. You do the critical CSS way, which is move the CSS into the HTML. It's simply now just a style tag with the styles that was previously in the outer in the external file is now just inlined in the HTML. It makes for a faster initial load, simply put. Fortunately for us, with style components, this is super simple. It's not an elaborate thing we have to spin up later where we, and these I've seen tons of implementations like this where you spin up a browser session that looks at your website and tries to pull out the styles that are the critical ones. You don't have to do that. Using Next.js and using style components, this is all you need to do. And yeah, it's a bit cryptic, but this is basically just a copy paste from the example, which you can find at the Next.js GitHub repository in the examples of how to use style components. And there are other examples for different kinds of CSS and JS libraries too. But this is all you need. And what this does is that it pulls out all the styles that your current route is using. So for instance, for the front page, this is pulling out all the styles of all the components being rendered, even down to the footer, everything. And you might think, well, that's a bit too much. But nah, you're going to be fine. It's not going to be massive. It's as long as it's tailor-made and as long as you're in control of what you're rendering, it's not going to be a problem whatsoever. Great. And obviously, that means that when you ship this inline CSS in the initial HTML payload, there's still going to be a JavaScript file, which Next.js so helpfully gives you later, which will contain the same CSS as you have in the payload. It's kind of a double download. And then for the subsequent pages, for instance, /blog, will contain the CSS and JavaScript for that. But hey, it doesn't matter much, believe me. Okay, the next take-home tip that we did, you should all be doing if you're doing Next.js, is static site generation. And essentially, it just means that you, instead of rendering the pages on the fly, you do it in advance. You build all your pages in advance. There's a lot of good resources you can read about this technique. Essentially, all you need to do is to define a get static props function on your page component itself. And this is a pure copy, a raw copy of how our front page declares its data dependencies. So it has a get static props function, and note the name static. If you don't want it static, you can use get server-side props, for instance, and then it's server-side rendered. Next.js is wonderful that way. Really, really nice. So initially, what this does, it moves your page or your application from being server-side rendered, which is it's taking some time, So server-side render means that, well, you have to boot up a node instance. And that node instance has to be warmed up, and then it has to receive the request, look at which route to load in those JavaScript files, pull the data in, render the page, and ship that HTML back to you. It takes about 1 to 1.5 seconds, more or less. But with static build, you're reducing this time to 100 milliseconds or less. We're seeing an average between 50 and 60 in our case. This is running on Vercel, but essentially the reason why it's so fast is that because it's static, it's already in the CDN. The HTML files are ready. The CSS, and obviously that's in line with the JavaScript, and that's ready. We're just requesting files now. There's nothing that needs to be rendered. And obviously the beauty of that is that we're going to be fast around the globe. There's no need for us to have a server in Rio and one in Tokyo and one in Frankfurt. We just put it on the CDN and we distribute that around the globe. If you're running Vercel or Next.js on Vercel, this is going to be automatically applied. You don't have to worry about it. Your website is going to be fast around the globe. And the last bit of the static thing is this one. Incremental static regeneration. Oh man, it's a long word. Very cryptic. Some people just now refer to it as ISR. I don't like abbreviations, honestly. I like saying it like the whole thing instead. And what it means, and I'm going to let my illustrator, Bartosz, try to illustrate it for you. Incremental static regeneration means, first off, when a user comes to your CDN and asks for something, like a product page, the CDN will just grab one, like a pre-built one, and just ship it to you. This is pre-built. All the CDN needs to do is to find it in the stack and give it to you. And the incremental static regeneration means that in the background, while the user is reading this wonderful product that you built, it regenerates the product page. It reads from whatever API you might have been using, and it puts that brand new product page back in the stack and gets rid of the old one. And when a new person comes along, requests for the same page, that person is going to get the new one. It's a wonderful, wonderful thing. So you don't have to worry about rebuilding your entire site. It's going to happen on the fly. And this is something you can enable really simply. And it works out of the box with Vercel. And all you need to do in Next is take your, remember this is our front page. So all you need to do to enable this is add this single line. See the difference? We have revalidate equals 1. Previously we didn't. Now we do. This one, no incremental static builds. Now we do. It's a wonderful little thing. So yeah, the next take-home tip, just kind of take a breath. Self-hosted custom fonts. Fonts are always a bitch. I have to say that. It's no fun. We are going, as a lot of other people doing, we're using Roboto as our custom font. And if you go to Google Fonts, which most people do to find their fonts, you can see, oh, there's a nice little link here with a pre-connect and stuff like that. It looks optimized, right? It even has that cool display equals swap, so that will be fast. No, it won't. So in order to have proper performance, we decided to inline our fonts along with the HTML response using font source, which is available on NPM. You can do that. Just download the font using them like this. You have this in our app.js file, and you're good to go. That's it. So by applying all of these different techniques, we were really psyched. Like we got Next.js, we got all the font loading, we got the critical CSS, we got static builds and all. We were like, okay, what's the results now? Like, how does this perform. And we were running an audit using PageSpeed Insights, and we were ready to pop the champagne when we saw this number, 78. It's obviously far better than 30 something, but we really wanted to get into the green zone and to 100, to be honest. So what were we doing wrong? So when we looked at the lab data, we saw that the largest contentful paint was still a bit much, and the total blocking time too was a bit much too. So we started to look at what we were sending the client. We looked at the HTML. So this is the HTML for any page. It contains our inline CSS, you might recognize that, the HTML, and then at the top there's preloading scripts, and at the bottom there's scripts, and in between that there's application state. It's a whole lot of extra stuff, isn't it? It's essentially what React needs on the client side to sort of recreate that entire HTML document. It needs the scripts, it needs the application state, and with those two combined, it can recreate the HTML and sort of rehydrate your app. Fair enough. But just a whole lot of stuff. And we thought, hold on, what do we really want to do? In a perfect world, this is what we will ship the user. No preloading scripts, no application state. So we were thinking, what if we get rid of them? How wonderful wouldn't that be? So we did a small, really quick test. You can do this too. Open DevTools, open the command palette, and disable JavaScript. It's a fun experience. You can browse pages, you try different websites and see how good or poorly they're working with that JavaScript. But for us, we saw that when we turn off JavaScript, the total download size went down from 2 megabytes to 1.2. And that 1.2 is still including a massive amount of application state. So it was becoming quite obvious to us that, well, when back in the days, JavaScript was just one piece of the puzzle. But now, in 2019, when we made this comic is just as valid today, looks like JavaScript is becoming its own very big monster and its own kind of puzzle. So we had to ask ourselves, why do we even need React in runtime? What are we using it for? So we had to look through, and it was a few things we used it for, the menu being one, this forum here, book a demo. We had a carousel with some videos. So we thought, we want to do this vanilla. And this is your final cheat. Do it vanilla. What does that mean? Well, it means you have to turn off React runtime. What? Yes, you have to turn off React runtime. Unfortunately, using Next, it's simple enough. Remember this page? You just add this. It's an undocumented feature, but Tim Nitkins from Next team, he won't hesitate to tell you how to do it. He keeps going on about that on Twitter. So this, by saying unstable runtime JS equals false, it will take away that application state. It will take away script preloading, take away scripts, and then all you're left with is your HTML and your CSS. And you're on your own. You're totally on your own. It means removing stuff like useState, because there's not going to be a useState. There's not going to be effects, so we can remove all use effects too. So for us, that meant we had to redo some of the stuff that we had in React and do them in vanilla. So that meant our main navigation changed from, and yeah, this is how it used to work. This is more or less how we did it and how most people would do it. Simple state, which we changed to this. It's still the same stuff. It's a main nav and a button. They just have IDs now. And this is the vanilla JS that you need. And honestly, it's not a whole lot. And if you ask me, this is perfectly understandable and maintainable. You see that we have a classless toggle open, which essentially means that we will remove and add an open class to the navigation. And the way that we specify this is that, well, we're using style components. So you can still use style components with this approach. So the at.open means that if the nav has a class called open on it, it will say display block. Simple? I think so. And the cool thing about that is that then you can apply all of the cool stuff that you want to do using style components, stuff like transform and scale and all that stuff, transitions and animation, keyframes, you name it. Things that you can or will not do with inline styles. The second example that we do, so this is the easy one. This is the more difficult one. It's the playground. So Crystallize, we offer a GraphQL server to people. And on the website, we wanted that GraphQL server to be played with, simply put. You can try it out. It's on the developer page today. You can go in, try it out, modify fields and see how fast our API is. I mean, we wanted that. And that sounded simple enough, right? Well, it's powered by a tool, a framework called Graphical. And you think, okay, cool, but that's, not a big deal. Well, if you look at what it requires, yep, React. We turn off React. But this tool needs it. So we had two options. We could either turn back React runtime for the pages that use the playground, or we could continue to do it vanilla. We chose the latter. We did it vanilla. And this is how we did it. Essentially, let me break it down here. We're adding two dependencies here. This is loaded lazily after the page is loaded. It's the graphical CSS that it needs and React core. So we're downloading a new version of React. It's totally independent from whatever Next.js ships. And this is just our approach. This is one way of doing it. And then we have the second part here where we're sort of waiting for React to be available in the window object. And then we inject the last bits. And then if you wanted to know what the wait for React function does, simply this, not really magic to that. And to initiate the graphical playground, all you need to do is this: React render React write element, and so on and so forth. Not really rocket science if you look at it. If you go back, we're just loading some scripts, steps, and then booting up the playground. It doesn't have to be more difficult than that. So the total download size went down. This is actually wrong. I forgot to update this. It's less than a megabyte now. We're down to 400 or 500 kilobytes. Oh, wish I had updated that. And the total client work went down from 270 to 0 milliseconds. So the results, well, remember this score? I think you might know. We got this almost consistently.
Hi, sorry to interrupt. We've run out of time, so do you think you'll be able to wrap up in the next couple of minutes?
I am.
Perfect. Okay, sorry.
At the very end.
Okay, great. Continue.
Nice. So this is the front page. This is one of the blogs that we have. We're seeing consistent runs between 99, 98, or between 98 and 100, essentially. And this matters to us because we will rank really high on the things that matters to us. So headless PIM being one of them. We want it to be at the top. You can try yourself. We want it to be at the, very visible at the developer comics and Google image results, which we are as well. And if you're curious to do the same thing, if performance matters to you, if you want to rank high or have an environmentally friendly website, or have happy customers, or cheaper AdWords, which is one thing as well, then all you need to do is turn on this flag. And this is a page, per page kind of thing, which means it's not application-wide. you can actually turn it on for a certain number of pages only. You can start with one. So this is how we do it. We have the runtime turned off for the homepage, each blog post, and each comic, but not for /blog and not for /comics. They are scoring decently, but not as good as the other ones. And we kept the runtime for blog and comics because they are actually doing a whole bunch of intricate React stuff with paginated list with infinite scrolling and stuff. So you can still have that. But for the critical pages, we turn it on. So this is what I hope that you can take home with you today. There's a lot of cool frameworks out there, but essentially, if you want to do it good, you have to do it tailor-made. So that's it. It's a wrap.
Thank you so much for your wonderful talk. That was very, very engaging. Some people are saying they like the comics. I like the comics as well. So wonderful. Great. Then I'm sure there will be a bunch of questions for you coming soon. And I will see you very shortly at the Q&A.
Yep.
See you soon. Thank you. So moving on to our next speaker. Our next speaker is Josh Goldberg. Josh is a senior front-end developer at Codecademy, where he focuses on the core learning platform, accessibility, and web infrastructure. He's also an overly enthusiastic open source and TypeScript aficionado and works on TypeScript static analysis tools on the side. Josh is from upstate New York, but currently lives in Brooklyn. In his spare time, he also appreciates a solid application architecture, crafting a retro game engine in TypeScript, and exploring meta languages. Ask him about his latest open source projects. Recently, Josh has given talks on advanced TypeScript usage at the last two TS Confs, React Native Performance Techniques at SWM Academy, and given introductions to open source at universities worldwide. His talk today is titled Slowest Page Ever, How We Kept Breaking the Codecademy Course Catalog. So welcome, Josh. Hello.
Thanks for having me.
Thank you for being here. How are you today?
I'm good. I'm excited to follow up a talk about Next.js and performance with another talk about slightly different Next.js and performance items.
Well, that's good. I think that's why those two talks are in the same block. So it's like you said, a nice follow-up. So thank you so much for being here. We are running a tiny bit behind, so I'm not going to take any more of your time. I'll let you get on with it. Do you have your presentation on hand?
You bet I do.
Great.
And here we go.
I'll add
All right. Good to go.
Wonderful. Thank you. Good luck.
Thank you very much. Hey, everyone. I won't bother you with more introductions. I'll just skip it right ahead. All the stuff that I'm talking about today is on joshuakgoldberg.com, slide notes, attributions. I will note if you don't like watching animated images and or if those images are troublesome or annoying for you, I recommend the PowerPoint Online Viewer because it lets you pause those animated images. Today, we're going to talk about a fun little set of things for performance. We'll talk about the situation, the Codecademy catalog, what is it, what's happening. We'll talk about a few problems we had on production, such as server bloat, script bloat, component bloat, what those all mean, DDoS, or dedicated denial of service, and then a few cultural takeaways and resources you can use to help not have the issues on your production app that we did on ours. Lastly, for the setup, a few ground rules. Totally fine to get lost, to not understand. I don't particularly find it easy to get a lot of information into my head from a single talk. Everything here is available online, on my site, and other resources. I would say please ask questions in the chat. I think there's a Q&A later, so looking forward to seeing you there. I also want to note, as with every other performance topic, React is just one way of doing things. Things like Angular and Svelte and Vue are totally fine too. There's no one best library or one best way. Everyone has their own needs and prior experiences. Good stuff. If you want to follow along at home, there is a code repository that will be jumped to frequently in this talk on my GitHub, which is linked here. This is, as a slide, also linked to in the website I posted before, joshuakgoldberg.com. It does require Node and Git to clone and then set up, so not too many repository needs. Fast moving on. This situation, a little bit about our catalog page and what I'm going to be talking to you about today. The Codecademy catalog shows all the courses and paths available to learners. It's pretty standard for an education company to have some kind of equivalent to this that shows all its offerings. It provides a few small features like filters on language and subject area. We've got a lot of courses, so there is quite a lot of data to show, but a lot of the data is in pretty normalized forms, say a bunch of courses or a bunch of paths. A little bit of context on the history of the page. It's gone through quite a few owners, so not only is it something that we've had to take care of with respect of performance, we also need to make sure it's well documented. In 1 year, it was the Learner Experience or LX team. Another year was Disco Nav, a team who is still yet to tell me why their mascot is a dolphin. That's pink and named Adolfo. And then most recently, it's been owned by the Reach team. So that's all to say the people and structures behind a product have a lot of influence on how that product evolves. So as we look through developing and architecting a product, it's important to also understand how the people behind it operate. Speaking of people, no one likes loading a slow page. That's why we have so many talks about performance and why frameworks like Next.js emphasize it so much. We've seen a bajillion studies from major software vendors and companies that users really, really hate sites that are slow. And if you have a slow website, you're probably losing money because of the slowness. But we need to really understand, what does it mean for a page to be slow? How do we quantify that? Back in the day, we had browser events like DOM content loaded and load, which were somewhat sufficient for measuring the performance characteristics of a site. DOM content loaded was when the initial HTML and DOM, or document object model, the representation of that HTML, were done. Load was, in addition to that, when the external resources like images may be loading. These definitions are a little rough around the edges. You can see more on the internet. The problem with these, though, is that pages could still be visually loading after these were fired. The initial view of a page might be a big loading box, and then 10 seconds later, the actual page gets rendered in. So now we have these much bigger performance scores called Lighthouse, which measure very particular things in the page with a certain weighting towards what's called the overall Lighthouse score. Lighthouse is an open source tool from Google, grades page performance based off of these attributes. It ships as a part of Chrome. It's also available as a standalone app or tool that you can use on your own. It's pretty nifty. I would highly recommend using it. We're going to be looking at how a page generally acts throughout this talk, not linking it too explicitly to these particular attributes, but each of them on your own time, I would highly recommend reading their pages. They're pretty informative. For example, my favorite one, largest contentful paint, is how long it takes for the largest image or text block within the viewport to render. Cool stuff. So that's the setup, that's the context. Now let's talk about the problems. Why is this page taking so long to respond? Server bloat. So I will make a couple of notes. One, all these problems are things we actually did ship to our users on Codecademy.com. So if you tried using our catalog and it was a poopy experience for you, sorry, that might have been me. Second of all, we should really understand how a page gets rendered in the general sense before we dive too much into the performance characteristics. You've seen shades of this before, but I do think it's good to reiterate and summarize. There are three major common strategies for rendering a page. The first, and we'll visualize these more later, is client on demand, as I call it. The server will send a roughly blank piece of HTML and some JavaScript to the client. Then the client uses that JavaScript to populate the page. It's the simplest one. It's the easiest to set up if you're using something like Create React App. The richest is server on demand, where the server makes a render or SSR of what the page should like and sends that down with the initial HTML and JavaScript, which means the client can get a really nice updated view of the page before it finishes rendering. And then the fastest is a version of SSR where instead of rendering the page for each request, the page is rendered ahead of time, and then the cached result of that is sent down to the clients. There are other fancy things coming out like React server components, but that's a whole other topic. So just to visualize, this is the simplest one, client on demand. The client requests a page. The server sends basic HTML and full JavaScript. The client will then start running that JavaScript, and eventually the client will render a full page DOM. This is nice because it's simple to set up, but you may notice there are two blue screens here. And that means that we have a lot of time, potentially, before the client is able to show the full DOM. In the second strategy, where the server now also pre-computes what the page might look like to start and send it down to the client, we have a little bit more of a complicated setup, so it'll take a little longer for the server to run, but as the benefit, the client gets a nice updated view of the page first. Server on demand. Lastly, we have server static, where the server sends pre-built initial DOM layer and JavaScript that was already computed ahead of time, so the client doesn't need to wait for a huge server request, which might potentially take a lot of time before it receives the first HTML for the DOM layout. Now, it might seem like I'm trying to edge you towards the server static version being the fastest, but I explicitly don't want to do that here. In theory, it sounds nice, but there are always trade-offs between things. For example, maybe the server does have to compute on every page render something specific to the user, so you can't use server static. Or maybe the users don't really care about performance. Who knows? So you should always be careful when you're designing your pages. Don't just assume that you know what the users need. And I want to show you the one problem that we were going to start with, where we tried to go for the server-side rendered version. We kind of messed it up a little. Now, to start, I'm going to show you a little bit about the dev tools. If you were to go to a page in, let's say, your browser, right-click Inspect, zoom in a little because you're presenting at a conference, drag to expand, and then go to the Network tab. This is a list of all the network requests that start on the page. Here we go. So this is a very simple app, the one that I mentioned earlier, the Codecademy Catalog Companion, and I'm on the home page. What I'm going to do is navigate to the Server Bloats tab and refresh the page and show you the status of this server bloat document request. This is the first request that comes in to the page. Here we go. And I'm going to go to the Timing tab. So this timing tab shows us that there's a TTFB, or time to first byte, of a little under 1/10 of a second. And then it takes another 1/10 of a second almost to download, giving us a total of roughly 200 milliseconds to load the page. I'll also note that I've disabled cache checked here because we don't want page request network situations to be cached between page loads because we're trying to measure performance. It would be annoying if sometimes things worked quickly and sometimes they didn't, and it was because of browser caching. Okay. So let's look at this in a little more detail. So I do want to note in the screenshot I took for the slides, it was a little more than 100 milliseconds. Network requests do fluctuate a lot. So definitely I'd recommend running several times and getting an average, perhaps removing outliers if you're running on your own site. I'll also say that 200 milliseconds might not sound like a lot of time to wait for a page, but if you're a user and you have to wait 200 milliseconds before the page can even start to load or render, that's a lot of time. So I also want to mention that not all users are fortunate enough to have a really good connection. If you were to say go to the throttling version and throttle to say a fast 3G connection, then restart this request, you might see that it could take up to half a second with 1.7 seconds of time for, let's say, a request that previously only took 1/10 or a 1/5 of a second. That's not great. The issue that we had on our catalog with this server bloat situation was that, and I'll actually show you the code example. We were doing a whole bunch of computation on the server for stuff that we didn't need immediately when the page loaded. We were loading all the courses and then loading all the paths. By the way, a path is a collection of courses, like web development rather than learn JavaScript. And then we were rendering them in the page. If you're not yet familiar with Next.js syntax, totally fine. This is the function that gets run on the server, and this is the result of that function getting passed to the page. And if you look at this page, with the page bloat, you'll see that we show the paths first and then the courses. But if someone is just refreshing the page to start, they don't need to see all the courses to begin with. It's a waste of time to do that on the server. So we switched to a version of it where we only loaded the paths to start, and then later on the client, we would load the, oh no, it's taking a while to load. There we go. we would only load the courses later on after, say, a second or the user interacted with the page. So now the content download, because it didn't have all this HTML with all the courses we had ever given, it's a lot smaller than HTML. It's only 25 milliseconds to download on a fast 3G rather than some ungodly amount that it was before. And I'll show you the code that was the fixed version of this. So instead of loading the courses on the server, we only loaded the paths on the server. And I'll collapse this for you. And then we set a timeout to load the courses on the client after a few seconds. And what was funny was we realized a lot of people looking at the data didn't even need to look at the courses. A lot of them would just directly click on a path and never scroll down on the page. So some of them wouldn't even load courses to begin with. Sweet. Some takeaways. Don't process data you don't immediately need. If a page does have dynamic data, consider maybe not loading it on the server, maybe waiting to load it on the client. Definitely measure. Don't just take this as a truism. If possible, it's really nice to pre-build static pages instead of server rendering them. But of course, the trade-off there is if you do need dynamic data per request, that can be rather difficult to set up. So already we see it's not as simple as just making the page fast. There are different trade-offs you need to understand when developing the page. Cool. Let's move on to a script flow version. We've talked about the server, now let's talk about the client. I don't know how many of you have used jQuery at this point, as it is no longer quite in vogue, but I have seen some sites that use multiple versions of jQuery and quite a few jQuery plugins, and just generically a whole bunch of JavaScript they don't need. And you would be shocked and horrified at how many sites load extra versions of all these random JavaScript libraries, jQuery, Lodash, whatever. Fun fact, the more code your page has, the longer it takes to start up. Little tip there. So if we go to a different page and look at the issues with it, I'm going to disable throttling because I don't want to have to wait. We look at the script flow page and let's filter to just JavaScript here. We see a whole bunch of requests loading on the page. We see that this waterfall here is still going. The waterfall is the list of requests on the page. So I'm going to just quickly select here, click and drag to just look at the stuff in the beginning. Here we go. One of the scripts didn't even download for a while. It's still going. That's funny. Yeah, this is a lot of stuff to load on the page. And none of these requests are taking particularly long. Like jQuery 2 is only taking, what, 1/10 of a second? But if you put them all together, that's a lot of stuff. And if we were to throttle to fast 3G, this page would take even more time to load, which is not great. I forgot to record. There we go. So yeah, would not recommend including a whole bunch of extra JavaScript on your page you don't need. Instead, if you want to look at your performance tab on your dev tools, you can probably audit to see how the performance works when you reload the page. And you can take a guess as to how this page is going to do with performance with all the extra scripts on it. I'm going to wait till it loads. There we go. Loading. All right, here we go. So we see in the top area, which shows us when the requests start, we have all these scripts that are taking up time. And then at the bottom right, we see those events that I'd mentioned, DOM content loaded, the old one, first contentful paint and first paint, which happen after, what, 15 seconds here because we're throttling to 3G. That's quite slow. And I'll show you the code for this page too. If we go to script float, it's got all these scripts in the head of the document, jQuery and Slick and all this random stuff. If we were to say, figure out how to write a version of this page without all these scripts, where we just completely get rid of the head, what a world. And then we were to load that page as well, we see it's quite a bit faster to load than the original one. If we throttle back to fast 3G again and do our own performance, start profiling and reload page, still not going to be super fast because we're throttling our network connection. But hopefully, oh, there we go. It loaded in under 10 seconds. Yeah, in about 10 seconds instead of 15. So that's a 1/3% performance improvement, which is pretty great. Yay. In conclusion, even with network throttling, it's super duper important to not load scripts you don't need. Mobile and low bandwidth users are particularly hurt by them. There are a few strategies you can do to fix this. For starters, there's a reason why script tags often go at the end of the body. It's because the DOM, or document object model, won't render while a script is running and parsing. So if a script is blocking your JavaScript or blocking your HTML from running, and you've got a lot of it, then your page might take longer. This is why we use the async and defer attributes on scripts and put them at the end of the body. Many of us don't have any access to this stuff because we use a framework like, say, Next or Create React App that just do this all for us. Which brings me to another topic. If you rely on some sort of big library in your code, consider async importing it. This is a relatively new syntax in JavaScript that takes in a file or module path and returns a promise for its contents, which, if you're using a framework that involves something like Webpack, can intelligently load it later on when you need it. As a code example, let's say you're using this fuse library. I don't know what the library does, but I've been told it's a rather large one. If you want, you can make a function that, after importing fuse in the body of the document, uses this library to, say, search for a text. Or you can wait until the function is called to asynchronously import fuse and then use fuse. So the advantage of the before version is that everything is a little simpler and it's always there. But the advantage of the after version is that your page won't wait to load fuse until it's needed. Some frameworks will even intelligently preload these async imports for you, which is really nifty. So in recap here, don't load things you don't need, and try to lazy load things if you don't need them yet. And we're going to talk a little bit more about that lazy loading stuff, specifically in the world of React. We had another problem we shipped to the catalog page, which was component bloat. Why does it take so long for the page to finish rendering? Now, if you load a giant HTML page and the browser takes a while to render it, that's going to be a pain for you. If the browser has to render more HTML DOM elements, it's going to take longer to render the page, especially if it's a mobile browser where your teeny little phone is not going to be able to render something as quickly as a laptop. So it's a good idea to try to limit the number of elements on the page. Try to wait to render complex areas until maybe you need them later. Maybe don't render them at all until the user renders or controls to them. I'm going to show you another page. This one is the component bloat page. You might have picked up by now we're going in order and we're 3/4 of the way through the talk. Almost. So this component has a lot of dependencies. It has this virtualized list, which I've been too lazy to set up properly. It's weirdly scrolling. It's got syntax highlighting. It's got randomly generated GUIDs. It's so slow that you can see it actually slows down the page. The page has this little loading spinner for a bit, which is quite unfortunate. And if you look at the performance profile for the page, not even throttling it, just no throttling, just looking at the performance regularly. Come on, browser. There we go. Let's select just the page itself. How do I do this? Come on, there we go. All right, we see that the JS file that's loaded for the component bloat page, appropriately named component bloat.js, is huge. It takes, what is it, from barely over 0 milliseconds to almost 750. It takes 606 milliseconds to load this big old JS file. And that's with no throttling. Can you imagine what a crappy 3G connection would do for that? It'd take forever to load. So if you're in a situation like this, where you have this giant library, React itself has really nice integrations that people have written for lazy loading. Frameworks like Next.js often come with something like a dynamic or a lazy component. If you don't have something like Next, the React docs do recommend falling back to a library called loadable components, which is what we use for our non-Next.js code in Codecademy. Similar to before, you might use an import statement for them. So again, similar to the fuse example, instead of importing something directly in your JavaScript file, you might create up a dynamic import where this hello variable is used like a React component, but the framework knows to magically only wait to load until you actually need it. So now if we look at the version of component bloat fixed, we see a nice little faster spinner there, and the component waits to load. That little pause there was the component loading in until after we need it. I'm going to start profiling and reload the page. Whoa, that was much faster. Now, if we look at specifically the part we need, we see component bloat.js is 200 milliseconds instead of 600 milliseconds to download. So yay, great, that's much faster. Skip through the slides. One last problem that I believe I still have enough time to talk to you about is DDoS, or a dedicated denial of service. It's nothing to do with performance. It's just a real bad thing we did to ourselves and actually caused some downtime for back in the day. So I want to bring it up. It's also kind of funny and sad. If you've learned React in the last few years, you've probably heard people complaining about switching to hooks. If you learned React before that, you've probably complained about switching to hooks. Hooks are awesome. I love hooks. It's my way of life for UI code, but they can be kind of complex. They can be difficult to use. And even before hooks, class components in React were also kind of complex and hard to use at times. Different lifecycle methods, like component did mount or did update. This is the nature of UI code. UI can be complex and hard to wrangle. So of course, the code that messes around with it sometimes suffers from the same things. But there's no way to get around UI complexity, which means there's probably no way really around to get the occasional bug in production. And this was the symptom of a bug that we had, where we accidentally set up code improperly so that it would constantly send a request over and over and over again. I'll show you the before and after real quick. The before was that we would always set a timeout to fetch, let's say in here is the user. In actuality, I think it was course data. Whenever the user changes, and then eventually we'll set the user once that response finishes. This code is buggy because it will always set a new request for the user whenever the user updates. What we should have done, and eventually did fix for, was that if there is no user, then we set the timeout for a request so that the user updates and then the effect runs again. We won't send a new request. If you haven't used React hooks before, A, highly recommend. They're pretty great. B, the general summary of what this code is doing is on the left, you can see a simple one where this effect function here that contains all this stuff runs whenever the list of things in this array changes, which in this case is running whenever the user changes. On the right, we have the same thing, but we won't run the body if the user already exists. So I'm actually going to show you an example of this. If you look in the code, if you look on the page, there doesn't really seem to be that much of a problem. It actually looks like it's working pretty great. But then if you open your dev tools and go to the network tab, you can see all these scripts requests coming in, all these requests, which is not great. So what was it? Self DDoS index, self DDoS index fixed. Yeah, the situation was pretty easy to avoid once we knew what it was, but until then it was kind of annoying. And by kind of annoying, I mean it took down some of our servers and caused extremely low load speeds for many users. But once we fixed it, amazing, only one request per page. So a few tips, check yourself before you wreck yourself. Whenever you change the loading behavior on a page, especially if you're introducing something with, say, caching or network optimizations, definitely look at the performance in the network tab results from the dev tools. Make sure that you don't have anything fishy going on. Even if the page performance looks good, you never really know what's happening behind the scenes. I've constantly been surprised by random stuff firing off requests 2 or 3 extra times I didn't need it to. Very annoying. In our case, you could see a pretty indicative graph of what happened. The bad deploy, which I'll admit, it was me. I made this bug. Sorry if this hurt you. It came out at about 3:40 or 3:50 p.m. I did not write this graph, otherwise I would have spelled our company name right. You can see that the DDoS started in severity to increase until around 530 or 540, at which point we reverted the code. And although it went down, because the people who already loaded the page still had the page up in many cases, we were still spamming ourselves for this particular endpoint. So we had to deploy a second fix to cache the results on that endpoint, at which point the DDoS was no longer severely impacting our servers. That was about 620 or so. So over the course of 2 to 3 hours, our site got real slow and then got fixed again, thanks to the efforts of our on-call team. Lastly, I want to talk a little bit about some cultural takeaways. We've talked about server bloat, script bloat, component bloat, and DDoSing. This all sounds horrible. How do we minimize the chance of it happening to us? In general, try to keep performance in mind early. If you're creating or updating a page, think of where the data flows from. How difficult is it for the page to request that data? Is it going to be required for the first view? Is it something you only need later? I'd also definitely recommend having these conversations early in the design phase, not just in the implementation phase once the designs are solidified. You really don't want to be in the situation where you have to tell someone, sorry, you made these designs and they're physically impossible. You have to completely rework them after they spent a whole bunch of time with them. It's a miserable situation for everyone. Definitely architect well and don't worry small, by which I mean try not to over-optimize on the small things that don't matter. Unless you demonstrate an operation really needs to be optimized, probably don't. Donald Knuth famously was quoted, and in his later words, partially misquoted by saying premature optimization is the root of all evil. He also likes to say, yet we should not pass up our opportunities in that critical 3%. So if there's something like script load or page bloats that's causing your performance to drop, definitely fix that. But most of the time, the difference between, say, a for loop or an array for each or some other iteration method probably won't matter if your collection, say, only has a few items. I highly recommend not assuming, as our math teachers used to say, it makes an ass out of you and me. I've been constantly surprised by performance learnings. I would think that the static server response would be better for an endpoint, and turns out it wasn't. Or I thought that we should render something on the client, and then the server was a better option. Definitely test your major assumptions before committing to them in your architectures. I also would not recommend making any assumptions about your users. They have a lot of different devices and networks. People have really great laptops and bad connections, really bad connections with great computers, all sorts of random situations out in the wild. This didn't happen to me, but I've heard of it happening, where you might take 10, 15 seconds to load a page for almost everyone in a particular country because you didn't optimize well for, say, their DNF server or for their particular type of usage. No one wants to be in that situation. Lastly, I cannot recommend enough the idea of a blameless postmortem. The worst thing you can do when something breaks is to try to figure out who broke it and point your finger at them. That just causes people to not want to admit when they break things and then not want to do anything that could break anything. When something fails, you should investigate why. Don't just fix and forget. Figure out actually what was the root cause that caused the failure, that allowed it to happen. These things are almost always systemic. They're almost never personal. It's not that someone shipped a thing that broke a page. It's that our systems allowed that page breakage to happen, that the tests, the static analysis didn't prevent this type of thing when they should have. There's a really great methodology that I highly recommend. There's a Wikipedia article for it. 5 whys. Arbitrarily, keep asking why, say, 5 or more times whenever a problem happens. Don't just be satisfied when someone says, oh, the code broke. Why did the code break? Well, why was the code allowed to break? Well, why didn't the test catch this? Well, why are we writing bad tests? You'll be surprised at how deep and insightful the findings are afterwards. Last little section here, some resources for you. Debugging is a really fun thing, highly recommend it. The Chrome DevTools have really good sections on network and performance and speed, all the stuff we covered today and much more. WebDev, Docs by Google as well. It's this dedicated site to making your website go fast itself. Really great stuff. I'm skipping through these because the slides are all on my website. You can copy them later. MDN has a section on performance, which is pretty good. And React also has a section on optimizing performance. which gives you a nice React-specific overview. Speaking of React-specific, React.js, surprising, they have great React docs. Codecademy also has React docs. A little plug from my company there, would recommend. I think we're pretty good at teaching. Anyway, let's recap. We talked about the catalog, a typical situation for a production app. We talked about a few server components, site components issues that we had. We talked about some cultural takeaways that you can use to help prevent yourself from getting these issues. And we listed some resources that you can use to learn more. Super. Thank you for listening to me. I'm Josh Goldberg. My Twitter and website are both Joshua K. Goldberg. That's the end of my presentation. Cheers.
Thank you so much, Josh. That was truly so engaging. I have to say, you are an amazing speaker. Where'd you go? Come back, please.
Sorry, and thank you.
You are a very, very engaging speaker. That was very interesting and a great talk. Thank you so much for that. I'm very excited. Oh my God, and you finished perfectly on time, like absolutely perfectly. Thank you so much for that. I'm very excited to speak to you more at the Q&A. So everybody, please get your questions for Josh ready ahead of time, if possible. If not, we'll just see where the Q&A takes us. So Josh, thanks again, and I'll see you soon. So moving on to our next speaker, I would like to introduce you to Clement Hoang. Clement is a current tech lead at Credit Karma, specializing in front-end and GraphQL, and he previously interned on the React team at Facebook, shipping JSX fragments. He previously founded a contracting company called zoohouse.io. This will be his first time speaking at a conference, but he has spoken done company talks before. So Clement's talk today is about how Credit Karma shipped a COVID-19 relief center in a week. And let's all say hello. Hello.
Hi, everyone. Thanks for having me today, and thanks for the introduction, Chrissy.
Thank you so much for being here. How do you feel?
A little bit nervous, but we'll see how it goes.
I'm sure you'll do just fine. I know how much work everyone put into their speeches, so I have no doubt it's going to go amazingly. So I'm not going to stay here and hang around for too long. So oh, there it is. So I'll pull up your presentation now, and I'll see you after your talk. So good luck.
Thank you. All right, so I'm a software engineer at Credit Karma, and today I'll be talking about how Credit Karma shipped Project Relief in a week. And I'm sure some of you might have some questions at this point. What is Credit Karma? What is Project Relief? And who am I really? I'll be going over these briefly, so without any further ado, let's jump right in. By the way, I posted my slides on my website, clemmy.ninja/react-geekle2021, so you can follow along. So let's start with who I am. During the day, I'm a software engineer employed by Credit Karma. I have a primary focus on product engineering and building wonderful experiences using React and GraphQL. And I also dabble with some of the platform teams from time to time. And here's a fun fact about me. I'm also the CEO, that is, the Chief Eating Officer. You'll usually find me in the kitchen snacking on Hello Panda after I'm tired of playing whack-a-mole with the CSS. And here's a picture of me bringing my favorite fruit to the office. For those of you who know what this is, give me a fire emoji in the live comments. And for those of you who don't know, this is durian, and it's not only one of the world's stinkiest delicacies, but it's also one of the most divisive of them. You either love it or you hate it, and if you haven't tried it before, I definitely recommend trying it out and choosing your camp. You might just discover your new favorite fruit. By the way, I'm also the guy who brought fragments to React. Yes, I'm full of controversy, I know. But that's enough about me. Let's talk about Credit Karma. In a nutshell, Credit Karma is a company whose mission is to empower each and every one of our members with the knowledge, tips, and tools they need to turn their financial dreams into reality. We have over 100 million members who depend on our free product offerings. These include things like credit reports, scores and monitoring, like mortgage refinancing calculators, personalized offers, checkings and savings accounts, tax filing, just to name some of the things that Credit Karma has to offer. And one of our most recent offerings was Project Relief. In March 2020, the World Health Organization officially declared COVID-19 to be a pandemic. This financially affected a lot of people. Many people experienced job loss, they were furloughed, or they had their hours reduced. And many of these people actually barely stayed afloat, and some even started to slip into debt. It wouldn't be long before many people ran out of money or had to dig into their retirement funds. This meant that time was of the essence. People needed help, and they needed it quickly. So Project Relief was ideated to help members navigate their current crisis financially. For our first iteration, we wanted to be able to connect our members with benefits that they're eligible for based on their financial situations. There were hundreds of benefits available online, yet many consumers felt overwhelmed by the amount of information out there and actually found it very difficult to understand what governments and private benefits they were eligible for. And we were actually able to build and deploy our first iteration of Project Relief in only a week, which was a huge success for us. With great velocity, we were able to ship a personalized experience that helped connect our members to the resources that they needed to increase their cash flow and release some of their financial stress. However, 1 year ago, this kind of velocity was actually not possible at Credit Karma. To build such a rich experience that supports web, Android, and iOS natively would take much longer than just a week of work. What really enabled this was a platform that we built internally to create new user experiences. Very unfortunately, it's named Containers. But looking past that, Containers leverages React and GraphQL to make it extremely easy for developers to create new experiences. So in this talk, first I'll run through some of the problems that we faced in the company in Credit Karma that led to the inception of Containers. Then I'll describe its architecture and show how it kind of looks in practice. And finally, I will be sharing the lessons that we learned after using Containers in production for a year. So let's start off with some history of Containers. What I'll do here is run through an engineering thought experiment and talk about some of the problems that we might run into and some of their common solutions. So we start off with this very familiar scenario. A product manager walks into the room with a PRD. Whew, it's an exciting time. And they ask for the following feature. Can we add a new page that shows members the benefits that they're eligible for? And attached to a PRD is usually a very beautiful design made in a proper design tool like Figma. As for me, I create this wonderful piece with Microsoft Paint. Maybe I should look into being a designer, eh? But jokes aside, you can see that from this low fidelity design, we're creating a new page that displays the benefits that a member is eligible for. We mocked 3 of them here, each showing the following: the name of the benefit, the description of the benefit, the expiry date of this benefit, and also a link to this benefit. So the next question to engineers are, how should we go about implementing this? And that's simple. From my first impression might be, let's just add a new GraphQL service or a module. And as you can see from this diagram, the benefits GraphQL service is something that we're creating and adding. It will connect to our domain services where it can fetch benefits, and then they will be rendered by our web, iOS, and Android clients. And diving a bit deeper into the GraphQL layer, we create this benefit type that contains the data fields that we need in order to render a benefit on the page. So this type will contain a benefit ID, its name, a description, a URL, expiry date, and a type. When the clients make a GraphQL query for this benefits data, they'll receive an array of these benefit types. And next we have, so what happens exactly once we have a benefit type? On the clients, let's take a look at web, for example. Number one, basically, the next part is once the client receives a list of these benefits, sorry about that, my slides kind of got wonky here, but what does it do with this data? This is known as the application logic, and in our web client, we implement this with React. So diving right in, we define a benefits card React component, which takes our query data and renders a list of benefit cards. So as you can see, there's a lot of custom logic in here to transform the raw data from the benefit object into what the user sees. So for example, we have a name that has a fallback using the benefit type. We have an expiry date, which has a formatter function. And we also have a default URL for the anchor. And then it's also hard-coded with a text of go to benefit page. And the key point to note here is that the clients are the ultimate arbiters of what the UI looks like. Application logic is written on the client side to transform the raw data from the queries into something that is presentable to the users. And as I mentioned before, this is what like the React client might look like, the web client where we write this application logic. And this presentation logic will also have to be duplicated and re-implemented in iOS and the Android code bases as well. And to quickly recap this data flow, a client first makes a request to the benefits GraphQL service to retrieve a list of benefits. And then the GraphQL service will then talk to the appropriate domain services to get the data that it needs. Then the benefits GraphQL service will then transform the data to conform with the benefit schema and respond with a list of benefit to the client. Finally, the client will execute application logic to transform the benefit type into pixels to render on the screen. And so we have this issue of duplicated application logic in each of the clients, as it needs to be repeated on web, iOS, and Android. Imagine needing to fix a bug or to change some functionality in the presentation layer. This code change will need to be repeated in 3 different code bases and have to go through 3 different like a release process for each one of these platforms individually. This can have a compounding effect. More time is taken to implement this. It'll take more time to ramp the experience. And you're also 3 times more likely to make bugs because you're writing the same code 3 times. And to really illustrate this point, let's consider an example where we're actually changing how the date is formatted. In your React code base, you'll just need to go into the getExpiryDate text function and update it. And then you'll need to repeat the same thing in your Android code base and the iOS code base as well. And hopefully, you didn't make a bug in any of these changes. And to make it even worse, not every user updates the apps on their devices right away. So it might even take some more time before your end users can even receive the updated builds with the date change or the bug fix. And this could potentially take months before a user updates their apps. So to solve this issue of duplicated application logic, we introduced the concept of a view-centric schema as opposed to the previous data-centric schema. This is also known as backend-driven UI. And in this new view-centric schema, we define a type benefit card. And the fields in this type define how the data should be rendered instead of just serving the raw data itself. So instead of having fields like the benefit's name, description, expiry date, we replace them with fields that correspond more directly to the final presentation, more generic types, such as primary text, which will contain the benefit name, secondary text, which will contain the benefit's description, and description, which will contain the expiry date, and an anchor type, which will contain both the anchor text and the link. So to really drive my point about view-centric schemas, let's take an example with the expiry date. We first take the data-centric expiry date field, and then we combine it with a text formatting application logic. And so you'll get this new view-centric schema where your description field is a string, and the logic to transform the expiry date and like formatting to a string will be defined inside your benefit card resolver to power the description field. And we also do the same for all the other fields, the primary text field, description, secondary text, anchor. We move all this application logic from the clients into the benefit card resolver, and this is the result, a benefit card schema that matches one-to-one with the benefit card renderer in React and the different platforms. And a view-centric schema design comes with one main advantage. That is, the application logic is centralized in the GraphQL layer. This means that the clients become simple renderers. There is now a clear separation of concern between the rendering logic and the application logic. It's easy to identify where bugs are located because rendering bugs will be isolated to the simple renderer clients, and then the application logic bugs will be isolated to the GraphQL layer. So you always kind of know where to look. There's also reduced code duplication. There's no more need to write the same application logic in all 3 platforms. There's now going to be a single source of truth for this logic in the GraphQL layer. This saves times and potential bugs. And finally, updates. With a view-centric approach, we can make certain updates to native without like cutting new native builds. This means that you won't need to cut a new build for things like copy changes, for experimentation, as long as they're within the constraints of the view-centric schema that you defined earlier. In this benefit example that I showed, this is limited to text, but we can see more powerful implications of this later. And this isn't to say that there are no cons of view-centric schemas. There are some, such as having lower resilience to changing UI requirements, and it won't really support more complex use cases. However, these trade-offs are worth it to us, and instead we kind of use extension points and escape hatches when needed. So everything is fine and dandy now in schema land, right? I mean, we have a reasonably well-designed benefits page that's view-centric. So let's zoom out of our system a little bit and take a look at the bigger picture. Across the company, we have many different GraphQL microservices. that use many different custom view-centric GraphQL types. For example, we mentioned a benefit card in our newly designed benefits GraphQL service. But other services at a company, such as the dashboard service and the offer service, might define their own card types, which closely resemble a benefit card, but with some slight differences. So as you can see here, custom types being returned in each place. And correspondingly, our clients define across the different pages and platforms will implement slightly different renderers for each one of these slightly different types. And what this results in is chaos. Here's a real-life problem that we actually had at Credit Karma. In 5 of our pages, we had 5 different credit card account components, which were slightly different. Let's take a look at how they look. That's number 1, 2, 3, 4, and 5. Can you spot the differences? This isn't limited to just the credit card account components either. We also had this issue with back buttons, modos, tooltips, and all sorts of common components. So how do we solve this? We share the view-centric GraphQL types, and we use a common rendering library. We can unify all these fragmented types across the organization and have a standard set of view-centric types that are applicable to a wide variety of use cases. And then we create a shared rendering library that is used by all the different pages to handle these different view-centric types. This rendering library will then be implemented in React, in iOS, and Android to handle all the different platforms. And so to recap the 2 main issues I described that we faced at Credit Karma that led to containers, one of them is having duplicated application logic in each client, and we aim to solve this via a more view-centric GraphQL schema design. The second one is the issue of inconsistent design due to fragmented GraphQL types and renderers across the organization, which we aim to solve by sharing types and renderers. And in addition to these 2 primary issues, we also have some other requirements that we want to factor in when building like new infrastructure and products. Things like experiments, metrics, maintainability, scalability, and most importantly, velocity. We need a system that will support all of this. And this is where Credit Karma Containers comes in. Containers takes the lessons from code duplication and design consistency problems and combines them with some other parts to meet our product needs at Credit Karma. So I took this definition directly from our internal documentation. 1, it's a platform for building personalized product experiences faster. And secondly, it's not related at all to Docker containers, which I find pretty hilarious that this needs to be part of the definition. If someone has any experience with changing internal nomenclature at a company after it's widely adopted, please send me some tips in the chat. I'd love to know. The anatomy of containers consists of 3 main components: a component renderer, a view orchestrator, and a data gateway. The first is a component renderer, which handles rendering GraphQL types that implement our company's design language. These renderers are available as libraries in both web and native. The next is the view orchestrator. This is a service that takes declarative configuration files, which specify sections and pages, as well as many other dependencies, and it outputs GraphQL types that our component renderer can understand. And finally, we have the data gateway. This service serves data points about a user that can be used by the view orchestrator. And then these can be used along with a template and transformations needed to turn them into view-centric fields. Or they can be used with eligibility rules on the view orchestrator sections to determine whether a user can see a specific section or not. And used together, these 3 components really gets us the benefit of fast product cycles, which is exactly what we did for Project Relief. And to illustrate like putting together the component renderer, the view orchestrator, and the data gateway, we get an architecture that looks like the following. So let's walk through a request flow when a member interacts with a containers-powered page. So first, we load up a specific surface on our phone or our laptop. The front-end client in React will then make a GraphQL query to get a section to show on that specific page. Then in the GraphQL resolver, there will be a view orchestrator client, which will then make an RPC call to the view orchestrator to fetch the sections to display. And a lot of magic happens in this view orchestrator. In the view orchestrator, we get the appropriate data points from the data gateway. the appropriate templates from the templates database and compile this down into a JSON representation of the standard GraphQL types. This will then be returned to the front-end client, where the component renderer can render the standard GraphQL types, taking care of the spacing and the layout. And Credit Karma's design system consists of all the components that you would need to build a full-fledged experience. Think things like buttons, cards, tables, and form inputs. All of these will have their own GraphQL types, and a set of these types will be passed from the component renderer, will be passed into the component renderer, which can take care of the arrangement and the spacing. And one cool thing about this is that it's a living design system. That means that this ecosystem is constantly evolving to support more and more use cases. The idea is that we invest some additional initial effort once we do something, and this will make it become a solved problem that others can reuse and use in their experiences. So something like memoization. Now, recall from the architecture diagram that the view orchestrator had an arrow that pointed to a database of templates. Here's an example of a basic template that renders something similar to the benefit card that we showed earlier in the presentation. Its type is a fabric article card, and it declares a title, a subtitle, description, and button fields. The parts surrounded by the curly braces are injected with data points from the data gateway, and transforms can also be run on this data to add some view-centric flavor. And now this will be processed by the view orchestrator, and out comes a GraphQL response. As you can see, we have our title, our subtitle, and a button in a format that's conformant with the GraphQL schema that we defined, and something that the component renderer understands. Additionally, the view orchestrator also automatically adds tracking metadata when it's compiling the template into GraphQL output. This allows us to collect a bunch of behavioral metrics that we might be interested in for experimentation for free. So taking the view orchestrator template that we wrote above, we eventually get a card that looks like the following, rendered by the component renderer. Pretty neat, huh? But for all of this to actually happen, we need to do a bit of plumbing work in the view orchestrator. So let's take a look at what the YAML configuration for the section in the previous slide looks like. It declares several key parts. A unique portal ID. This will be used to uniquely identify, a unique section ID. This will be used to uniquely identify the section in the page. A template ID. This binds a specific template from the template database to a specific view in the view orchestrator section. The view orchestrator will then take this template and its required data points and process it into a standard GraphQL type, which can be handled by the component renderer. Finally, this section includes the tracking metadata, which will be consumed by the component renderer to fire tracking events. And finally, we have the section's eligibility rules. This is really the bread and butter of what a section looks like. It uses our internal eligibility language as well as member data points in the data gateway to determine whether or not a user should see a specific section or not. And to tie together, the second entity of the view orchestrator is the idea of this page. Does this look familiar? It's the beautiful benefits page, which I wireframed earlier. A page can be thought of as a composition of sections. And in Project Relief, we actually have hundreds of sections on a single page. Notice how we can arrange the sections in a page configuration depending on the member's eligibility for different sections on the page. Depending on what sections are put in this configuration and what the eligibilities are like for different members can actually see significantly different pages. And in this specific page configuration, I defined 4 sections. As you can see, there's 1 section for the header and 3 benefit card sections. And that gets basically, if a user was eligible for all 4 of these sections, they would see what I show on the left. So putting it all together, here are the different steps needed to create a new page at Credit Karma. We create data points in the data gateway, if needed. Then we create templates in the view for the view orchestrators to consume, if needed. And then we configure sections in the view orchestrator to bind templates and add eligibility rules. And finally, We configure pages in the view orchestrator to compose sections. And that's it. Your page will be served somewhere once you push the launch button. And ta-da, leveraging the containers ecosystem, we spun up a bunch of different pages, hundreds of sections, and here is the end result, project relief in less than a week. So we have all three platforms supported natively with a backend-driven UI. And it has now been over a year since the inception of containers, and we extensively used it in production for many experiments and projects, including project relief. We learned a lot of things. The thing that went well with containers was that it was able to solve the problems that we designed to solve. Phew. The time that it took for us to ship products improved greatly. By being configuration-driven and taking away the developer concern for UI logic, we were able to reduce the time it took to transform an idea into production. There was less time spent trying to play whack-a-mole on UI bugs and reinventing the wheel. We were also able to solve our design consistency problem. Due to our shared GraphQL types and the common component renderer, presentation logic for components and spacing is no longer really a concern of the product engineers, but instead they were solely focused on by a focused design and engineering team. And additionally, new components were contributed back into the design system, which made it very easy to reuse components from any existing experience. And finally, data-driven design was encouraged. With containers, we were able to have this short product iteration loop, and behavioral tracking came for free as well. With this combination, teams were able to make decisions like, is there high engagement on this page? Are there members dropping off in this funnel? Is there some benefit that users are using less than others? Does putting this card here cannibalize from another card? So we were able to learn from and iterate really quickly from all these data and insights. However, this one-year journey was not smooth sailing all the way. We learned many important lessons. The first one is that documentation is of paramount importance. This is especially true when we design a new paradigm for developer workflow. Without good documentation, there will be a much lower adoption rate for technology, and bad practices can and will form. Work closely with product partners who will pioneer your tech and ask for early feedback. Another thing are extension points. These are necessary. There are going to be a million edge cases that you won't account for, and you can't expect to solve every problem with a library that you build. For example, what if we want to do custom components? What if we wanted to integrate with third-party widgets, support for interactive experiences, support for progressively migrating to containers? Without extension points and escape hatches, many teams will find it hard to justify migrating to your tools. The friction will just be too high. Give your developers the ability to break the rules when it makes sense. And containers was initially built to serve read-only experiences, and it did that quite well. On the server side, we can define what we want to render. But then how do we exactly define client-side interactions, form submissions, things of this nature? In the end, we went with a pub/sub model for components, but it actually ends up being a little bit complex even for a fairly simple task, and we're still actively working on solving this problem. Build tools and empower your quality engineers to do their job. Give them ways to mock data points, give them ways to simulate different sections, eligibilities in a test environment. One of the initial issues that we had early on was actually a lack of quality engineering tools. This made it really hard for our quality engineers to exhaustively test any pages built with containers, which increased our risk and our uncertainty. And finally, at Credit Karma, we learned that we shifted the organization so that the design team would work extremely closely with the containers engineering team. This really helped to facilitate communication between two extremely coupled teams. The design language should be agreed upon by both teams with a strong mutual understanding of the current component support level. And finally, there are still some problems with containers that need to be solved. As we add more and more components into our design system, the component renderer grows larger and larger in size. And this is pretty problematic, especially in the web world, because a large bundle size means that the initial load of your page will take longer. Perhaps a solution would be to dynamically load a page, to dynamically load renderers only when needed. Another issue was caching, and this is kind of due to the view-centric nature of containers. When navigating between different pages, a new GraphQL request will need to be made to refetch the sections for a particular page. Otherwise, there's no guarantee that some data points about a user has changed, and thus their eligibility has changed for specific sections, and then the sections to render on that page will also need to be different as well. And finally, as I mentioned before, Android and iOS members may be on outdated app versions, which won't support newer GraphQL types. And so even though the component renderer is designed to fail gracefully, when we define templates, we will also need to take these different versions into account. Like, for example, if we have some new button type that we want to render, and this isn't supported by an outdated version of the Android version, we can't just be like, oh, let's just hide a button and miss a button. We'll need to take these different versions into account and render some sort of fallback UI. And this kind of litters the templates with fallbacks and version checks. And that concludes my presentation. Thank you for listening. Go build something cool. And as mentioned before, my slides can be found on my website at climbing.ninja/ReactGeekle2021. And I finished way earlier than I expected because I spoke way too fast.
It happens. It happens. I have to say, the comments in the comments section are absolutely blowing up. People loved your presentation. A lot of them could relate to basically everything you said. There were so many comments on the animations and things like that. Wow, what a great speaker. Thank you. So I think you did absolutely amazing. We can give it maybe a minute or two since we still have 10 minutes. To the audience, I'll say, if you have any questions that you want to ask now before the Q&A, this is your chance. We have 10 minutes to fill up, basically. If not, we can go for a break. But while people come up with questions, speaking too fast, I was listening and I could keep up, but I was thinking like, wow, we still have 10 minutes and it sounds like it's coming to a close, but I wasn't sure. And here we are. So I have to say that truly, it's not often that this many people comment on how happy they are. Everyone, like I said, if you want to ask your questions, ask them now before I let Clement go. Anyway, well, hopefully the questions come in. So where are you based right now?
So I'm living in San Francisco in California right now.
Wonderful. I've been there on a holiday, and I have to say, it was, I hope I don't offend anyone by saying this, but when I was there, everyone hyped it up so much, and you see it in the movies and things like that, and it looks so beautiful. And the 3 days that I was there, it rained every single day. It was miserable. It was absolutely miserable. And the whole time I was like, what's the hype? Why do people like it so much? But it is a beautiful city, gorgeous. Sadly, I never got to go to Alcatraz, which was the high point of my trip because we just didn't get a chance to go, but that would have been fun. So hopefully next time I'm in San Francisco. Oh, someone's asking, well, we have a serious question, but someone's asking, what are the benefits of San Francisco? Tell me some good things.
The benefits of San Francisco, well, I would say San Francisco is definitely usually kind of known for its weather. At least it doesn't.
That's what they say, apparently.
I feel like in the past we've been under a drought for a really long time, so there's actually no rain for years. And now I guess you just came at a really bad time where it happened to rain for 3 days.
Yeah, it was Christmas time, by the way. Maybe that affects it.
But that's actually so that's at least one selling point. I really enjoy sweater weather. So for me, I like wearing my many layers and just going outside. And then if I'm getting a little bit cold, just take out a sweater, walk into the sun. And then if it's getting too hot, you just walk into the shade. San Francisco is kind of known for its microclimate culture. So wherever you cross the street and just gets like 20 degrees colder or something.
Oh, wow. That's a big difference. So now the questions are popping up. So am I wrong? But What do you have to say to this?
So, well, when I made this point, I was gonna say I'm the chief eating officer of Credit Karma. You will always find me in the kitchen.
That's amazing. That is, I think that's the best person to be in a company, to be the one like with the snacks, always knowing who to find if you're hungry. Amazing. Okay, so here's a serious question. If we wanted to introduce a container system that you described to our team from scratch, would you have any advice on where to start?
Yeah. So first of all, I would really urge you to evaluate like what are the needs of what are the problems that you're trying to solve? What are the problems that you're facing in your team currently? Is the issue this duplicated application logic, right? And is the issue this idea of having very fragmented designs and types? And if this is the case, then maybe you do want to look into like some system similar to containers. And I will kind of reference back to my slides where I described the three main parts of containers. One specific thing that I would one big point of containers is the view-centric part of it, the idea of backend driven UI. So, define your renderers on the client side, define what those renderers can render on the backend, and just build it out using technologies that you're comfortable with. And in the case at Credit Karma, we had a lot of expertise in React for the front end side, and we also had a lot of expertise on GraphQL for the backend side. So that's kind of how the technology gravitate towards those.
Great answer. Here's another question, which is, can containers be implemented without GraphQL?
And so this kind of follows along with what I mentioned earlier, right? Use the technology that you're comfortable with, and containers can definitely be implemented without GraphQL. So actually, I guess for example, even something like GraphQL can be implemented without GraphQL. For example, you can have some REST endpoint that specifically queries for different fields that you want, although that would be a lot more work. I think GraphQL definitely makes it easier, but yes, if you just have endpoints to define what are the shapes that your renders can handle, either through some post some normal REST endpoint, and then just have clients that will take those types that it returns back and render those, that should be enough to implement something similar.
Amazing. We still have a couple of minutes, so let's do a couple more questions. So how would you pitch containers to a less technical PM?
Oh, that's a good question. And the way that we pitch containers to our PMs at Credit Karma was, it'll help ship things faster. It'll make things more reusable. It'll make it easier to have data-driven design. So
just really selling it.
I think that's the idea of it, and that's basically what containers was created to do. It was created in order to make developing similar experiences much easier. I think with complex experiences, containers, it'll be hard to make containers to support those use cases. But for very common tasks, like you want to render a page with different sections on it, with different cards, and they're composed of some standard design language that you reuse over and over again in the company, this is a problem that's already solved, and you don't need to solve this problem over and over again, which leads to a high fixed cost every time you want to solve this problem. And so containers, this is where containers comes in. You can reuse solutions that you built before and just really quickly ship things that you have kind of shipped in the past.
And let's do one last question before the Q&A. So if you do send in a question, we will cover it in the Q&A, but let's do the last one for now. So is container code designed to be written by developers or other teams?
Okay, so let's see. Containers is designed to be written by developers first, because it is configuration that's stored on GitHub. But what we're trying to transition to is being able to make it a bit more hands-off in terms of for developers. So there is some work being done internally right now to, for example, create drag and drop UIs that would the core of containers was, I mentioned in the view orchestrator, we had configuration files, right? So these configurations are just things like, are users eligible to see this section? What should this section look like? And in general, like section templates can be kind of built with drag and drop UI. There's like lots of products out there that kind of try to solve this with what you see is what you get editors. And then there's the idea of eligibility tools, which is, can the user see this section? So these can also be done via like some kind of like UI template builder thing. And then finally, we can have some kind of tool to compose all these different sections that we create onto one specific page. And this is all something that can be done through an intuitive tool. It's basically the idea of, instead of writing it in a config file, you have a tool to, write your config in an easier way. And so even less technical people can consume this.
Amazing. Right. Okay. So that's it for now then. Thank you so much, but we're not saying goodbye. We'll see you very shortly. So thank you and see you soon.
Sweet. Thanks for having me.
Bye. So before I introduce our next speaker, I would like to do some branding. Right. So this is going to be the last speaker for my moderation block because it's getting late and I've been here for a while, but I have very much enjoyed myself. So last but not least, for my moderation block, let's welcome André Elmoznino Laufer. André is a software developer at Valtech, specializing in front-end, currently consulting for IVDem. He was previously at Goodyear, and then, honestly, I'm not even going to try and butcher the Swedish language by pronouncing this, but I will say he also worked for a Swedish educational broadcasting company and another Swedish public employment service. In his free time, he bakes delicious sourdough bread or teaches kids coding at Coder Dojo Stockholm. He has also previously spoken at 4 other events, so he's a seasoned speaker. And his talk today is titled Converting URPlay into React, a Legacy Rewrite Case Study. So let's get into it.
Hi, everyone. My name is André Elmoznino Laufer, and I'm a software developer at Valtech. I'm here today to talk to you about how we converted URPlay from a legacy Ruby on Rails app into React. Today's agenda, I'll start with the background, why we decided to move to React. I'll share our strategy and the different steps we took in doing this migration. I'll also share some ways of working that were working fine for us. And I'll end with some takeaways and resources that you might find useful. The aim of this talk, of course, I understand that not everybody sits on an old Ruby on Rails app, but I want everybody in general that have legacy apps to get some insights on how we can do this. But also keep in mind that if you do work on a super fancy modern app that is modern today, of course, it won't be modern for all future, and you might need to do some rewrite in the future. So this might leave you more knowledgeable for when it's time to do so. So who am I? I'm a front-end developer doing mostly React and Angular. I might also mention that I'm based in Stockholm, Sweden. I'm also the lead of our front-end craft circle at Valtech Sweden, which means that I arrange lunch lectures and workshops so all of our front-end developers keep up to date with the latest trends in front-end development. And some of the clients I've worked with include UR, which is what I'm talking about today, but also Goodyear Tires and InVidem, which is a Scandinavian business-to-business financial company. And on my free time, I love to bake sourdough breads. I teach kids how to code at Coder Dojo. And I also occasionally talk at meetups. This is me at React.js Meetup Stockholm, pre-COVID, giving a shorter version of this talk. So on to the background. If you're from Sweden, you know what UR is, but I guess most of you aren't from Sweden. It is the Swedish educational broadcasting company and is part of the National Public Service Broadcasting Group. And in essence, they produce and broadcast educational and general knowledge programs. And URPlay is what you see on the right here. You can sort of see it as a Netflix of educational content, mostly videos, but there's also a lot of podcasts. So why did we choose to go to React? In early 2019, the situation was the following. We had a Ruby on Rails monolith that was about 4 or 5 years old. There was a lot of jQuery magic going on. You didn't really know how things happened. There was also a lot of not only IDs, but also CSS class names, not just used for styling, but also for tracking and testing and functionality. So when you just wanted to change the DOM a little bit, or you saw that the class name didn't really make sense, you didn't really know what you broke and for who you broke it. There were, of course, some tests, but the coverage wasn't amazing. And there had also been some staff over during the years. There were a few consultants that came and left, and there wasn't a big focus on collaboration. So chances were that if the person who wrote the code wasn't there anymore, that nobody really knew how it worked. And it turned out that there was actually a bunch of code, at least, that wasn't even used anymore. And at least in Stockholm, back then and still today, it's hard to recruit Ruby on Rails developers. And I mean, we're all here at the React.js Case Study Festival because we love React and we want to work with modern technologies. And one of the major reasons for this migration was that UR decided, instead of having 2 different websites, which they had back then, there was one aimed for schools, which was UR Skola, and one aimed at the general public, which was UR Play. And instead of maintaining 2 different code bases with similar but not exactly the same functionality, it was decided to make it into one platform that would cater to the needs of both user groups. And I might also mention that it wasn't an exact one-to-one rewrite. We did add some new features. We implemented a new visual identity, so some new brand colors and so on. And this is what it looked before the migration. And this is what it looks like today. So it's sort of same, but different, as they say. Pretty similar, but some new functionality as well. Over to the strategy. We started with what I call the setup phase. So there are a few so-called Ruby gems available to have React running in your Ruby on Rails app. One of them being React Rails. And we wanted to make sure that it catered to our needs, that it worked for us. So we made a small proof of concept, made sure that we could use TypeScript and run the test, and that it had a good developer experience, which it had. So then we started writing all of our end-to-end tests. We went for Cypress because it's a great tool. We knew it and we had worked with it before, so that's why we went that way. And we made sure to cover all of the happy flows and the most critical features. Let's say that a user could actually search for programs, that you could play them, that they could browse and so forth. And that way we could feel confident that nothing broke. When we removed some code or made some swapping from Ruby on Rails to React, that everything still worked as expected. Then we did some setup. Of course, we wanted our own TypeScript configuration. We needed to make sure that Jest ran. We had some bubble configuration and so on. But we did that as a team to have a configuration that we were all happy with. Then we had a whiteboarding session, and this picture doesn't really show it that well what we agreed on. It's not so nice, but I just want to prove the point that we had a whiteboarding session and to agree on the project and file structure and to have a common vision and a strategy of how to do this rewrite, which we had. And I mentioned Cypress. In case you haven't used it, this is what it looks like in action. It basically opens up, you can do it, of course, headed or headless. This is headed, then you see the browser in Chrome. You can choose to do it in Firefox or Microsoft Edge as well, if you prefer. And it is also recommended, of course, to run it in different browsers to make sure that all of your users can use your app. And then, of course, you write your Cypress tests. You make sure that you have tests asserting that you can do all the things you want. And we liked to say reactifying. That's our way of saying turning it into React. So the steps are pretty straightforward how to migrate to React with the help of Cypress. First of all, you attach data-sci or data-e2e, whatever you choose, on your HTML markup. And the great thing with Cypress is that it's tech agnostic, so you can use it in Ruby on Rails, you can use it in Angular or React apps, you name it. And then once you have them added, of course, I should also mention that the selector should be unique. So it could be data-e2e product card or search input, for example. Then you write your tests. You make sure that you have coverage for all your features and so on. And then you start swapping out components and do your conversion. And I should also mention, as a bonus tip, to use one of the many great plugins that exist for Cypress. There are a lot of them that are community maintained. There is one called Cypress Acts, which we used. You can run it locally or in your CI/CD pipeline, and it will fail your test and, of course, also your build if you introduce any severe accessibility violation. And this helps you ensure that your site is accessible for everybody. And it was one of the tools that helped us get a 100% score in Google Chrome's Lighthouse audit. So onto the implementation phase. We went component by component, and we made React grow and take over the page by growing up, down, or sideways. And I will illustrate here with an example. This is our search results page. In this case, the user hasn't searched for any particular query or any show. So it's just showing all programs and series. And we started with the little box that I marked with a number 1. It's a drop-down, it's a filter, and it says all education levels. And initially, we would just pass in the props directly from React Rails into our React component. And it would be an array of all the different options, basically. And once that one was in React, we could reuse the same component for the other drop-down filters. So for the one next to it saying all languages and so on. And each of them in turn would get their props from Rails into React. And once we had them all in React, then we could just wrap them in a container, and we would have one single point of entry in our code for the props coming in from Rails into React. And so that way we grew it sideways and to the right. And then we made our component grow to the left and take over that toggle that you see marked with a number 3. And it's a toggle between either showing just programs or entire series. And that, of course, would also get its props from Ruby on Rails, which would say the number of available programs or series. And then finally, we would grow upwards, taking over the header. In this case, because we haven't done any particular query, it just says all programs and series. But if you had searched for, let's say, Pinot, one of our favorite shows, then it would say all results for Pinot. So it would be kind of dynamic. And then, as you can imagine, then all of the top of the page was in React, and then we had it grow downwards as well. And you might wonder, where did we start? Like, where did we choose to turn from from Rails to React? And for us, it was generally when our experienced team, our UX and designers, would have suggestions on improved design and change it, or if it was entirely new features, then instead of doing it in Rails first, then we just implemented it directly in React. And from time to time, there wasn't anything that was prioritized to be turned into or a new design. And in that case, we would go to the pages that we had a lot of React and make React take over more and more of that page. So I've mentioned React Rails a few times, and this is how it looked like. in your Rails template, basically your HTML, you would call React component. And as the first argument, you pass it the name of your component, in this case, hello message. As the second argument, you pass it an object of all of your props, and it can take any amount of props and all JavaScript primitives, like booleans, strings, arrays, you name it. And then the third argument is the options. In this case, we're passing it pre-render true. There are a bunch of different options, but this is one example that we use frequently. Pre-render true makes your component server-side rendered. So it will render once on the server, once it arrives in the client. And if you've done server-side rendering before, you know that there's no window on the server. So you cannot call anything on the window or so there. And therefore, you need to guard for it in your React code. Okay, so our hello message component, this is how it looks like in React. You import React as you always would. We love TypeScript, so we declared our types and interfaces. In this case, we say name is a required string. And then in the end, in the bottom, we declare hello message, and we destruct name, and we display an H1 saying hello name, in this case, hello André. And although this is just a simple example, if this would be something more complex that we needed to assert with Cypress with our end-to-end tests, then we would add a data-E2E, let's say, header on the H1 to still be able to assert that our header works as expected. And of course, everything has its downsides, and React Rails has some too. It is a great tool, first of all, but the downsides. It hasn't, last time I checked at least, been maintained since July 2020. As far as I know, there aren't any major issues or bugs with it. We haven't faced any, at least. But just keep that in mind so that you have a plan, if you want to move to React Rails, that you have a plan to proceed from there to some other technology, which I'm getting into soon. Because, I mean, you don't want to go to another outdated system. Documentation, it's okay, but not amazing. When you Google or look through the issues, you find solutions to most of your problems. But it's not amazing. I just want to mention that as well. But pretty much is being explained in the docs. And then major downside, I would say, is that there's no code splitting out of the box. Luckily for us at UR, it wasn't a huge app with hundreds of pages or so we didn't really have a big issue with this. But you're just shipping one bundle, and it will become larger over time. So it means, in essence, that you always ship a lot of unused CSS and JavaScript, and your site will be slower over time. Of course, it can be cached and so on, but it means that you're shipping more over the network than you should. And it also means that the browser needs to parse all that JavaScript and CSS unnecessarily. And so this is an example of the start page that I ran a few weeks ago. And as you can see, about 72% of the JavaScript was unused, and about 88% or 87% of the CSS. We were just shipping unnecessarily big amounts of code. And it was more or less the same picture on every page. And of course, you have to mention state and data. And as I said, it wasn't a very complex app. We didn't really need any app-wide state, anything shared. We didn't have a login, for example, for various reasons. But when we needed to have data, when we server-side rendered, we passed all the props from Ruby on Rails into React. And those in turn would be coming from our Rails views, and they would fetch data from our API and the CMS. Sometimes we needed dynamic data. For example, then we used something called a backend for frontend pattern, abbreviated as BFF. You might have heard of that before. And that's how we fetch data in React. And the BFF, in turn, will go to the CMS or to the API and get its data. And let me illustrate with an example. This is in our header. We have the search bar. If you click on the search icon, you will have it expanded and it shows an input. And it's a debounced search with auto suggestions. So let's say we search for our favorite program, Pinot, and it will show us a list of the most popular series and programs matching our query. And of course, that's something you can't really server-side render, so you have to fetch that data dynamically. And that's when we use the BFF. And also, we decided to use the URL as our state, as our single source of truth. The reason being that you can bookmark it, you can share it, you can refresh the page, you can go back and forth in history pretty easily. And the cases when we needed the URL as the state would be mainly on our search result page, because we added all those filters. Let's say we filtered on a specific language or so, we would add it in the URL. And on to the third phase. I said that you might not want to stay too long in React Rails. We had pretty early on saw a need for something like Next.js. It's a great framework. And I should also mention a disclaimer that I'm not part of the team anymore. So this is reported by my colleagues who are still on the team, how they did and why they did migrate to Next.js. So first of all, it has route-based code splitting, which will significantly reduce your load times. So it's great for the user experience, but also for SEO. And as I mentioned, there's about 70 to 90% of unused CSS and JavaScript per page. So we're shipping way less code. And also another great feature, if you haven't used Next.js, is that it prefetches all the links in the viewport, and it makes your app feels like a single page application. There's no flicker. And what happened to us when we had React Rails and React running inside of our Rails app, specifically with that larger bundle size, that the app became pretty slow. It could take a second or two or so for it to render the new page. So you saw actually a white flicker, which wasn't that nice. And of course, it has lazy loading of images, making you load less code than you need, and makes it faster as well. So the different steps of turning to Next.js. First, they created a new repo, a brand new Next.js app. Then they decided to go with the most simple pages. So, for example, there's one, the child lock page, and there the user could set the pin code to make sure that the kids that were using the computer couldn't see inappropriate content. And then they copied the end-to-end tests for that particular page to the new repo. Of course, it would fail because there wasn't any such page implemented. So it's sort of test-driven development with end-to-end tests. And then they copy-pasted the code for that particular page and went through all of the CSS and JavaScript. Because we had done some redesign over the 1.5 to 2 years that it took to do this migration, there was some CSS that wasn't used. And when we started the project, we used class-based components in React. And over time, we started using more and more hooks. And thus, they went through all these classes and turned into hooks instead. And then in Next.js, there's something called get server-side props. It's a method that you can call to call the API or the CMS to get any data that's needed to server-side render your page. And then there's also the -API folder, which is basically an Express app. And through that, we would fetch data dynamically that would previously be fetched from the BFF. For example, I showed you the search input that is doing a deep-bound search with suggestions. That would instead be done through the API folder, which in turn would go to our API or CMS. Then once the whole page would be in Next.js and end-to-end tests were passing, then they did a redirect in the proxy. So any request that would go to /childlock would instead of being directed to the old Rails app, it would be redirected to the Next.js app per route. So I promised to mention some good ways of working. We did a lot of mob programming. This is what it looked like. We had a big screen and a common computer. We shared a keyboard and a mouse. And we frequently also invited our UX and designers and analytics to work with us. Sometimes you might get a design, and it might be that you feel that they didn't think through something, or you see ways to improve it, or things that might not be clear. So that's typically when we invited them to sit with us. And then also you might notice on the right, a big whiteboard that was very useful for our whiteboarding sessions when we had complex issues to solve. You might also notice on the screen, there's an app called Your Mobster that I built on our lab Fridays. And it helps you keep track of whose turn it is and make sure that you rotate every 10 or so minutes. It also adds a break every, well, how often you like it, but we had a break every hour. So we stayed fresh and awake. And if you're not mode programming, you should try it, and you can download Your Mobster as well. And of course, there are some pros and cons with mode programming. One of the pros being knowledge sharing. So instead of having one person that wrote all of the code knowing everything, and then that person leaves, then with mode programming, everybody knows a little bit about how everything works. It also helps facilitate onboarding. So if you have new team members, they won't be in a struggle. They just jump into the mob and start delivering directly. You also don't have to spend time, as I say, ping-ponging pull requests. Typically when you open a pull request, you get some feedback, then you have to wait for some time until that person gets back to you and so on. Sometimes it can take a long time, but when you're mobbing, then you don't have the need for that. So it saves you time in a sense. And also for us, some of my colleagues were great at Ruby on Rails, and some were great at React. And together we could solve most problems, and we had all the skills we needed together. It is, however, a bit frustrating when everybody feels lost, when you have this really strange bug or something that happens very randomly or seldom, and that can be frustrating. In general, also, it can be pretty energy draining to sit together and talk all day long and being focused and being nice to each other. You feel kind of energy drained in the end of the day. And then, in my opinion, some tasks don't really fit for mobbing. For example, pixel pushing or doing some, copy-paste tasks doesn't really feel like it adds a lot of value to sit together, 4 to 6 developers and doing it together. And some other useful ways of working, we decided that if 2 or more people worked on something together and they felt confident about it, that we didn't need a pull request, or we had a pull request, but you didn't need a review. Just save time. And then we decided also that sometimes we needed to add new features. For example, we wanted to add an infinity scroll on our search results page. So instead of doing this evaluation and labbing all together as a team, we went maybe one by one, did some evaluation, did a proof of concept, and then presented it to the rest of the team. And then we agreed on what to choose. We also had some smågodis, which is Swedish for small candy. And it's basically, imagine we're sitting together as a mob, all of our front-end developers, and the experienced team would find something that needed to update the copy, something was wrong, or the font size would be wrong somewhere. They just spotted these small things that you can do in a few minutes or so. They would park it in a column in Jira, or, well, you can use whatever platform you're using to track your tickets. And they would mark it as small candy. And those were the tasks that some days, let's say you were too tired to mob program, or you came in early in the morning, or you're waiting for your tests to pass or build to pass or whatever. Then you could just grab one of these candy tasks and do it by your own. We had a similar concept of dev stories. So for example, sometimes we were working on a feature as a mob and we saw that some component didn't have a lot of tests or enough tests, or we saw some other kind of room for improvement or technical debt. That wasn't really in the scope of what we were working on at the time. So we marked it as a dev story and parked it in the dev story column. And then as well, first of all, if it was a small one, we could grab it again, in the early morning or so, or if you didn't want to mob. But also, instead of just adding to the technical debt, which is what most teams tend to do, we decided to keep on reducing it systematically. So every sprint, we as developers decided which one of them we want to tackle. So every sprint, we just kept on reducing our technical debt all the time. I also recommend that you use a PR template if you don't already. That way you make sure that the time you're not there anymore in the team, that the rest of the team can follow the code and understand why you did certain things or architectural decisions and so on. And also by having a checklist, you can make sure that, first of all, for example, that your site is accessible, that you maybe run, that you add the end-to-end test that runs an accessibility check, or that you try it out with just by navigating with a keyboard. You can also, for example, make sure that you always add tests for new features, that you don't forget it, because, well, we're human, we forget it. And then as well, things just like hygiene factors, like that the tests are passing, that the linter is passing, instead of trying to commit it, and then you wait for it to build. Sometimes CI/CD isn't that quick. And instead of failing 15 minutes later, you can just run it locally quickly, make sure that it passes, and then you know that your build will most likely pass. Also, do follow the Boy or Girl Scout rule, which means that you always leave the campsite nicer than you found it. So if you go through some code and if it's just a quick fix that doesn't belong to the technical debt thing, but it's rather like, for example, that you see a variable name that's unclear, where you could make things more dry, then just do it. And then we did have frequent user tests, and we front-end developers could join in on those as well to get insights into what our users needed and how they perceive things. Because after all, we do love to code, but we don't do this just because of the love of coding. We are coding to solve end user problems, so don't forget about that. And then we did have one design sprint. If you haven't tried it, you should, if you have the need of it, of course. If you don't know what it is, you should Google it. But in essence, for example, the time we had it was when, as I said, we were merging two different sites, the school site for education and the one for the general public. And we needed to make sure that our program page, where you actually watch the show, catered to the needs of both. So the school users, let's say the teachers that needed some teaching material and some other metadata available, we needed to cater to them, but on the same hand, we didn't want to clutter the page with things that aren't useful for the general public. So we gathered around the whole team for a week and worked on this together. The front-end developers, the UX, the designers, copywriters, and made sure that we did a few prototypes, clickable ones, and tested them on real users to get their insights and to determine if we were solving their problems. Finally, some takeaways and resources. First of all, start with your end-to-end tests. You will feel way more confident when you start removing things. You know that everything works as expected. And there's not only end-to-end tests, we did have a lot of unit tests as well in TypeScript. And even though you have a plan in the beginning, you will do some refactoring and moving things around. And when you have that in place, then you know nothing gets lost in the way. You know you always pass the props that you need and so on. Also, to avoid the problem we had in the beginning with IDs and CSS classes being used for everything, be very explicit. Like CSS class names should only be used for styling. And then you use data dash whatever instead of IDs. So for example, if it's tracking, you add data dash track or TRK or whatever you agree with in the team and with your analytics people. For end-to-end tests, you add data dash E2E and whatever. That way you know that if you want to remove a piece of code, you know what it's being used for and who to ask. If it says data dash track, then you can ask your analytics team if they are still using it or not. If you don't already, then do use a CSS constants file. where you declare all of your colors, font sizes, and so on. And we had one, but it wasn't always used. So we found a lot of variations on our headers. We found about 50 shades of gray and a lot of mismatch. So it wasn't always consistent. So this way, first of all, you have consistency. It gives a much more professional look of your site when it's consistent. But also the day when you want to change your theme, you just do it in one place and it will hit everywhere. So it's way easier. And also do take this time to go through your media queries and colors. We found a lot that wasn't used anymore, but also our media queries didn't really make sense. We had, I believe, a dozen or so, and they didn't always play nicely together. So some would be up to a certain breakpoint and some would be below a certain breakpoint. And it didn't really play nicely together. So instead, go through your design system, make sure that it's consistent, and do it well from the beginning. Then do have reuse in mind. Of course, you can't plan for everything, but make sure to think out your components, how you structure them, and so on, that you can reuse them. For example, when I showed you the drop-downs in the search results page, that we could just reuse the same component for different drop-downs, and we had the tests and all that already set up. So in the beginning, it took us quite a lot of time mobbing all of these little components, but once they were in React, it was way easier to scaffold an entirely new page in React. So it went way faster over time. And only add things when it's needed. For example, we didn't go for Redux because we didn't see a need for it, but a lot of times you see a lot of templates and so on that features all the bells and whistles. And in the end, you're just shipping more code than you need to. And you're also adding complexity where it's not really needed. I mean, you don't want to add too much of a learning curve to newcomers to your project. And speaking of Redux and state management, please only, if possible, handle your state in a single way. I worked in a project where there was Redux, there was MobX, there was session storage, and there was even the URL being used as a state, and it was being modified with jQuery. You can imagine that it was a mess. It wasn't nice to work with. You couldn't really do time travel, debugging. You didn't know what you had in state and where you had it. So if possible, please just use it in one single way. It will make your life way easier. And do try mob programming if you have enough people on your team. Do that. You'll have way better knowledge sharing. You mitigate the bust factor. So if someone leaves the team for whatever reason, then people can still work on it and understand why things are being made and so on, instead of just one person keeping all the knowledge in their own head. Also, by doing it this way with component by component, we avoided this big bang release that will probably just be delayed and delayed because, well, things are never ready. No software is ever completely done after all. So this way we managed to continuously ship improvements, new design, new feature to our users, instead of having the site locked down for a few months and having them wait for it. And then, very importantly, don't forget to collaborate across disciplines. People tend to think in waterfalls or making assumptions. When you don't know or you don't understand how your sketch should be implemented or how they thought about it, invite them. Make sure to ask them. That's something we do a lot. We work across different disciplines, and that's when you deliver the best solutions for your users. After all, don't forget that they're who you're building your site for. So I mentioned I'll share some resources. My slides will be available for download. Here are some of the technologies that I've mentioned during this talk. And that's about it. My email is right here. If you want to ask me any questions or give me any feedback, welcome it. Feel free to reach out. I hope that you've learned something new today. And that's it. Thank you very much.
Wonderful. A big, big thank you to André. And now, before we move on to our Q&A, I have to tell you about something very exciting, which in my opinion is the best announcement of today. I hinted at it earlier. I'm excited to announce our next flash prize for today. And can you guess what it's for? It's for Vue, which I'm organizing. So this summit is dedicated to an amazing and powerful framework, which is Vue.js. Join us to discover endless possibilities of simple components. There are lots of working recipes and best practices that can inspire you to create your own to create your complex and highly performative systems. That's why we've gathered the most powerful Vue.js speakers to share their insights and provide the latest knowledge on Vue.js product creation. There will be over 35 front-end development gurus from Amazon, AWS, IBM, Accenture, Microsoft, Philips, and so many other innovative businesses. And they are all ready to share their experience of using the unlimited possibilities in your projects. So today you can save your spot at an amazing price of just $99. You can get one of 20 tickets at a discounted price. We are actually having a price up in a couple of days. But this, if you use this QR code or the link that's here on screen, use the promo code and grab your tickets. So that was great. I'm always happy to talk about my event. And so time for the Q&A. So with us, we're going to have Håkon, we're going to have Clement, and we're going to have Josh. So because, oh, they're all here. Okay, so let's get them up on screen. Hello. Hi, everyone. Hi.
Hello.
Hello.
So I am saying this not so much to you or the audience. I'm saying this out loud, sort of to myself, so I can hold myself accountable. We have to finish at exactly 1:40 my time, because the link will change, and we have to end this broadcast and switch over to the other link. So I'm just saying that to hold myself accountable. My technical support over there, he's also aware. So let's get cracking. So questions usually take a couple of minutes to roll in. So I will start with some of my questions. So let's do a question for, who wants to go first? I'm so sorry. It's almost 2 a.m. I'm getting loopy. Like I'm trying to focus. Okay, let's start with Josh. Josh, if I have a website, how should I start off investigating its performance?
Great question. I was going to suggest eeny, meeny, miny, mo to figure out who goes first, but this works too. Pop that sucker into the Chrome DevTools or the DevTools you prefer, and check out the network or performance tabs. Maybe run a Lighthouse audit, which is something I didn't show in my talk, but others did. Lighthouse is a fantastic tool. Yay, thank you. I think there are a few common problems that a lot of sites face, like not server-side rendering at all, or having some really, really big script load and block the page. So if you can check for one of the really big issues that tend to be common, that oftentimes will give you a really nice benefit.
Good answer. Like I said to the other speakers at the last Q&A, if anyone ever wants to contribute something to what another person, to a question that another person just answered, feel free. The more discussions we have, the better. So, okay, question for Clement. What is your biggest takeaway from building containers? Also, one final thing, I'll stop talking, because we have quite a lot of time on our hands. No rush. Everybody, please take your time. Go as deep into the question as you'd like. So no need to rush.
Okay. So for me, there are actually two really big takeaways for me. One of them was documentation, and the other one was building extension points. As for the part of documentation, basically when you're building a new library, a new system that you want other people in your company to adopt, or even in the open source world, documentation is of paramount importance. If you don't have good docs, people aren't going to use your stuff. And even if they do use your stuff, maybe bad practices will form. They won't use it the way that you intend them to. So documentation really helps like convey the motivation behind what you're building. And then secondly is the idea of building extension points. Generally, like a system like containers is a very high friction system to like switch to. Or for example, like even like in the open source line, like for example, if you have a code base in JavaScript and you want to migrate to TypeScript, generally you're going to start a new project in TypeScript, but you're not going to take one giant code base and migrate all in one step. So you'll need ways to kind of slowly do this in an iterative process, and building extension points, allowing developers to do custom things to like slowly bring in your system is like the way to go.
Amazing. Thank you. Okay, let's do a question for Håkon. Why do React on the server if you're not going to ship it into the browser? Why not just use Eleventhly or something else that generates plain HTML plus CSS?
Yeah, that's a very good question. And it's something we sometimes wonder if we should move to as well. But the reality is that we love React, honestly. It's a wonderful way of composing UIs. And looking at other frameworks, we would rather not do that, because even though it's just going to be on the server, we still love it. And at the end, I was noting, yeah, exactly. I mean, we do have this hybrid approach that we don't do React on the client on some pages, but on some other ones we do. And just having that flexibility is really awesome, because that allows us to do some pages in a really strict manner with vanilla.js, React on the server, nothing on the client. And then other pages, we go fully fledged React all the way. And having that flexibility it's really awesome. So I don't think we will switch to something like Eleventhly or something else. Although we have some people on on the team that would like to try it out, myself included.
Well, there's always the option. Wonderful, thank you. So, Josh, I find this question quite interesting. What are some surprises you've had investigating performance?
I think when I was really new to setting up websites, I was surprised that whether you use a for in versus a for each versus a for I equals doesn't matter 99.9% of the time. And then one time it did matter, which was horrifying to me. I've set up pages to lazy load sections. Like if there's a big landing page, I would have part of the page below the fold, referring to the fold is where you might not see below your monitor, lazy load, and then that actually hurt performance because it caused an extra browser render. So that was surprising and also horrifying. Lastly, we ran an experiment on the Codecademy homepage once where we removed about half of the content for being redundant and not necessary. It was an intentional experiment. We didn't just like willy-nilly remove half the stuff. It was in collaboration with design. And we saw that the click-through rate on the homepage increased by something like 10%, I think. And then the click-through rate on the subsequent pages decreased by roughly the same 10%, which was really annoying. We got all excited about the improvement and then annoyed at the not improvement. But then I think the conclusion was that sometimes performance isn't actually the core metric you should be after. The assumption we're making was that people who just skip through the homepage willy-nilly later on got churned out of the funnel, meaning later on they would have just not stuck through anyway. So although performance is really important, things like good marketing, solid brands, like evocative quotes and user stories are also really important for the site experience.
I have a question here, actually. So did you ever have a time where you had to sacrifice code quality in order to improve your performance? And then, like, if there is an example, like, how do you kind of mitigate, like, I guess, code quality loss or deal with the situation?
I do have a situation, actually, and it involves React. It doesn't involve JSX fragments, though, that I've been trying to weasel in a snarky question about. Love fragments. So React server components are really cool. It's this thing that React team is working on that's not yet widely available or recommended for stable production use, but is looking like it's going to make it really nice for streaming live HTML from the server. We have a pretty standard monolith Ruby on Rails application for most of our website. It's not set up in Next. We're moving it to Next soon /now. And we have these big article pages where you might see like codecademy.com/learn/accessibility in the browser or something like that. And then we, like many websites, print out the JSON props on the page. So if the article is 9,001 sentences and a lot of images, then the JSON props include a lot of text. So I was trying to, we got this really hacky thing to work where we like do this terrible update mechanism where the server has the props but then doesn't print them on the page, and then the client just uses the HTML given to it by the server. And it was nice for performance, but just garbage code quality, like really, really bad. It was basically doing what React Server Components is supposed to do, but from the outside of React. So it was not set up for success. So we got rid of it. I don't have any examples that lived long for sacrificing code quality for performance. Do you? Either of you?
Let me get back to you on that. But I mean, none specifically comes to mind right now. But I think a cool example of this in open source land, I guess I actually just learned about like things like D and Snowpack recently, where you rewrite parts of, I guess, the compiler in Go. But I can't really speak to what the code quality in that looks like. But I'm sure they're amazing.
Amazing. Thank you. Håkon, would you like to add anything?
Yeah, I thought I might. Because we're being real pragmatic at Crystallize when it comes to what we ship. And code quality is something we value much in our product, a whole lot. And not necessarily as much when it comes to our website, because then that doesn't matter as much as for the rest of the stuff. So yeah, I think our website is truly a testament of how you can ship something wonderful to a customer that performs like nothing before, and the quality is like, it's okay. It's not bad, but it's a mix of both both worlds. You got really cool React stuff using really fancy stuff on some pages, and on other ones they're totally different land. So I think that's if you're looking for that, just check the source code of a few of our pages, like the front page, for instance, is a good example.
Yeah, I think actually, like thinking back about it a bit more, I said I'll get back to you. I think this question was partially motivated not by performance issues, but more like the fact that sometimes I had very extreme product requirements, like tons of animations, tons of things going on the page, and I was like, oh, in order to support this, our infra and frameworks and libraries don't really support it. I'll need to get a little bit hacky in here. So I go in, support some crazy experience that product managers love, design loves, users probably love. But then I look at it like a few months later, and I'm like, holy crap, I don't know what to do here anymore. Like I can't touch this code. So and I think we still kind of have that problem. Like I guess that code just becomes legacy, never touch this again. And I was curious about how other people kind of deal with this problem. Until the eventual rewrite happens.
Thank you. So actually, I want to say something very quickly to the audience. It would make my life so much easier if you could @ the person that your question is for or aimed at. That would be amazing, please. Having said that, here's a question which I'm not 100% sure who it's aimed at, but Astro is a new React/Vue/Angular solution that can render React at build time or at runtime or combinations of both. I'm not sure if that's a comment or a question.
I guess just as a comment.
Okay, well, Phil, thank you for sharing your opinion. If you want to learn more about Vue, I am organizing a summit. So come to my Vue summit and we can talk about this. Thank you. Okay, not a question. Okay, let's do a question for Clement. Clement, how would you test a system like containers?
So as with any system, I would just look at all the different components that compose the system and test each part of it, right? So in containers, we have 3 different sections: the Vue orchestrator, the what's it called, the component renderer, and also well, I am blanking out right now. Yeah, view orchestrator on
Don't worry.
View orchestrator, yeah, and the data gateway. So sorry, let me rephrase that. View component renderer, view orchestrator, and data gateway. So number one, on the component renderer side, you would want to have like tests like snapshot testing, make sure that all your renderers render the types that they should render properly. And we also want to see how those different types interact with each other. Like, because the component renderer also has the responsibility of doing layouts. We also just want to combine different permutations and combinations of different sections for it to render and see what happens. To try on different native devices, different screen sizes, check for accessibility, all that stuff. And then you also want to do the idea of so that's the idea of a unit test, and you would basically unit test all three of those systems. But then you also have the idea of now when product engineers decide to use the system, they would want integration tests that kind of test their functionality, their page that they build with containers from end to end. So for example, when they create their configuration, what exactly gets rendered given a specific set of data points that the users have? Can we do eligibility tests? And so just give the capability to test those things. And then finally, you also want the ability to do manual testing. So for like the part where like after you do your automated testing, you write your tests, and then we can basically run those every time someone ships a new page or something. But now when you do, before you ship an actual experience, you might want to have quality engineers sign off on what the experience looks like. And you want to give them the ability to have manual tools to update their data points, update eligibility, and just really see the product and experience in a bunch of different ways, and just really like hack at it that your automated test might not catch.
Wonderful, thank you. So Phil followed up his comment with a question, which is, what are your thoughts on Astro or component islands?
I can have a quick comment on this, because after I saw his comment, I quickly searched for it. Like because I've seen the name before, Astro, and I do see it now. It's a very early stage library, similar to Next, Gatsby, and the similar that really promotes that sort of thin layer of client side library, heavily focused on performance, which I love. And it's definitely worth a look once it's out of. It's not even on alpha mode. It's on. I haven't seen this before. It's on shh mode. I don't know what that means. But the whole idea of promoting client-side performance that way, I love that idea. I love the idea. Obviously, this is the promise of server components too, like the partial rehydration of the application. I'm excited just to see all of these ideas coming through. This is what end users want, and as a developer myself, I would love the idea to have a tool I can just use to get this out of the box. And that's what we need in the end. We need the tooling to solve these issues that we're facing. So that's pretty much it. It looks cool. I love to get an early version and try that.
Amazing, thank you. Let's do a question for Josh. Josh, how do you find out about bugs on your web page?
A few different strategies. Definitely having a good set of unit end-to-end integration, whatever your team wants to call the different variants, is a great idea. So you don't want to ship bugs if possible. So set up a CI/CD workflow that makes sure on every pull request, or whatever your situation calls it, you do run a set of tests. But some bugs are inevitable, even with static analysis, dynamic analysis, all that stuff. Having a good error reporting dashboard is always really nice. We use Datadog. I highly recommend them. We switched from New Relic recently because New Relic's UI is kind of annoying and doesn't give a lot of information out of the box. Datadog gives us these nice little graphs about these are the top client crashes. These are the crashes introduced since the last update. And then you can use a library like a service like LogRocket or FullStory, which will capture all your users' data. I think that's incredibly creepy that you might record everything a user does in your site, but it's also so freaking useful for debugging errors. Like they'll automatically find when users rage quit, or like they'll correlate different page visits to different crashes. So, you know, depends on your moral compass. And lastly, having a good customer support team, people who can be talked to by learners, having an actual Zendesk set up where people can live email rather than just having, I don't know, an email that people sometimes respond to is really good. A Twitter support page or an account on Twitter that's active is really great too.
Amazing. That's really, really good advice. Good points. Thank you. Let's do a question for Håkon. Is there risk for new kinds of bugs with this approach? You're on mute. No.
Yes.
There we go.
Yes.
Sorry,
Of course,
Håkon,
yeah.
go ahead.
No, yeah. So there's definitely risks of introducing bugs for sure, because we're doing things in two different ways. Vanilla.js on one side, framework side on the other side. So yeah, one bug could be like you're having a use effect or use state on your components, but since you're not shipping the JS, that's not going to be executed, and you're going to be scratching your head for weeks figuring out why that doesn't happen. And that's going to happen if you're a new developer on this project, and sort of not be giving the introduction in advance. So yeah, it's definitely a consideration you have to take, to do, because you have to look at your project and look at who's going to be working at it and figure out if this is a valid strategy for you and your team, essentially.
Mm-hmm. Great, thank you. Clement, question for you. Should I always go with the view-centric GraphQL API instead of a data-centric GraphQL API?
Yeah, so I think that this really depends on what your app is, and you gotta really consider the trade-offs. The benefits of a view-centric API are that you can dedupe your client logic, your application logic, and move that all into your GraphQL resolver layer instead of repeating it in the clients, in your native clients, in your web client. But however, because of this, you also end up with that sacrifice of having more granular and fine-grained interactions on the client side. Like, for example, there's only so much that you can define on the server side. You have to accommodate for, like, generally it will only accommodate such a subset of all the cases that can be supported. So if you want granular experiences, things that are novel, unbuilt, I would go with the data-centric API for these kinds of more exploratory things.
Good answer, thank you. Josh, do you have any tips for writing fast React components?
I do. I also want to note, Clement, I really appreciate the answer you just gave. We've started playing with a component-centric page generator. It's a much simpler version, very, very less well-featured or thought out. But it's really nice to just be able, as an engineer, to say, I want these things, and then the page is built. It doesn't even use GraphQL. It's just there's a contentful, like a CMS entry for what the page should look like, and then it's auto-generated from our design system. So, yay, good stuff.
Backend driven UI.
Yeah. But to actually answer the question I was just asked, I think most of the time it's about the page architecture. It doesn't matter too much if you have a list of 20 elements and sometimes the list all re-renders. Like, that's not great, but a single millisecond of time in JavaScript can accomplish quite a few re-renders or page changes. So to start, I think my slide on try to design with architecture in mind and not sweat the small stuff until you notice it is generally good. If you do start to observe things, I highly recommend try the React Profiler. It's a set of dev tools on Chromium and Firefox browsers that are really good for showing you where the components are instantly re-rendering. Most of the time when there's a re-render that I've seen, it's because someone was passing a callback and it was generated as an inline Lambda. Or failing that, there was just generally an object created inline that was passed through at the root level and then got pilfered down to child components. At that point, you might consider using something like Redux or Recoil or MobX. Love MobX. I wish it was more popular. To try to optimize your performance based off your data needs. Lastly, if you have a situation that's really common, like a big list of a lot of items, there's probably a library written for that already, like a virtualized list library. There are a bajillion of those. You can probably find one that suits your needs really well. That's all.
Great. Thank you. So, Håkon, question for you. Are Crystallize the only ones with this approach on the web?
No, we're not the only ones, and we're not the first. If you turn back time 3-4 years, Netflix was advocating the same thing for their own website. They might still be running it. So they were the first one trying it out. And there's plenty of other ones doing it as well. Can't really mention more on the top of my head, but no, we're not alone.
Okay. Clement, this is, I think, in my opinion, quite an open question, but should I use containers in my company?
Oh, okay. So I think this is like along the theme of like things I described earlier in terms of it's all about trade-offs, and you know, depending on your company product, there's going to be like outcome depend on what you value the company. And to recap this, if you want to have an infrastructure that will support shipping very quickly, the product that your company has is something that is very like data driven. You have a lot of read-only UIs, and you want to just display and format like information to a user. So something like Credit Karma fits this use case, then I would recommend containers. If your company's products specialize a lot more in like very complex user like interactive experiences, so for example, something like, let's say, I don't know, Discord, for example, right? Or like Airtable, something where you're doing a lot of drag and drop, lots of interactive things, are updating a lot of different things on the page, then I don't think containers will be a good use case fit here.
Great, thank you. Håkon, let's come back to you. Would this approach work for any website? Which ones does it not work for?
In theory, yeah, it works for any website, but again, you would have to carefully consider if you want this approach or not. I would argue that this is an approach that would that you might consider if you have a site that needs to have the best performance possible. You do sacrifice a bit of developer experience for it. You do set yourself up for a bit of risk in terms of bugs. But in terms of performance, there's just nothing beating it. And still, if you want this hybrid approach, this is the way to go. If you want to go totally crazy and totally vanilla all the way, then something like Levity would be a good fit. You could have a look at Astro, mentioned in the comments here, which is promising to be a kinder version of Next or something in terms of client-side performance and rehydration. But in theory, you could apply to any kind of site, yes, but it needs to be the proper one. I'd say needs. I mean, our marketing site is the perfect example of sites that suits this kind of approach.
Amazing, thank you. Let's do a couple of last questions. So, Josh, can TypeScript help? Can TypeScript help with these bugs or performance?
Yes, love TypeScript. Strong +1. TypeScript's really good at helping you define your data. So even if you don't catch any bugs with it, if it doesn't show you that you're using the wrong method names or something, it's really nice having a standardized way to describe the shapes of things, whether they're auto-generated or ad hoc written bespoke APIs. TypeScript can definitely help you out there. I'll also say sometimes the advantage of TypeScript isn't just the being able to look at your code and analyze it, it's the integrations. If you use anything like ESLint, static analysis on your code, being able to run TypeScript ESLint and have really powerful rules that can, say, catch floating promises or enforce deprecated APIs not be used with TypeScript type information is very clutch. But I've also caught bugs in my own code by running TypeScript or seeing from TypeScript that, yeah, like I'd used a React API in the wrong way and was forgetting to pass a function or not passing an array when I should have, which was quite nice.
Yeah, plus one to that, TypeScript has changed my life.
Great, thank you. So I'd say that was probably the last question for Josh. We'll do one more for Clement, one more for Håkon. So Clement, how does this differ from something like React Native?
Yeah, very, very good question. And so I think at the core of it, they solve two kind of different problems. And like, so React Native itself solves the cross-platform requirement, but it doesn't really solve the code duplication issue or the inconsistent styles issue, right? So like in the entire containers ecosystem, one might say that maybe like React Native can be actually incorporated into the solution. Maybe it could be part of the actual like web, like the component renderer portion of it. But I'll say that containers as a whole solves like a different issue, and React Native is just the view layer of it, and something that we can totally incorporate into our system, for example.
Thank you. And then to wrap things up, last question. Can you guess who it's aimed at? Let's go. So, what kind of skill set is required from a developer to make and maintain a site like this?
Oh, yeah. Well, you need to be in control of your, web primitives. You need to know how to traverse the DOM without using React, and you need to know how to, well, it's sort of back to basic, back to when I started pre-jQuery days. You're out in the wild, define your own script tags, figure out how to load them, figure out how to load them across page navigations. It does require a bit more knowledge of the natives, like the web natives. But then again, I would also argue that those are skill sets really worth having anyways. It will help you a lot in your everyday work in the frameworks too.
Great. Thank you all so much for both your speeches and the Q&A. I've noticed the way I was at the beginning 6 hours ago is very different to how I am now. I wish we had met in a different time zone or a couple of hours earlier, but I had such a wonderful time with all of you. Thank you all so much for all of your hard work. I'm sure Anna has thanked you already, but I want to thank you as well. It's been a pleasure spending time with you, and see you later, guys.
Have a wonderful Tuesday.
Cheers. Thanks for having us.
Bye. So, the time has come for me to say goodbye. I will like to remind you that the link will be changing. So we will be ending this broadcast and starting a new link. So, like I said, time for me to say goodbye. The time has just flown by so quickly. I've had so much fun today. Both Q&As were very engaging. The speakers were very interesting. I feel like I got very lucky with my moderation shift today. It's been an absolute pleasure to accompany both the speakers and the attendees today. Thank you to our organizer, Anna, for asking me to moderate. She knows how much I enjoy it. Thank you to everyone watching. We all feel your love and support and really appreciate you taking the time out of your day to be here. I hope you're all very excited for the remaining 11 or 12 hours of the summit. I hope that everything you learned today will help you all grow and develop both personally and professionally. And I will see you later.